me? All right, good morning. Welcome to the Network Digital GreenTech Konferenz 2025. To start, just a couple of housekeeping details. You might have already seen, well, this is obviously for the people here in the room, not the people online. There is water and coffee in the hall outside. Everyone online will have to get coffee in their kitchen. There's also snacks outside, and just so you don't miss it, if you walk towards the coat check, there's another room with snacks. Those are also available to you down the hall. The Wi-Fi code is Invalidenpark_0625, Invalidenpark_0625. And then if you're needing a conference program, you will see that there are QR codes on the wall to download that. So enough details about that. We're here today to look at research projects that aim to develop more sustainable solutions at the intersection of digitalization and environmental technology in the areas, of course, of water management, sustainable land management, geotechnology, as well as resource efficiency and, of course, the circular economy. So today and tomorrow we'll be learning about the results of 14 very interesting research projects, and most importantly, we'll be discussing how we use these results to transfer them to political, economic, and social action. So we're excited for a huge transfer of ideas, perspectives, of results, and maybe even a bit of musical taste, because there will be a music quiz later, so just to warn you ahead of time about that. Now, as for who is the strange American lady on the stage, my name is Christy Platzen. I'm a journalist with Deutsche Welle. I cover business and economy topics, and I'm very happy to be with you today and tomorrow. Also personally for myself, to hear what's been going on in your research fields and maybe get some new ideas of stories to look into. So if you do have something you've been dying to tell the press, feel free to grab me on the sidelines for any hot news stories. So enough about me. I would now like to welcome Dr. Rainer Müssner to the stage. He is the scientific officer at the Federal Ministry of Research, Technology and Space. And he's very enthusiastic to talk to us not just about digitalization and sustainability, but to find and promote concrete solutions. Let's give him a round of applause.
Good morning, everybody, and a very warm welcome from the cold Berlin. It's around 0 degrees here in Berlin. Particularly important to those of us that join us virtually in the stream today. But of course, warm welcome to those that are here this morning and to those that are following us in the stream. Thank you very much for the nice introduction, Ms. Platzen. And I'd like to give you a very short and brief overview about what is the motivation of our ministry, the Ministry for Research, Technology and Space. Why do we fund initiatives like Digital GreenTech here today? And what are our expectations from a ministry when we look at the projects or the project results? And as you can imagine, the perspective and the view on a project from a ministerial perspective differs quite a lot from a PhD or from a postdoctoral researcher. What's very important is to understand that a ministry is a ministry and not a research funding organization. DFG in Germany is a research funding organization, but a ministry, an entity like a ministry, is meant to perform policies. At the very end of the day, the money we're using in the projects and in the programs is taxpayers' monies. So we have to stay accountable to the taxpayer. And it's not Mr. Müssner or my hierarchy who decides on where we spend the money. Ultimately, it's the Parliament and the parliamentarians in Germany that decide where they want to spend money. So it's very important to understand from a ministerial perspective, every project and every program like Digital GreenTech is embedded in a policy. The two policies that are most relevant for Digital GreenTech are Research for Sustainability, the abbreviation is FONA, a very long-running program in our department. The department is called Department for Sustainability. Our division is the Division for Circular Economy, Resources and Geoscience. And FONA FONA strives to give new impulses to sustainability, to go forward with sustainability research in climate, in water, in energy supply, in smart mobility, to go forward in these areas with research and set new impulses for policy for society. The other cornerstone behind Digital GreenTech is rather brand new. It's a so-called high-tech agenda for Germany. So high-tech agenda Germany. And high-tech agenda Germany follows a completely different philosophy than the philosophy of research for sustainability. The high-tech agenda for Germany strives to increase the, strives to increase the competitiveness of Germany as a hub for science and industry. And as you can see clearly, this is a complete different direction. So the challenge today is to find the right middle way between making impact on sustainability and making an impact and growth and jobs and wealth of Germany. So there's a certain dualism that we have to take into account here. So how to strengthen Germany as a science and as an industry hub. Our government recently, let's say 6 months ago, decided that this high-tech agenda for Germany, that is not only high-tech agenda of our ministry, it's a high-tech agenda of the whole government, I have to say, including the other ministries, has a particular focus on 6 key technologies. These key technologies include microelectronics, robotics, AI, quantum technology, etc. And with the 6 key technologies comes along 5 strategic research areas where sustainability research is one of it. And this dualism is, of course, visible, or let's say mirrored, in Digital GreenTech, because all of you know from your projects that you have project partners that come from the digital side, let's say. They are specialists in data science, AI, robotics. Yesterday we had the kickoff of our robotics projects. And communication between those that work in the key sectors, let's say, and those that come more from the sustainability side, let's say circular economy, waste treatment, water treatment, environmental monitoring, you name it. So the sessions we have during the day, they have a different philosophy, but the added value, what we as a ministry expect from Digital GreenTech is that it's able to merge these 2 worlds in Digital GreenTech. To build a bridge, it was framed to build a bridge between 2 domains to pave the road to sustainability using the tools of the 21st century. It's a nice sentence, I think. Somebody wrote it up for me here on this, on the sheets. With this brief introduction, so why is BMFTR funding initiative that Digital GreenTech? We are funding it since 5 years, more than 30 projects all in all, and we spent more than 30 million euro, not BMFTR money, but taxpayers' money, as I said, in this issue. I guess it's a very promising field, and it's very important that each of your projects have a clear focus on 2 things. So one thing that is very close to my heart is transfer. It's a good thing for scientists to make nice publications. It's a good thing if you get your PhD or master's degree. Perfect, well done. But from a ministry's perspective, we are looking for impact for end users, for people that use your tools, your devices, for companies, SMEs, startups, or big industry like Siemens that say, okay, that's a smart solution. I like to test it or to use it as a business case. Because, here again, environmental green tech is big business. In Germany alone, we have growth rates between 6 to 7% in this sector. We have more than 3.6 million people employed in Germany, only in Germany, and I'm not speaking about the world and Germany as an export nation. So striving to strengthen the competitiveness of Germany, one road to explore is definitely digital green tech or environmental technologies. That's a message I like to convey to all of you. Secondly, transfer is not an end in itself. You do transfer your results, your products, your devices, your service to somebody to use it. And only when you come to a level, to a high TRL level, or to the level where a customer, a real customer or a market position says, oh, that's really interesting, I want to buy it, I want to develop it further, then you create impact. And that's what is very important, the second message here. Try to do your very best to create impact. What we see today and tomorrow with the projects you will hear about, hopefully gives you a glimpse or an idea what is meant with impact. We have a very interesting audience and a lot of interesting speakers today and tomorrow. Every section where project participants or coordinators present their results and what they consider impact is followed by a hopefully lively discussion of experts about the issue of transfer. And this structure, let's say, is done on purpose and not by coincidence. We have a discussion here, and I'd like to invite all of you being here in the room or following us on the stream on the internet to take actively part in this discussion. Some presentations, some are very good, some are only good, but what is more important at the very end of the day is that we have a good discussion of what is meant with transfer and impact. And after all, enjoying the day today and tomorrow. So thank you very much for allowing me to give this brief introduction, and hope to see you during the day in the coffee break. Everybody free to contact me to give a chat. And now the advertising block. Please keep in mind we have a very interesting element of our two-day conference, the Digital Green Talents event, who's taking place in the afternoon today. We have two outstanding points I'd like to address, and then I close really, is we have a sister initiative from the Ministry for Economic Affairs. It's the innovation competition, and we're looking very much forward to hear from our colleagues from the Ministry for Economic Affairs how they are addressing the issue of environmental innovation. And after all, the baseline today is the projects, of course. But Digital Green Tech is a funding scheme to fund project, and the real sister initiative we are doing is the Digital Green Talents. I know a lot of the Digital Green Talents is here are already watching us virtually. Please feel very welcome, please feel invited, and I'm looking very much forward to the ceremony this afternoon to select the new Digital Green Talents 2025. International outstanding people, I can tell you. Thank you very much, and a very good event today. Thank you.
So, thank you, Dr. Müssner. So we're also here today to celebrate the launch of the first Digital GreenTech online magazine. So all of the projects here today contributed with their own stories and insights, and were able to put together a very well-rounded magazine, which Paul Reinhold from the German Informatics Society created. And Mr. Reinhold will introduce that to us now. Let's see, can you join us then on stage? Yeah, all right, a round of applause for him. Yeah, thank you.
Hello, I'm very excited to present you the following project that got published today. For those who don't know me, my name is Paul Reinhold. I work at Gesellschaft für Informatik, partially at Digital GreenTech, and partially at our editorial department. Today I want to present you Digital GreenTech. which is the only magazine for Digital GreenTech. It is a magazine published only once, and it is available online now. You may wonder, Digital GreenTech has a conference. We have a website, we have a podcast, we have a newsletter, we have multiple social media channels, a webinar, and we visit other festivals to represent Digital GreenTech. So why do we need a magazine now? We wanted to present the projects in a different way than just giving everyone the same category or the same layout, or just creating 14 articles or interviews. And we wanted to create these different categories that I will present you in a bit, and most importantly, we wanted to make this fun. Another idea behind this magazine is that it was important for us to not only reach people who already know a lot about green tech, we also wanted to reach people who may have never heard of our topics before. And that is why this magazine, you won't just find articles about every project or 14 interviews, you will also find a collection of very different types of representations of the projects. We have interviews that are short but tell you everything you need to know about the projects. We have the next foil, you can see a comic strip, you can see a card of Germany that tells you about the different circumstances of the projects, and an online quiz where you can test your knowledge and much more. A personal highlight is the category Und sonst so, which means and what else. A research project thrives on the teams that drive it forward. But what motivates these people? In the and what else section, we ask them questions that also provide insight beyond their project work. For example, you can learn about their favorite books that then inspired them to become a researcher, or about the most important item on their desktop, which also got a lot of interesting answers, or what they wanted to become if not a researcher. I'm very happy to announce that each project will be featured in the magazine, and each project has helped to make the magazine become a reality. So thank you to all the projects who have helped us. I think that deserves an applause. I also want to thank a lot of people who've helped to create this project. I want to thank Anne Gunkel and Saskia Ziemann from PTKA, and my colleagues Alexandra Resch, Friederike Bark, Stella Drebber, Nicolas Becker, Elena Müller, Teresa Zeck, Maja Denisova, Sven Lubenau, and Oliver Pfaff. I think that also deserves an applause. I know it's a long list, but it shows how many people have created this magazine. And you can read the magazine at digitalgreentech.de/magazine, or simply scan this QR code. You will also find the address on the postcards on your seats, which also have a lot of interesting quotes already from the magazine. And now I hope that you enjoy the rest of the Digital GreenTech Konferenz. You now have plenty of reading material for the breaks or your journey back home. Thank you.
So, thanks, Paul. So now we can dive into the results of the research. We have a lot to get through in the next 2 days, so we will be doing parallel sessions. So our groups are going to split up now. The topic of water management will be in room ARA. That's the room we're in right now, so stay here if you're with this project or want to see this topic with the projects Agents 42 Water Markets, DIWA, and YOLE. And then at the same time, just across the hall, through the door, we will cover the topic Circular Economy in Room Conrad. And this is with the projects Reduce, Sorek, and Kimba. And this session will be moderated by my colleague Christoph Kempschel. So please choose a topic, and let's move directly, or either stay or move directly to the room, and then we can get started. So thank you. So, welcome to our first session. Just to explain how this is going to go, first the project results will be presented by the project leads. They each have exactly 12 minutes for the presentation, and afterwards there will be a short time slot for you to ask any follow-up questions. We have 3 presentations. Once the 3 presentations are over, we will then have a discussion together with our experts, focusing on how we can take these results and apply them to the real world. So to start telling us how a multi-agent approach can achieve efficient water distribution, I'd like to welcome Katharina Henn from Agent 42 Water Markets to the stage. Katharina.
So now the pointer is actually gone.
We have some technical difficulties with the pointer.
Okay.
So is it all right for you if we click the...
Yeah, I'll give you a sign. Yeah, let's try. Okay, so thank you for the introduction, and I'm going to present the results from a project with a complicated name. It's actually Agents 42 Water Markets. And I want to start first of all with giving the definition of our understanding of an agent. So we can go to the next slide, please. Exactly, perfect, thank you. So agents might be a strange term. In social science, it's actually used for referring to humans acting in a complex social systems, but it's also a term used in computer science when referring to autonomous entities. And we think of controllers and edge devices as being agents. And as has been mentioned, we want to make the future water infrastructure fair, efficient, and resilient using this multi-agent approach. And I am going to present you how we address these objectives in our project. So first of all, let's look at the efficiency. Okay, that's somehow messed up, but we will manage. So for the first part, we looked at water distribution networks, and this is a rather generic one, and it's inspired by our project partner, Rhein Energie. And here we have agents controlling the pumping stations in the network, and these agents are operating variable speed pumps. So pressure head and power consumption of these pumps is both a function of the rotational speed of these networks. And in the back of the network, you can see buffer tanks, which are able to store a certain amount of water. When you describe such a system with mathematical formula and you define an objective function, you end up with a so-called pump scheduling problem, rather complex, as you can see. And you can solve it using Python toolbox like Casali, for example. And what we aim to do here is to minimize the power consumption over the course of a day in such a system. And I show you some results. So we looked at a benchmark case where we used a rather traditional control strategy where the tank level in these buffer tanks is kept constant, and you see you need quite a big amount of energy for that. But when you try to minimize energy consumption, you can decrease energy consumption by more than 10%. But that creates a lot of communicational costs in a system. So what is more interesting for us is this decentralized approach, where we have the 2 pumping stations being operated independently. And you can see, compared to the centralized setup, you only have an energy consumption by 3%, which is not that much compared to this benchmark. So that's why we think this decentralized approach is really the way to go. For the pumping stations in the network, we also had a look at these, because usually they are designed in a way where you have multiple pumps of the same type. Here they call pump A, and they usually they are operated for different operation points, and the black curve you can see here, it's indicating all the operating points which can be covered by the setup. All these points below the curve are possible operation points. The control of such a system is quite simple, and the control of another system with multiple types of pumps is more complicated, because the rotational speed of these pumps, you need to calculate that using optimization problem. But when you have a more complex setup, you can, for most operating points, you can save a significant amount of power and energy, as is indicated by these numbers. And during the project, these results were validated using hydraulic simulations. And for the case you're seeing here, because you reduce the number of pumps in the system, you also have like saving in investment costs and obviously CO2 footprint during manufacturing of these pumps. So that was the results for the keyword resilience. Efficiency. Now let's look at resilience. Here we talk about how these agents operate in a real-world scenario. You can see in the photo at the bottom, you can see the hardware agents connected to a pump at a test rig. And this hardware agent was developed during the project. We had quite some improvements there, and we end up with a customized circuit board. You can see that on the right side. And it is based on a microcontroller, an ESP32, and we have quite some input-output modules on these circuit boards, and a Modbus communication module. And these agents are operated at a test rig at the TU Darmstadt, and they also have the possibility through this Modbus communication to achieve cooperation and find near optimal solutions for these control tasks. And we call that fluid trading, because agents are exchanging contracts and to fulfill the demand in the network. And these hardware agents are part of a larger infrastructure, which is established at another project partner of Agents for Water Markets. It's the Vilo Cloud, and you can see here that standard pumps, also from different manufacturers than Vilo, are connected to edge devices, creating smart products, and these then are able to communicate via Modbus to message broker systems, and then you can use different protocols like MQTT or protobuf to even communicate to different cloud setups. Here you can see, for example, one pump message where the pump is communicating its rotational speed and its power consumption. And obviously, you can then use these data in platforms for optimization, visualization, and analysis. And the setup by Vilo is, has a latency of only 60 seconds, quite a reasonable store and forward capability, and security is addressed using protocols like VPN and TSL. Last but not least, let's talk about the fairness. Here, the question was addressed how water demand is changing as a function of the pricing schemes customers are facing in Germany. And the factors analyzed was household size and household income in Germany. And that was done using agent-based simulations using Repast Symphony. That's a Java-based framework. And I brought some summarizing results. So in Germany, usually you have a uniform pricing scheme for water, where cost is increasing with water consumption in a linear way. That's indicated in the middle. And that was compared with increasing and decreasing block rate, where price is increasing the more you consume, or decreasing. You can see that on the right. And when you go to the left and to the right respectively, the deviation from this uniform distribution is increasing. And for a one-person household with an upper medium income, you can see that the annual bill in water is decreasing for this increasing block rate. And when you summarize all these simulation results, which are now presented by these dots in the plot, you summarize them for all the agents in the simulation setup, you can calculate the change in water consumption across the population. And what is striking is that for increasing block rate, you can decrease the water consumption by 0.7% in this population representing Germany. That might not seem that much, but during the evaluation of the sustainability and the CO2 emissions, that quite a reasonable factor if you think of Germany. That's quite a lot. So I hope that I showed how we try to make water infrastructure more efficient, resilient, and fair with our results. And obviously, we also thought about the potentials and how one can utilize the results we obtain. So the software we wrote for the pump scheduling problem can be used also for operating these parallel pumps in pumping station or well galleries. The hardware agents and the VeloCloud setup has the possibility to be used for optimal system control or data-driven optimization, and for the agent-based simulation when changing the parameters and adapting them for different geographical locations. It can be used for testing the influence of water prices on demand. Last but not least, for the highlights, I brought some publications from our project. You can look into these if you are interested in the details. Maybe one low light, actually our project was extended till February, so we have the pleasure to continue working on that. And the vision for the future is that we actually use these hardware agents in an office building of the university for getting more test data, and also use the control strategy in well gallery pumps. So thank you for your attention, and I'm happy to answer questions.
Thank you, Katrin. Oh, dropped my pen. We have a couple minutes. Would anyone like to ask Ms. Hen a question about her results? We can bring you a microphone. You're also welcome to ask the question in German if you prefer. We have a question up here. Do we have a microphone? Yes. Sorry, I didn't.
I think I don't need a microphone.
For the stream, can I just give him one of these? Yes. Okay. Thank you.
Okay, my question is, you talked about the beginning of efficiency, and you said 3 pumps are one pump is not needed. What happened if you have only 2 pumps and one is breaking down? Then it's a critical situation then, because then the water is not coming, and water is always a critical factor. Yes.
So obviously that's a major question, and usually we talk about that with Rhein Energie, our associated partner, and they are talking of this N-1 Sicherheit. So when you think of these buffer tanks being also part of the network, usually the idea is to provide a certain time the water demand with these buffer tanks in the system, for example. That might be a reason, or might be a solution. You could also think of keeping the 4th pump in the system if you have it anyway, but don't use it because it's less efficient than the setup with only these 3 pumps. If you keep the old pump, let's say, for emergency situations, yes.
Thank you very much.
Thanks. Any further questions? Okay. All right. Thank you. Okay. So, thank you, Ms. Hen. So moving right along, telling us now about an autonomous early warning system to protect our water, we have Dr. Gabriele Pakroff from, is it DIVA or the DIW? DIVA, yes, from DIVA. Thank you. Let's welcome her.
Thank you very much for your kind introduction, and good morning to everyone in the audience. I'm here today to present the project DIVA, and you see the long title over there. I want to spare you to read it out and start right now with my presentation. First, I want to introduce the project partners. DIVA consists of 7 partners. We have 2 research institutions, the TZW in Karlsruhe and the University of Potsdam, and 4 companies, BBE Moldenke, SEBA, Südro, and Brockmann Consult, and a drinking water supplier, that's the Warnbach-Talsperrenverband, where I'm coming from. And here you see the project team of DIVA at various project meetings during the past 2 years. The aim of the project is to develop a concept for an innovative autonomous early warning system for water quality by digitally networking sensor system and analyzing data sets with the help of artificial intelligence. The investigations focus on the Warnbach Reservoir, drinking water reservoir in North Rhine-Westphalia, but we also do perform representative measurements at the Oder River to test the transferability of our concept. In the past 2 years, we have installed various sensor systems at the Warnbach Reservoir, starting at the inflow through the water body and down to the outtake of the water for the drinking water treatment. Data from the Sentinel-2 satellite are processed for satellite remote monitoring. As you can imagine, we didn't install the satellite. In the following slides, I would like to highlight some of the project results. Due to the time constraints, I cannot go very much into detail. The biofish is a sensor that is towed behind a boat. You can see it down here, and is collecting high-resolution data of water quality in all 3 dimensions. You see here cross-section plots of various parameters that are recorded simultaneously by the sensor system, and they visualize the spatial variation of water quality along the longitudinal axis, the main axis of the reservoir, and the data reveal how, for example, chlorophyll A as a parameter for the phytoplankton varies along the main axis and also with depth and time. At the inflow of the reservoir, a camera-based system for continuous flow measurement was installed. It is coupled with measurement of key water quality parameters and using a multi-parameter probe. You see in the time-lapse video the relatively rapid rise in the water level in the Warnbach stream, which is very familiar for us for this water body. The data are also automatically transferred to our DIVA database. With the establishment of a quantitative PCR assay for the detection of cyanobacteria and the determination of their toxin formation potential, 2 methods are now available that can be used to test algal blooms relatively quickly for the presence of potentially toxic cyanobacteria, an excellent addition to our sensor system. The fluorometric measurement of algae allows a fast and online monitoring, and the DIVA project success in further differentiating the spectral fingerprint, of the so-called brown algal spectral group, thereby distinguishing and identifying the toxic algae Prymnesium parvum. By adapting the measurement device with an additional LED, developments of these algae that caused the fish kill in 3 years ago in the Oder River can now be detected more quickly and monitored more effectively. The full archive of the Sentinel-2 data were already processed for the water bodies of the Warnbach Reservoir and the Oder River. The figures show the validation of turbidity data with the measurements in situ. The blue dots are the measurements in situ, and the red ones are from the sensor, from the satellite sensor. In March 2019, high turbidity appeared to a flooding and overflow of the pre-dam with a superficial stratification of the turbid water. But most of the time, the water in the Warnbach Reservoir is very clear, You see it here. It's like black for the satellite due to the low turbidity values. You can see it's over there. Compared to this, the dam is quite difficult for the remote monitoring. It works much better with, for example, high turbidity and high chlorophyll values of the Oder River. All this data of the sensor systems, including the satellite data, together with lab analysis and historical data, were integrated in our DIVA database. This achieved a key project goal, establishing interfaces and digitally linking the data. A dashboard for visualization was established and is still being expanded. We have two approaches for the developing of forecasts on different timescales, both using deep learning. A hybrid deep learning model will be used to predict short-term chlorophyll A concentration, integrating vertical high-resolution data from the ADCP or BioLift datasets and meteorological inputs. For the long-term forecast, a deep learning neural network was established based on Keras. The neural net is already being trained with various measurement data, water quality, water levels, and probe measurements. A run-off forecast based on models of hydrometeorological indicators as well as global or regional weather models is then implemented in the neural net. The combination of the run-off forecast and of the application of the neural network enables the prediction of water quality parameters such as turbidity. You see here some test runs of different neural nets concerning the parameter turbidity, and you see sometimes it fits very well, but at other times, it differs very much. So this is still very much work in progress, and we need some more time to complete this. Conclusions so far. Our sensor systems at various levels were successfully digitally connected. The sensor systems on different scales, high frequency, 3D and large scales, the satellite data, and methods on different levels, online analysis, lab analysis, complement each other and provide added value. The deep neural network were established and the training phase is currently underway. We are on a good way to get an improved holistic water resources management based on real-time data. Well, we've also faced some challenges during our project. There were some technical problems that led to a delay. The high-frequency data from the BioLift only started recently. Up to now, we have not enough data collected for the training phases of the neural networks, so there is some more time needed to evaluate sensor systems, the measuring intervals, and the relevant parameters for the short and long-time forecast. So coming to the transfer for our company partners, they already achieved or are developing new application solutions. They can expand their portfolio or integrate new or improved services. There's also the possibility of joint concepts using the DIVA cooperation for joint future contracts. For the scientific and the practice partners in DIVA, it's the expansion of knowledge and experience, leading to lectures and posters at conferences and publications. By participating in various committees, the project can be presented in a subject-specific manner. And we plan to workshops in the next year to present the results of DIVA to potential users, for example, operators of drinking water reservoirs or authorities responsible for water quality monitoring. Well, and with this, I want to thank you for your attention, and I also want to thank the DIVA project team for the wonderful cooperation.
Thank you. Do we have any questions for Dr. Pakroff? No? Okay, if you have more later, yeah. Yes, please, yeah.
Hello, test, mic. Christoph Krakow from the Ministry of Environment in Baden-Württemberg. Thanks for your presentation. I would imagine if you are combining different sensors, you have quite a range of latency between them. Can you elaborate on that? What is the range of latency you have, like the smallest latency and the biggest latency?
Well, the modern sensors are very fast, so I think it's in milliseconds to seconds in measuring in the water. I cannot say something about the satellite data, so I had to ask my colleague from Brockman Consult about this.
Okay. Thank you very much. So now for our third and final presentation of this segment, we are welcoming Professor Dr. Andrea Cominola to come up to the podium. And he is going to talk to, he is from Yole, and he will talk about the future of leakage detection in water distribution systems.
Thanks a lot for the introduction, and good morning, everyone. It's very exciting to be here and meet you after 1 year to present the progress we've made on this project. We've been working on this with our partners, of course, our team at TU Berlin and Einstein Center Digital Future, the Kompetenzzentrum Wasser Berlin, Urban Impact Agency, and the associated partner, Wasser. So we have quite a lot of new things to present today, but going back to the original question, when we sat together more or less 3 years ago and we talked about leakage detection, we had this question that is, well, leakage detection has been quite an old problem by now, and there's been so many solutions around, so why the numbers are still so high? 25% of water being lost in European water distribution networks, and somewhere else, I would say a lot more. Globally, billions of cubic meters lost and billions of dollars or euros, whatever currency you want to use, lost in as non-revenue water. So the question was, we've seen a lot of digital solutions in research, and at the same time we see a mismatch between that and what's implemented in the field, so the actual practical application. And starting from this mismatch, we thought that in fact there's a lack of general solutions that can move beyond case studies or available and benchmark data sets and models as well. So the key question was, how do we actually foster digital solutions in such a way that we can develop a digitally based solution for leakage detection that is industry ready? Well, in Yole we do this in 3 ways, in 3 dimensions. We go integrated, robust, and human-centered. And let me unpack these 3 dimensions for you, basically. Integrated means we have more than one solution embedded in our general framework. Basically, we have 2 algorithms for leakage detection. One that's called the dual model. It's a high-fidelity algorithm to find leakages promptly in time and accurately in location. It's a model-based algorithm. That means it needs a hydraulic model of the network. That's why it's high fidelity, but that also means it's highly demanding because it needs the model needs to be calibrated, and it's computationally more costly than the second algorithm, which is called Lila. Completely different philosophy. It's data-driven. It doesn't need a hydraulic model. It just needs pressure data. So simpler, less demanding, more computationally efficient. But of course, there's a trade-off potentially with accuracy in time to detection and location of detection. So we integrate these two algorithms in our solution. Robust. We want our algorithms to work under a portfolio of different situations, which means under different uncertain scenarios. We categorized possible uncertainties in aleatoric, for instance, types of leakage scenarios and system inputs, as well as epistemic uncertainties, for instance, the quality of data, of the measurements, the quality of the hydraulic model, and so on. Why do we want our algorithm to be robust? Well, to create trust and prove reliability with the end users, to foster continuous development also, starting from a benchmark case and then moving into more complex cases, and of course, moving from theory to practical use cases. And finally, human-centered. Since the early stages, we've been involving our potential customers and users, the water utilities, in the process a bit more passively at the beginning with our market research, where we mapped startups and relevant companies that could use our solution, and then more actively through the process of developing our solutions with dedicated slots for in-depth discussion with individual utilities, workshops. Actually, we had the final validation workshop 2 weeks ago, and an online survey, which provided quite some interesting insights I'm gonna show in a second. Now, down to the results. We worked on these 3 dimensions, and also the results will be mapped across these 3 dimensions, starting from the integrated. So we've been working into improving the 2 algorithms, both individually and in combination. As you see here now, there's a connection on the bottom of the 2 algorithms. So now they have a new module for the actual change point detection, which is basically the module that says when a leakage is happening. And this is now common and adaptive across the 2 algorithms. We also have a publication there and one more in review where we test these on some real data, actually. Sensitivity, which is a measure, it's a method for us to measure the robustness of these 2 algorithms. We've tested them under several circumstances, as I said, in several uncertain scenarios. We're still working on refining the sensitivity for the dual model, but we have already results for Lila and some consistent results across the 2 algorithms. First of all, you see here the Sobol index. For those of you that know sensitivity analysis, it is basically showing more or less the importance of uncertain factors on conditioning the output of a model. The higher, the more influential a factor is. So what we see here, to put it in a nutshell, is that if you have bursts, which are abrupt leakages, then it's more important to have more sensors in the network. The green bar is high. If you have instead incipient leakages, which grow a little bit slower and are harder to detect, then the quality of the data, the measurement error, needs to be low, because if you have better data, then you can detect them faster. Whereas the parameters of our algorithms don't matter so much. So apparently these are really conditions upon the settings of the network and the measurements we get. We also see, going a bit more in the detail of the number of sensors, we see that for the network we are playing with, basically, we have somehow a sweet spot of 30 sensors, which is more or less 10% of the nodes of the network that we have, a bit less. If they're covered with pressure sensors, then the time to detection, on the y-axis you want to keep it low, gets really flat, which means we get somehow a stable and reliable solution there. So if we have enough sensors, our algorithms then work quite nicely. And this is a result that is consistent between the 2 algorithms. Then the beauty of this study on robustness is actually that we can pull all these factors together. Here I'm doing it for the number of sensors and the quality of the measurement, and you see several matrices, each of them referred to a different leak. White means success, leakage found, and green or dark purple means leakage not detected. So we can identify, basically now, without going into details, but basically combinations of factors that allow our algorithms to work successfully, and combinations of factors where we can have challenges, therefore we can inform water utilities on how to mitigate these effects. Now the human-centered aspect of it, we want this to be usable by water utilities, so we've put quite a lot of time and efforts in developing a hopefully friendly user interface. You see it here. You have also an URL on top and a QR code. You can check it out. It's actually now optimized mostly for laptops. What you see here is basically a map, which is the central focus of our interface, so that utilities can see where a leakage is happening. And then they have different functionalities of spotting a real-time leak, basically, but also checking previous leaks and having a records of that. And on the bottom, you see the 2 signals given as an output by the 2 algorithms, so that we have these redundant solutions. And depending on what the utility can actually implement, they can use either one or both algorithms. Now, while it takes some time, hopefully, to check this interface, let me conclude with some thoughts and about the transfer. So hopefully this can also inspire the conversation later. we want this to be used. So the project is running till end of January. What we've been working already at and we're finalizing now is actually moving from just this interface and the algorithms into a full stack application where we have back-end, front-end, and everything that goes from the data to the final visualization of the leakage detection results. And whereas a large part of this will be released open source, we're also considering how to exploit this in the future. We're also in conversation with the business unit at the Kompetenzzentrum Wasser Berlin for that, and of course our project partners in general. We have some encouraging signals, and these are coming from an interview with 20 water utilities worldwide. 17 out of 20 respondents told us that they plan to invest in leakage detection in the next 5 years. So going back to the original question, is this a problem that's solved? Yes, no, apparently not. And nicely, if you look into the reasons for that, of course, it's about the money as well, because they need to save water and save money, but it's mostly also about sustainability and perception of the utility towards the customer. So there's really this attention toward the environment and customers. Second, why are they still in need for these solutions, and what are the challenges that they still face? They indicated that they have difficulties in detecting small leakages, rated by far the most very relevant challenge so far. And often there's an inadequate quality of data and limited resources, which means time and also trained staff to use digital solutions. So we believe that our sort of pursuit towards robustness and automation will help solve and overcome some of these challenges at least. And with this, I'd like to thank you. A couple of weeks ago, some members of our team got a Science and Startup Award, which hopefully is another encouraging signal that we don't want to stop here, particularly working about the final wrapping up of all these products and the transferability. Thanks a lot.
Thank you very much. Do we have any questions about this presentation from Dr. Kominola? No? Okay, thank you. You can sit down for a moment. Wonderful. So thank you for those three very interesting presentations. So now we get to move on to discussing the results. And to do that, our organizers have put together a very exciting panel of experts from different areas. I would first like to invite to the stage Christoph Krakow, who we heard from the question a minute ago. He works for the Ministry for the Environment, Climate, and Energy sector in Baden-Württemberg, as you already mentioned, and where you work in the area of software development. So round of applause. Thank you. Then I would now like to welcome Dr. Andreas Piersing to the stage. He's with Siemens Digital Industries, and you've been with Siemens for over 30 years and are specialized in water management with a particular focus on the needs of Siemens clients. Let's give him a round of applause. And then do we have, yes, all right. See, we also have Dr. Johannes Kollmann joining us via Zoom. He's the director of the AI working group for the BFG, the Federal Institute of Hydrology. His working group looks at the application of AI to research and production. And in 2022 and 2023, you were also the chief scientist of the UN General Assembly. Thank you for joining us digitally today. So a warm welcome for him. Then I would also like to ask our three presenters to also join us on stage. Let's see, where we got you there. Then we have, yes, there. and then we're also welcoming Johannes, sorry, I have your name here. Johannes Kozlowski, tapping in for Yole to speak. So, all right. We have microphones for you here, so when I ask you a question, you can feel free to grab one to answer. So, our goal now is to discuss the problem, solutions, and ideas for the transfer of these project results into follow-up projects, which I'd say you all did a wonderful job already of indicating towards that. But to go deeper into this, we want to talk about the applications into education, the economy, and other practical implementation. And then a note now, largely for the people watching online. At this point, we're going to have a small change, and we will be switching to German. We have a panel of German experts here with us, so to allow the greatest depth of exchange on this topic, we thought we could do this in German. So for our viewers abroad, you can feel free to grab a coffee now, or if you're feeling ambitious and want to grab a dictionary, we will be now talking in German for the next 45 minutes. So, wir wechseln jetzt. Guten Tag. Falls mein Akzent ein bisschen zu stark ist, dann einfach wieder nachfragen oder einfach reden, was so aus Ihrem Herzen liegt. Das ist auch egal. An das Publikum hier im Raum, wenn Sie Fragen haben, heben Sie einfach gerne jederzeit während der Diskussion die Hand und wir kommen mit dem Mikro, wie wir schon gemacht haben. Ich kann nicht versprechen, dass wir am Ende noch Zeit haben, also bitte seien Sie nicht schüchtern, einfach Hand hoch. So, zum Beginn gehen wir noch einmal kurz zu unseren Präsentierenden zurück, weil wir haben gerade sehr viel gehört und um diese Runde eine klare Richtung zu geben, möchte ich von jedem von Ihnen eine abschließende Aussage hören, und zwar: Was ist die wichtigste Erkenntnis aus Ihrem Vorhaben in einem einzigen Satz? Also in einem Satz. Ich würde mit Katharina Henn anfangen. Und bitte, ja, Mikro nehmen.
Okay, jetzt habe ich natürlich am wenigsten Zeit, um darüber nachzudenken. Ich glaube, was für mich am wichtigsten ist, ist die Herausforderung, die Wissenschaft mit der Praxis in Verbindung zu bringen. Das haben wir ja schon ganz am Anfang gehört. Und was wir auf sehr eindrucksvoller Art gelernt haben, ist, dass die Anforderungen und Sichtweisen da oft weiter auseinander liegen, als man das vielleicht aus der wissenschaftlichen Perspektive denken mag.
Einen Satz, sehr gut. Ja, okay, prima.
Ein langer Satz.
Ja, nee, dafür ist die deutsche Sprache da. Ja, okay, dann wir würden vielleicht direkt zu Herr Kozlowski gehen, weil Sie neben Sie sitzt. So, ja, in einem Satz, ja, Jole.
Ein Satz, okay, ich versuch's.
Ja.
Es ist am wichtigsten ist es, dass man mit den Stakeholdern viel spricht, weil man kann forschen, wie man möchte, und Modelle nutzen, wie man will. Wenn man sich nicht den Gegebenheiten der Stakeholder anpasst, dann kann ein Produkt, was aus so einem Forschungsprojekt entsteht, kein Erfolg werden.
Super. Ich glaube, das waren 2 Sätze, aber das ist okay. Genau. Und ja, genau. Ja, Dr. Pakroff, was ist dann Ihr Satz?
Also die Erkenntnis ist eigentlich, dass wir können sehr, sehr viel messen und irgendwie jede Messung bringt wieder einen Erkenntnisgewinn. Und jetzt kommt die Herausforderung, das eben in die Praxis umzusetzen, diese Erkenntnisse, die wir jetzt zum Prozessverständnis zum Beispiel gewinnen, was läuft in so einem Gewässer ab, das sozusagen in die Praxis zu übertragen und anzuwenden.
Ja, prima. Ja, und dafür sind wir ja jetzt hier mit den Experten. Also ich würde jetzt zu den Experten wechseln. Und ja, für euch meine erste Frage. Sie haben gerade die Projekte angesehen. Wenn ihr das alles hört, was geht Ihnen durch den Kopf? Also wir haben alle 3 verschiedene Perspektiven, dafür seid ihr da. Ich würde mit Dr. Piersing anfangen, aus Ihrem Perspektiv als Technologieunternehmens. Was geht Ihnen durch den Kopf, wenn wir das alles anhören heute?
Also zunächst einmal sehr vielfältige Lösungsangebote für sehr vielfältige Herausforderungen. Das finde ich erstmal gut, dass also sozusagen nicht nur ein Problemfeld adressiert wird, sondern sozusagen die ganze Bandbreite der Herausforderungen der Wasserwirtschaft. Und es gibt ja auch noch viel mehr, wie die anderen Projekte dann sicherlich auch zeigen werden im Laufe des Tages. Was mir auch gut gefällt, ist, dass es zum einen, ich sage mal, Dinge gibt, die offensichtlich schon relativ praxisnah, anwendungsnah sind, wenn ich an die Leckageerkennung denke. Ja. Und dann gibt es aber auch Dinge, die einen deutlich weiteren Horizont haben. Wenn ich jetzt an Ihr Projekt denke, dieses, wie war das, Agents for to Watermark? Ja? Das ist sicherlich, also in meinen Augen etwas, was ich glaube was wir nicht morgen sehen werden, was aber viele interessante Aspekte hat und auch dazu anregen kann, zum Beispiel die Betriebsführung eines Wasserversorgers mal völlig neu anzugehen. Ja, und da wird es sicherlich viele Erkenntnisse geben, die von der klassischen Betriebsweise abweichen und die dann aber wieder, ich sag mal, auch mit klassischen Mitteln dann auch wieder umgesetzt werden. Und das, also dieses sich beschäftigen mal mit anderen Herangehensweisen, anderen Lösungen, also das finde ich äußerst spannend.
Ja, danke schön. Ich würde jetzt zu unserer digitalen Gast gehen. Dr. Kamen, als Vertreter eines bundesbehördlichen Forschungseinrichtungen, was geht Ihnen durch den Kopf gerade?
Ja, also erstmal Entschuldigung, dass ich nicht persönlich da sein kann. Das hat sich gestern kurzfristig bei uns geändert. Wir hatten in der Familie einen Todesfall. Aber ich bin froh, dass es online geklappt hat. Wie ich spreche hier für eine Bundesforschungseinrichtung. Wir sind eine Oberbehörde und wir machen im Prinzip wissenschaftliche Grundlagen für Entscheidungen, die dann in Ministerien getroffen werden oder von Bundesländern auch mit betrachtet werden, wenn sie ihre eigenen hoheitlichen Aufgaben an Gewässern wahrnehmen. Und für uns ist es immer wichtig, glaube ich, dass wir, wenn es um GreenTech geht oder um AI oder um die ganze Entwicklung am Ende wollen wir Innovation auf die Straße bringen oder an die Wasserstraße bringen oder in die Gesellschaft bringen. Und ich denke, dass es wichtig ist, dass wir den breiten Blick erstmal haben auf Entwicklung. Und also für mich würde sich zum Beispiel bei dem ersten Beispiel mit den Pumpen hat sich mir sofort die Frage gestellt, okay, wenn ich es dezentral optimisiere, habe ich da wahrscheinlich Vorteile, aber kann man es auch als Gesamtsystem optimisieren und an die Externalitäten denken, die ich damit vielleicht habe, also Energie oder Zeit oder Raum und solche Sachen mit betrachten. Und dann kann ich es runterbrechen auf, was ist die praktikabelste oder die Lösung, die mir unter den Rahmenbedingungen halt am sinnvollsten erscheint oder die ein politischer Entscheidungsträger dann aus einer Anzahl von Möglichkeiten aussuchen will. Also ich fand das super spannend, diese drei. Und für mich stellt sich immer die Frage, wie sagen wir mal, bedingungslos wird am Anfang gedacht, um zu möglichst global optimalen Lösungen zu kommen.
Ja, vielen Dank, dass Sie trotzdem dabei sind für das Gespräch heute. Wir schätzen das sehr. Dann Herr Krakau, Sie vertreten heute eine Landesbehörde. Was denken Sie gerade?
Ja, vielen Dank, dass ich hier die Sicht einer Behörde auch darstellen darf. Ich finde es auch alles drei sehr, sehr spannende Projekte und ich glaube, die sich auch sehr mit den Problemen beschäftigen, die wir in Zukunft oder auch schon sehr kurzfristig lösen müssen in Anbetracht eines Klimawandels und in Wasserknappheit, die uns in Baden-Württemberg noch nicht so sehr betrifft, aber wo wir auch merken, dass wir da die Wasserressource oder die Ressource Wasser immer knapper wird, auch schon teilweise. Ich fand das ganz spannend. Auf dem letzten Vortrag, auf der letzten Folie ging es darum, da wurde gefragt, die Stakeholder, was deren Motivation ist, so ein bisschen, da war, glaube ich, der letzte Punkt ganz unten mit der wenigsten Angabe war die regulatorische Pflicht, irgendwie was zu erfüllen und für Wassersparsamkeit zu sorgen letztendlich. Und da ist, glaube ich, auch für mich was, wo ich dann mitnehmen kann. Also ich glaube, da haben wir einen Aufholbedarf, auch zu gucken, dass mit diesen Ressourcen sparsam umgegangen wird. Und das finde ich spannend, dass wir dann jetzt schon Lösungen haben, wie man das aber auch umsetzen kann. Und das finde ich gut, da diesen Austausch zu führen. Von dem her toll, dass wir das hier besprechen können.
Ja, super. Vielleicht können wir direkt dazu, das finde ich total spannend, dass man sparsamer damit umgehen kann. Können Sie vielleicht dazu ein bisschen mehr sagen, was genau das Problem ist da und welche Möglichkeiten Sie sehen, das zu verbessern?
Ja, sehr gerne. Also bisher hatten wir, glaube ich, was Wasser anging, so ein Luxusproblem. Wasser war immer sehr verfügbar, sehr auch günstig da. In Baden-Württemberg, wir haben die Rheintalebene, die 70 Meter tiefe Grundwasserkörper enthält. Aber wir sehen in anderen Bereichen, auch in Baden-Württemberg, dass das eben zurückgeht und dass eben durch den Klimawandel ausgelöst letztendlich auch Quellen versiegen können und es zu einer Knappheit kommt. Wir haben bisher da nicht so eine richtige regulatorische Lösung darauf. Also wenn wir ein Wasserrecht genehmigen, also die Entnahme von Wasser genehmigen, gibt es immer eine Menge, die jemandem genehmigt wird, die er entnehmen darf aus dem Grundwasserkörper. Es wird aber nicht geschaut, was ist denn überhaupt nachhaltig verfügbar in der Region oder in dem Bundesland. Und ist denn die Summe der ganzen Entnahmen, die wir da genehmigen, überhaupt noch nachhaltig für das Gesamtsystem? Und ich glaube, das sind so Ansätze, die man überprüfen muss, wo man vielleicht in Zukunft zu einem System kommen muss, das bewerten zu können und zu schauen können, wie können wir nachhaltig genug Wasser entnehmen, sodass immer auch genügend neu gebildet werden kann. Und dann ist in dem zweiten Schritt natürlich dann die Nutzung wichtig, dass da halt möglichst wenig Verlust entsteht auf dem gesamten Transportweg bis hin zu uns, die wir das dann nutzen letztendlich.
Ja. Vielen Dank. Auch an den Vortragenden, falls ihr auch was dazu sagen wollt oder ja, einfach melden. Genau. Ja, ich gehe jetzt dann zurück zu Dr. Piersing. Also Sie sprechen viel mit Kunden, das finde ich auch total spannend. Sie hören, was sie brauchen, genau, was für Interessen die haben. Aus Ihrer Sicht, welche Anforderungen hören Sie am häufigsten aus der Wasserwirtschaft und wo klafft die große Lücke zwischen dem, was die Kunden brauchen und dem, was digitale Systeme derzeit leisten?
Also interessanterweise, wenn wir als Systemanbieter mit Wasserkunden sprechen wir sehr häufig über Kosten, über Betriebskosten, über Investitionskosten. Ja. Nachhaltigkeit ist natürlich auch ein Thema, das immer wieder angesprochen wird. Im Ranking, rein gefühlsmäßig würde ich sagen, nicht ganz so hoch angesiedelt ist, auch weil es sicherlich nicht so greifbar, nicht so messbar ist. Und wenn ich dann an Digitalisierung denke, an die vielen Lösungen, die wir jetzt hier gesehen haben, dann wird die Digitalisierung als hilfreiches Mittel zum Zweck gesehen. So ist es auch richtig, meiner Meinung nach. Es geht nicht darum, jetzt irgendwas hier digital zu machen, sondern Digitalisierung soll immer ein Problem lösen, eine Herausforderung lösen. Also von daher sind die vorgestellten Projekte hier sicherlich gut und interessant. Was man dann im Verlauf dieser 2 Tage und wenn man sich so ein bisschen mit dem Thema beschäftigt, sicherlich auch sehen wird, ist, dass es inzwischen sehr viele Lösungen gibt für natürlich sehr viele Herausforderungen. Und wenn ich da jetzt an die Kundendiskussion denke, dann habe ich manchmal oder nie häufig das Gefühl, dass die Kunden auch einfach überfordert sind. Ja, die haben viele Herausforderungen und dann sehen sie da ein Mehr an Lösungen. Und dann sehen Sie sich so ein bisschen vor so einer Wand an Lösungsmöglichkeiten, ohne jetzt wirklich für sich so einen Plan entwickeln zu können, wie Sie jetzt diese einzelnen Herausforderungen kategorisieren, klassifizieren, für sich wichten, um dann einen geordneten Weg über die nächsten, 5, 8, 10 Jahre zu gehen. Und das wäre sicherlich auch nochmal, ich glaube, wir haben ja vorhin von Herrn Müßner gesprochen, das Thema Transfer. Das wäre sicherlich auch nochmal so eine Anregung, nicht nur bei den technologischen Lösungen Hilfestellung zu geben, sondern dann auch ganz konkret bei der Übertragung dessen, was jetzt hier erarbeitet wurde, in die Praxis, in den betrieblichen Alltag, dabei zu unterstützen und zu helfen, damit ich sag mal, die guten Ideen nicht irgendwo versanden und man dann irgendwann mal sagt, ja, es war eine gute Idee, aber genutzt worden ist sie dann doch nur relativ selten.
Ja. Dr. Kummern, Sie haben gerade den Kopf ein bisschen geschüttelt, als Dr. Piersing meinte, ja, das ist manchmal zu viel, die Kunden sind überfordert. Haben Sie dazu auch ein Perspektiv, also aus Ihrer Rolle? Wir können Sie gerade nicht hören. Können Sie noch mal was? Jetzt
müsste es wahrscheinlich gehen, genau. Ich hatte mich aus Versehen selber stumm geschaltet, aber kann mich nicht mehr entstummisieren.
Der Klassiker.
Also, genau. Also, vieles davon kommt mir auch bekannt vor, nicht nur aus der Arbeit an der Bundesanstalt für Gewässerkunde jetzt, sondern auch aus der Zeit vorher, wo ich habe auch mal an der Uni Hochwasservorhersagesysteme entwickelt, mit künstlicher Intelligenz unterstützt. Und oft ist das Problem, dass die Lösung halt, ich habe eine Idee als Entwickler oder Wissenschaftler und versuche dazu die bestmögliche Lösung von irgendeinem Problem zu erarbeiten. Und das kann jetzt GreenTech sein oder jetzt ist natürlich künstliche Intelligenz gerade schön en vogue. Aber am Ende ist es, denke ich, ganz wichtig, dass für mich gibt es ein paar Aspekte, die wir oft nicht genug bedenken am Start und was dann auch den Transfer schwierig macht. Und das ist eben, was ja auch schon angeklungen war, wie robust ist es in der Anwenderfreundlichkeit? Wie viel von dem System kann ich einfach erklären, was ich irgendwie ersetzen will? Und bei künstlicher Intelligenz ist diese Explainability ja auch gerade im Kommen. Also welchen Teil von dem Service oder von dem Resultat, was mir so ein System produziert, kann ich erklären. Und es ist ein großes Problem mit Risiko, denke ich. Also kein Unternehmen oder kein Wasserverband oder irgendwie kein normaler Mensch wird irgendwie plötzlich irgendeine neue Lösung, auch wenn die auf dem Papier schön aussieht, nehmen, um sein existierendes System zu ersetzen, wenn er das Risiko nicht abschätzen kann. Also das ist ein Vertrauensproblem und das Vertrauensproblem löse ich dann, wenn ich Anwendern oder eben wenn ich den Leuten, zu denen hin ich es transferieren will, die Möglichkeit gebe, Systeme erstmal wirklich im Echtzeitbetrieb parallel zu testen. Und ich glaube, das machen wir nicht genug. Wir geben den Menschen nicht die Chance, sozusagen bestehende Systeme weiterlaufen zu lassen und parallel dazu Alternativen, die mit GreenTech oder AI oder Digitalisierung zu tun haben, zu entwickeln und wirklich dann, wenn sie selber das Vertrauen haben, okay, ich glaube jetzt daran und ich weiß, dass meine rechtlichen Rahmenbedingungen das mir jetzt erlauben, dann schalte ich es tatsächlich um. Das machen wir nicht genug und das ist auch nicht in der Forschungsförderung. Ich weiß, es gibt immer die Transferphase von Forschungsprogrammen, aber eigentlich müssten wir sowas schon am Anfang mit der Community denken, zu der es dann transferiert werden soll. Jetzt mache ich erstmal eine kurze Pause. Manchmal, wenn man online ist, redet man zu lang.
Nee, alles gut. Finde ich total spannend, weil für mich kommt die Frage im Kopf, also warum gibt es diese Möglichkeit nicht oder was können wir tun, dass es die Möglichkeiten gibt. Aber Dr. Piersing, Sie haben dazu...
Guter Punkt, ich würde da sogar noch einen draufsetzen. Also dieses Thema Risikobereitschaft betrifft natürlich auch Genehmigungsbehörden und ich stelle mir vor, ich bin Betreiber und ich sehe da eine schöne Lösung, die bei mir auch ein Problem passen würde und ich setze die jetzt um. Jetzt funktioniert die aber nicht. Was mache ich denn dann? Dann habe ich viel Geld ausgegeben, ja, und das Geld ist in den Sand gesetzt, also vermeintlich in den Sand gesetzt. Ich meine, die Community hat ja durchaus einen Erkenntnisgewinn, ja, aber dieses wird nicht ausreichend honoriert und ich als derjenige, der vorangehe, bleibt dann sozusagen mit dem Mist sitzen, ja, also viel Geld für was ausprobiert zu haben und trotzdem nochmal dann Geld ausgeben zu müssen, um auf den alten Stand zurückgehen zu müssen. Also da würde ich mir auch wünschen, dass es da Möglichkeiten gibt für eine, ich sage mal, gefahrlose Pilotierung, inklusive auch einer, ja, wie soll ich das nennen, intelligenten Genehmigung, die sich nicht nur an Jahrzehnte alten Erfahrungen orientiert, so neue Dinge einfach mal auszuprobieren.
Aber was genau bräuchte man, um das zu haben? Also mehr Geld, mehr, ich weiß nicht, also Geld geht immer, ja. Aber was genau fehlt, was fehlt, dass wir das nicht haben?
Also ich sag mal, gut, fangen wir mit dem Geld an. Ich sag mal, wenn gewisse Projekte einfach mal mit den entsprechenden Mitteln ausgestattet werden, um neue Dinge ins Feld zu bringen. Und zwar so, dass es im Misserfolgsfall für denjenigen, der diese Investition tätigt, kein Desaster wird, kein finanzielles Desaster wird. Ja. Wenn es erfolgreich wird, dann profitiert derjenige ja dann auch davon, dann soll er durchaus auch von diesem Budget dann auch wieder was meinetwegen zurückgeben oder sowas, ja. Und das Zweite sind Genehmigungsbehörden. Also vielfach ist es ja so, dass Genehmigungsbehörden sich hier im Bereich Abwasser an DWA-Richtlinien orientieren. Die basieren dann auf jahrzehntelange Erfahrung. Haben wir schon immer so gemacht? Haben wir schon immer gut gemacht? Also das soll jetzt gar nicht
ein Klassiker, ja.
Das soll jetzt gar nicht so abwertend sein, ja. Aber die Bereitschaft, auch mal neue Dinge zu machen, auch auf der Behörde, auf der Genehmigungsseite Risiken einzugehen. Und sich vielleicht da mal auch, ich sag mal, nicht nur mit einem mit einem bekannten Ablaufschema in der Genehmigung auseinanderzusetzen, sondern sich durchaus auch mal mit wissenschaftlichen Erkenntnissen und neuen Herangehensweisen auseinanderzusetzen. Und dann auch zu sagen, so, und dafür übernehme ich jetzt die Verantwortung als Genehmigungsbehörde, damit was Neues mal ins Feld kommt. Das würde ich mir durchaus auch wünschen.
Ja, klar. Also Herr Krakow, ich sehe Sie denken ganz viel, das sehe ich. Also was wollen Sie sagen?
Ja, ich stimme Ihnen zu, das ist wünschenswert. Nur wir haben natürlich als Behörde das Problem, dass wir immer abwägen müssen zwischen dem, was wir gewinnen können und dem Risiko, was besteht. Und ich würde sagen, dass in vielen dieser Projekte manchmal der Druck für Veränderung nicht groß genug ist, um aus behördlicher Sicht so ein Risiko einzugehen. Ich komme aus einem anderen Bereich, also auch im Grundwasserbereich habe ich vor meinem jetzigen Job einen der größten europäischen Schadensfälle betreuen dürfen und da gab es einen riesigen Druck, weil es gab einen sehr großen Schadstoffeintrag ins Grundwasser in Mittelbaden und man musste schnell handeln. Es gab die Notwendigkeit und dann war man auch sehr bereit, innovative Projekte und Lösungen umzusetzen, weil der Druck eben entsprechend groß war. Diesen Druck sehe ich im Wasser bisher aber wenig. Also der ist halt nicht da, weil es eben auch alles sehr gut funktioniert, wie Sie auch gesagt haben. Die DWA-Leitfäden, die sind nicht ohne Grund da, die sind halt auch sehr erprobt. Wenn wir jetzt aber neue Herausforderungen haben oder bekommen in Zukunft, und das ist ja irgendwo absehbar, dann wird zwangsläufig auch der Druck steigen, sich diesen Problemen mit innovativen Projekten oder Lösungen irgendwie zu stellen. Und dann sind, glaube ich, auch Behörden bereit, da mitzugehen. Wir brauchen vielleicht in diesem Scale-up zwischen Pilotphase und Großanwendung irgendwie so ein Zwischending noch vielleicht, dass man irgendwie das in Testregionen irgendwie ausprobiert oder so. Aber dass es dann so einen Zwischenschritt gibt, das wäre auch noch vielleicht eine gute Variante da drin.
Dankeschön. Ich wollte noch mal... Fragen. Ja.
Zu dem Punkt eben, es gibt noch nicht genug, ich will mal sagen, Katastrophen. Man ist eine Katastrophe so ein bisschen. Wenn ich jetzt aber vorausschaue, ich meine, ich komme aus Niedersachsen und wir haben jetzt in den letzten Jahren im Sommer schon nicht mehr, was auch ein bisschen dumm ist, sprengen dürfen über die Mittagszeit, also das Wasser sparen. Man steuert auf diese Nummer schon zu. Und trotzdem höre ich jetzt noch so ein bisschen raus, ja, es ist vielleicht noch nicht kritisch genug, dass es erst so weit kommen muss, dass man sagt, okay, von 10 bis um 17 Uhr dürft ihr gar kein Wasser mehr verbrauchen. Das geht dann nicht nur für Sprengen, sondern auch für die Haushalte. Also wie kritisch muss es werden, bis irgendwas passiert? Das ist, finde ich, so ein bisschen dünnes Eis, glaube ich. Und die anderen Punkte, die mir aufgefallen sind, die Industrie sagt, Nachhaltigkeit ist noch nicht ganz oben.
Entschuldigung, können Sie dem Mann ein Mikrofon geben? Weil sonst höre ich eigentlich nur 10%.
Sorry.
Ja, okay. Soll ich nochmal anfangen?
Nee, ich glaube, ist schon mit Wassersprengen und Niedersachsen und ist schon soweit, habe ich schon verstanden.
Genau. Und der andere Punkt, den ich gerade gehört habe, ist, Industrie sagt, Nachhaltigkeit beim Wasserverbrauch ist noch nicht ganz oben, weil es gibt noch genug. Kann ich total verstehen, obwohl Nachhaltigkeit, glaube ich, in der Bevölkerung ist eines der Top-Themen aktuell. Und auf der anderen Seite sind die Regularien scheinbar noch nicht da, um das Ganze zu managen. Da habe ich dann wiederum Angst, denke, okay, wir versuchen alle Bürokratie abzubauen. Da laufen gerade zwei Züge, will ich jetzt nicht sagen, doch ein bisschen aufeinander zu. Der eine sagt, wir brauchen mehr Regularien und die Industrie sagt, nö, eigentlich brauchen wir es so gar nicht. Bisher gefällt uns das ganz gut. Nachhaltigkeit ist noch nicht Top-Thema. Also das sind so die beiden Punkte, die mir so aufgefallen sind während der Diskussion.
Ja, Dr. Pesing.
Also, dann habe ich mich falsch ausgedrückt. Wenn ich gesagt habe, Nachhaltigkeit ist auf unserer Kundenseite nicht das bestimmende Nachfragekriterium. So habe ich das gemeint. Wenn ich einem Kunden vorschlage, du kriegst eine preiswerte Lösung oder du kriegst eine etwas teurere Lösung mit einem höheren Nachhaltigkeitspotenzial oder das Problem ist ja auch, man kann es ja nicht richtig messen, dann stellen wir fest, dass in den allermeisten Fällen die preiswerte Lösung vom Kunden gekauft wird. Durchaus entgegen unseren Wünschen. Ja, also wir würden gerne mehr in Richtung Nachhaltigkeit tun. Intern machen wir auch viel. Aber wenn unsere Kunden uns sagen, sieh mal zu, dass du eher eine preiswerte Lösung anbietest, ja, dann müssen wir uns in vielen Fällen diesem Druck dann leider auch beugen. Also,
ja, kann ich dazu auch.
War jetzt keine Kritik jetzt direkt an Sie jetzt, also an die Firma, sondern ganz allgemein, dass tatsächlich genau Kosten immer noch wichtiger sind als Nachhaltigkeit. Und das müsste man irgendwann mal in eine gleiche Level bringen, dass man sagt, okay, Nachhaltigkeit ist mindestens genauso hoch wichtig wie Kosten eben auch. Vielleicht muss man das irgendwie anders spannend machen. Da kommt wiederum Geld ins Spiel. Ne?
Ja, Dr. Kommann.
Ja, ich habe dazu direkt eine Erfahrung. Also vor 2-3 Jahren haben wir mal eine Studie kommissioniert bei den Vereinten Nationen und nageln Sie mich jetzt nicht auf die genauen Zahlen fest, das ist eine Schätzung. Da haben wir abgeschätzt, dass pro Jahr öffentliche Mittel im Wassersektor, also alle Regierungen dieser Welt, pro Jahr sind ungefähr 3,2 Trillionen US-Dollar werden investiert in öffentliche Mittel für die Verbesserung der, wenn Sie wollen, Sustainable Development Goal 6, also Wasser. Und davon hat ungefähr 1/3 eine negative Externalität. Das heißt, wenn ich irgendwo 3 Euro investiere für irgendwas Schönes, zerstöre ich mit dem Wert von 1 Euro irgendeine andere Funktion, sei es nun in der Umwelt oder eine andere, oder es wird wirtschaftlich irgendwas anderes schwieriger oder es ist halt ein gesellschaftlicher Schaden, der entsteht. Also das sind diese 3 Dimensionen von Nachhaltigkeit, die Gesellschaft, die Wirtschaft und die Umwelt. Und ich denke, oftmals fahren wir uns fest in dem betriebswirtschaftlichen Preis, der halt, wie der Kollege von Siemens sagt, wenn ich es betriebswirtschaftlich rechnen muss, ist es so, die Betriebswirtschaftsrechnung ist aber halt nur Sie kommen in ein lokales Optimum rein, wenn Sie alles nur in dem eigenen Kontext optimieren und eigentlich müssten wir viel mehr gucken, wo sind diese Externalitätspotenziale, die wir heben können, also wo kann ich mit einem Investment noch einen anderen positiven Effekt erzeugen und eigentlich müsste es dafür ja sogar von der Politik oder so eine Art Ausgleichsfonds geben oder so, wenn man halt Externalitäten, die negativ sind, vermeidet oder Externalitäten, die positiv sind, generiert, müsste man dafür eigentlich noch irgendwie steuerlich bevorteilt werden oder so, also ist vielleicht besser als die Mütterrente, zukunftsmäßig. Also ich denke, es gibt solche Möglichkeiten, aber darüber wird halt in der Politik meistens nicht diskutiert, weil auch die Politik in Ressorts denkt. Also wir in der Verwaltung und in der Politik wird in Ressorts oder das hier ist mein Thema, ich bin der Minister für so und das ist nicht nur im Bund so, das ist auch auf der Länderebene so und wir müssen diese Denkgrenzen in den Ressorts, und ich spreche jetzt halt für die Verwaltung, wir könnten das gerne auch für andere Teile der Gesellschaft diskutieren, überwinden, damit wir anders uns vorstellen können, wie wir neue Technologien oder Innovationen transferieren können. Ich glaube, das gilt nicht, wenn wir in diesen engen Grenzen bleiben, in denen wir normalerweise halt wirtschaften.
Ja, so Schere aus dem Kopf quasi. Ja. Frau Henn.
Ich wollte dazu vielleicht ein Beispiel aus unserem Projekt vorstellen. Und zwar bei den agentenbasierten Simulationen zur Abschätzung von diesen Preisstrukturen beim Wasser. Die Ergebnisse, die wir gezeigt haben, wenn sich jetzt tatsächlich der Wasserverbrauch durch die Änderung der Preisstruktur senken würde oder auch erhöhen würde, dann würde das am Ende wieder Auswirkungen auf die Kosten haben, die für die Wasseraufbereitung nötig sind. Also dieses Thema Externalitäten, das sagt man jetzt so schön, aber am Ende ist das schon auch sehr komplex, da die Auswirkungen abzuschätzen und dem Rechnung zu tragen. Mhm. Und andererseits, das ist für viele Leute aus der Praxis auch ein sehr abstraktes und sehr fernes Thema gewesen. Also wenn wir jetzt da denken, wo sind wir beim Strom, wo sind wir beim Wasser, da ist schon noch ein sehr großer Unterschied und ich glaube, die Vision ist vielleicht auch noch nicht so angekommen an vielen Stellen.
Mhm. Herr Kozlowski, vielleicht wollen Sie auch für Jolle was dazu sagen, also um Sie einzubinden hier, ja? Also gerne mit Mikro, bitte.
Mir fällt spontan jetzt ehrlich gesagt gar nicht so wirklich was ein.
Ja, oder vielleicht so einfach... sorry, dann sind Sie gerettet, ja.
Ich hätte eine Frage an Jole, von daher passt das vielleicht ganz gut.
Ja.
Kurz vorhin dran noch ein Kommentar. Ich glaube, wir springen auch ein bisschen zu kurz, wenn wir sagen, Nachhaltigkeit machen wir nur, weil es nicht kosteneffizient ist. Wir sehen das leider auch in anderen Gebieten bei der Kreislaufwirtschaft oder so, dass selbst Kosteneinsparungen Unternehmen manchmal nicht motivieren, neue Lösungen einzusetzen, einfach weil man so ein bisschen auch die Transformation oder das Neue an sich so ein bisschen scheut. Also auch vielleicht andere Kosten als monetäre im Betrieb irgendwas umzustellen. Ja. Aber die Frage, die ich eigentlich an Jole hatte, ist tatsächlich, wir hatten ja, der erste Punkt war ja von Ihnen, auch von Frau Henn und so, wir müssen sprechen mit den Stakeholdern und eigentlich macht ja Jole das, was wir wirklich wollen, dass wir die Projekte auch gleich von Anfang an darauf denken. Wie waren denn Ihre Erfahrungen mit dem Interesse von den Stakeholdern?
Glaube ich, sehr stark auch an dieser einzigartigen Struktur, die wir in Deutschland haben, mit den sehr, sehr vielen kleinen Wasserbetreibern. Wir haben festgestellt im Prozess, dass es wesentlich leichter ist, von größeren ausländischen Betreibern Informationen zu bekommen. Und auch der Großteil dieser Antworten bei der Umfrage, die wir gemacht haben, kommt aus dem Ausland tatsächlich. Das ist, glaube ich, eine ganz andere Kiste, die man da aufmachen muss, wenn man jetzt da auf Deutschland schaut, wo es halt einfach um Kosteneffizienz geht und nicht um Ressourceneffizienz bei Wasserbetreibern. Genau, aber ja, das ist ein großes Problem.
Vielen Dank. So eine allgemeine Frage, die ich in die Runde werfen möchte, weil wir reden hier viel von Strukturen und von Geld und Probleme, aber ich möchte jetzt von dem Faktor Mensch reden. Also welche Bedeutung kommt dem Faktor Mensch dabei zu? Wie können Menschen für neue Technologien und Transformation begeistert werden? Oder welche Rolle spielt dieser Faktor? Herr Krakau.
Ja, würde ich gerne was zu sagen. Also wir haben gerade in Behörden natürlich das Problem, dass wir mit dem Generationenwechsel zu kämpfen haben, aber auch mit dem Nachwuchskräftemangel letztendlich und dass wir teilweise neue Stellen, die wir brauchen, gar nicht so ausreichend besetzen können, wie das notwendig wäre. Und da sind gerade neue Technologien oder KI auch als Hilfe, die uns da zukünftig vielleicht auch sehr repetitive Aufgaben abnehmen kann, aber bis hin auch zu der Möglichkeit, vielleicht große Antragsverfahren irgendwie vorab zu prüfen oder die Möglichkeiten uns zu geben, da effizienter zu werden innerhalb einer Behörde. Eigentlich sehr gewollt und wir sind da auch sehr bestrebt, Pilotprojekte umzusetzen und sind dabei, genau solche Lösungen zu prüfen und zu entwickeln und uns da auch mit Forschungsprojekten dem anzunähern. Wir haben aber als Behörde immer auch den Auftrag, dass wir, wenn wir Daten verarbeiten zum Beispiel, dass diese Daten sicher verarbeitet werden müssen und dass die nicht auf amerikanische Server zum Beispiel gelangen dürfen, was für uns ein Problem darstellt, gerade mit solchen neuen Technologien. Das heißt, da ist uns eben auch wichtig, und das ist auch eine Herausforderung oder ein Auftrag irgendwo an die Wissenschaft und eben da vielleicht eine europäische oder deutsche Lösung zu finden, wie man solche Systeme sicher betreiben und einsetzen kann. Ich glaube, da gibt es einen großen Bedarf letztendlich für solche Systeme. Aber wir sind sehr gewillt und wir brauchen das. Also wir sind da sehr im Austausch.
Ja, super. Ich gehe dann zurück zu Dr. Kollmann, weil Sie, zum Thema Deutschland und deutscher Server, Sie haben diese internationale Perspektive, also aus Ihrem Erfahrung bei der UN-Generalversammlung. Ja, können Sie vielleicht was dazu sagen, also zu Thema Deutschland und was Deutschland braucht oder Deutschland im Vergleich mit anderen Ländern, was es um Themen wie KI geht?
Oh, da machen wir jetzt eine ganz lange Diskussion auf. Ich würde noch einmal kurz zu dem Faktor Mensch zurückkommen und dann bitte. Würde ich gerne was dazu sagen. Ich glaube, der Faktor Mensch ist tatsächlich wirklich diese Vertrauensgeschichte oder kann ich das selber verstehen, kann ich das selber anwenden. Und ich meine, Fahrradfahren lerne ich auch nicht, wenn mir einer erklärt, wie ein Fahrrad funktioniert, sondern ich muss mich da draufsetzen und muss irgendwann das Gefühl haben, okay, ich beherrsche das Ding oder es macht Spaß oder irgendwas, es bringt mir was. Also ich glaube, das Problem, was wir haben, ist, dass wir und das sieht man ja auch an Studenten, heutzutage studiere ich halt oder bin ich in der Ausbildung und am Ende bin ich halt an Raufasertapeten-Spezialist und dann darf ich aber keinen Teppichboden mehr verlegen oder sowas. Also wir sind schon so kompartmentalisiert, dass wir gar nicht mehr diese Exposition haben zu Innovation oder zu den ganzen Möglichkeiten der künstlichen Intelligenz. Und da gibt es so ein Riesenpotenzial, was uns, ich meine, das klang jetzt gerade an vom Kollegen aus Baden-Württemberg, in Deutschland haben wir eine Migrationsangstdebatte und wir werden überhaupt gar nicht überleben ohne künstliche Intelligenz und ausländische oder Leute mit Migrationshintergrund, die Arbeit machen können in diesem Land. Also da denke ich, da springen wir viel zu kurz. Und von daher, ich hätte den Wunsch, dass viel mehr Austauschmöglichkeiten bestehen, wo Leute aus verschiedenen Sektoren oder Branchen oder auch aus der Wirtschaft, aus der Verwaltung einfach mal für eine Zeit irgendwo anders hingehen können. Und das kann kurz sein, das können Besuche sein, das können Praktika sein, vielleicht will man das so nicht nennen, wenn man schon was Wichtiges ist, aber wir brauchen mehr Austausch zwischen den Leuten. Dann entsteht auch, glaube ich, mehr Vertrauen in die gemeinsame Innovationskraft. Mhm. Und wenn Sie jetzt Deutschland im Vergleich zu anderen Ländern, also die ganze Geschichte der künstlichen Intelligenz, okay, es gibt jetzt den europäischen AI Act, der versucht wahrscheinlich Risiken zu vermeiden, aber da gibt es, denke ich, nicht genügend Chancenanerkennung, was wir mit künstlicher Intelligenz zum Beispiel alles wirklich erreichen können. Und für mich liegt die große Chance in der Erweiterung des Informationsgehaltes von Systemlösungen oder der Betrachtung von Systemen. Und das ist jetzt egal, ob das ein Umweltsystem ist, ein Erdsystems oder ein ökonomisches System. Ich glaube, wenn wir durch künstliche Intelligenz und Innovation mehr Informationsgehalt verarbeiten können, dann bekommen wir eben aufs Globale gesehen oder auf unseren Zweck gesehen eine bessere Optimierung von Systemen hin. Und Systemoptimierung ist, glaube ich, das, wo wir ganz viel Potenzial haben, weil das klang ja auch schon an in der Diskussion. Wir machen halt immer so Sachen, weil die halt schon so lange so gut funktioniert haben, oder ich baue halt einen Dieselmotor, weil der sich gut verkauft. Aber in Wirklichkeit ist sozusagen die Innovationsbereitschaft in der Erweiterung von diesen Wissensprozessen der entscheidende Faktor, der in Deutschland funktionieren kann. Und den betrachten wir im Moment, glaube ich, nicht genug. Von daher würde ich mir wünschen, dass wir wir sprechen immer von Technologieoffenheit, wenn es um Verkehr geht, aber in Wirklichkeit müssten wir mal von Informationsoffenheit sprechen ich möchte gerne mehr Informationen in solche Prozesse durch Digitalisierung reinbringen, damit ich optimalere Lösungen entwickeln kann.
Ja, vielen Dank. Wir haben hier eine Frage. Wenn wir den Mikro hier ganz... Ja.
Gregor Thiele, mein Name. Ich habe eine Frage zu diesem Transfer. Eine Forschungseinrichtung erstellt ganz tolle Verfahren und Lösungen und vielleicht können wir das ein bisschen konkreter, technischer denken. Die verwenden beispielsweise ganz viel Open-Source-Module. Und jetzt gibt es zwei Arten von Bedacht und Vorsicht beim Einsatz von Technologie. Wir können uns jetzt einen KMU im Maschinenbau vorstellen. Die können noch sagen, ich trage das Risiko an dieser Stelle für den Einsatz von Predictive Maintenance und da entstehen ein paar Kosten, wenn was schief geht. Den Fall hatten wir vorhin. Das ist eine andere Skepsis als Betreiber von Kritis. Und wir sind jetzt in der Wasserwirtschaft und ich kenne aus meiner eigenen Erfahrung den Bedacht, ich nehme lieber was Proprietäres, was komplett einem Unternehmen gehört, was mir auch Wartungsverträge bis in alle Ewigkeit verspricht, anstatt irgendwas, was eine Community gerade hypt, wo noch irgendwo eine GNU-Lizenz drin steckt und dann irgendwie in 2 Jahren entweder die Community abhaut oder klar ist, die Lizenz ist doch nicht tauglich für den Einsatz bei mir. Was ist so Ihre Ansicht, vielleicht sogar Herr Pirsing, Sie hatten erwähnt, dass Ihre Kunden vielleicht nochmal ein anderer Schlag sind von Bezug zur Technik als jetzt der typische Maschinenbauer, wie ist Ihre Sicht, ist diese Community von Kritis-Betreibern bereit, Open-Source-Module mit aufzunehmen und einzusetzen?
Das ist ein interessanter Punkt. Ich weiß nicht, ob Sie das mitbekommen haben, die Diskussion beginnt gerade. Also ich würde mal sagen, seit einem Jahr läuft die Diskussion mit einer zunehmenden Dynamik. Wahrscheinlich auch ein bisschen aus falsch getriebenen Gründen, weil nämlich viele Leute Open Source mit kostenlos verwechseln. Ja, und also der Community-Gedanke, der hat schon einige faszinierende Aspekte. Ja. Auch Open Source hat einige faszinierende Aspekte, natürlich auch viele Gefahren. Ich sage mal, wir als Unternehmen sind noch in der Findungsphase. Ja, also natürlich hat dieser Community-Gedanke, wie schon gesagt, viele interessante Aspekte. Also das Bündeln von viel Wissen, von viel Erfahrung, auch die Bereitschaft, das zu teilen, dass auch wir als wirklich großes Unternehmen gar nicht mehr alles alleine leisten können. Ja? Auf der anderen Seite natürlich die Gefahren. Ja? Also Open Source heißt ganz einfach, jeder kann da reingucken. Das ist das eine. Jeder kann im Grunde genommen mit dem Offenlegen zum Beispiel von Softwarecode auch Unfug treiben. Und dann bleibt nur die Hoffnung über, dass der Rest der Community diesen Unfug erkennt und dann dagegen handelt. Auf der anderen Seite, wir als Unternehmen haben auch noch keine richtige Vorgehensweise gefunden, wie wir auch langfristig unser Geschäft bei Open Source sicherstellen. Ja, denn ich meine, zu einem Großteil basiert ja unser Umsatz und auch unser Gewinn aus dem Verkauf zum Beispiel von Software. Und wenn dieses nun wegfallen sollte, würde uns das vor erhebliche Schwierigkeiten stellen. Wobei natürlich, ich sage es nochmal, Open Source heißt nicht kostenlos. Wir müssten uns dann sicherlich darauf einstellen, neue Geschäftsmodelle, neue Verrechnungsmodelle zu finden, zu definieren, die dann hoffentlich auch entsprechend akzeptiert werden.
Herr Krakau dazu?
Ja, vielen Dank. Ich betreue ja auch bei uns in Baden-Württemberg die Entwicklung unserer Fachverfahren, die ja auch sind nicht wirklich kritische Anwendungen tatsächlich, aber unsere Datenbanken, die wir da einsetzen, letztendlich speisen die auch dann Hochwasserwarnsysteme etc., die dann wiederum kritische Anwendungen sind. Und wir sind jetzt in einer sehr großen Modernisierung dieser Verfahren gerade. Die sind sehr veraltet, diese Systeme. Und wir sind dabei, eigentlich alle proprietären Technologien abzuschaffen aus diesen Systemen und komplett auf Open-Source-Komponenten zu setzen, weil wir zum einen das als auch Akt der digitalen Souveränität sehen letztendlich, diese Daten eben auch so lange Zeit betreiben zu können und unabhängig zu sein und auch weiterentwickeln zu dürfen. Aber auch vor allem den Kostenfaktor, der ist nicht außen vor zu lassen. Also Open Source ist nicht umsonst, das sehe ich auch so. Man braucht dann trotzdem Softwarepartner, die eben den Support entsprechend leisten können. Aber trotzdem sehen wir bei vielen Softwareprodukten und Lösungen, die halt proprietär sind, enorme Lizenzkostensteigerungen. Da gibt es einige Beispiele, die einfach nicht langfristig tragbar sind finanziell und da ist dann der Wechsel auf Open-Source-Komponenten, glaube ich, ein sehr wichtiger Schritt, um sich dem zu entziehen.
Danke. Wir müssen so langsam zu Ende kommen, also ich würde dann mit ein paar letzte Fragen beenden. Ich gehe zurück zu den Vortragenden und die Frage wäre, Sie können jetzt vielleicht so 2, 3 Sätze nutzen, nicht nur eins, aber genau, 5 bis 10 Jahren, wo steht Ihre entwickelte Lösung und was bräuchten Sie als außer Forschungsgelder, um diese Ziele zu erreichen? Was bräuchtet ihr? Vielleicht fangen wir Dr. Parkhoff an.
Ja, ich fände es ich hoffe, dass wir vielleicht in 5 oder vielleicht auch in 10 Jahren unser System oder ein vergleichbares System wirklich in unseren Leitstand zum Beispiel im Wasserwerk integriert haben, dass die Kollegen sehen, okay, da tut sich was im Wasserkörper, wir müssen die Aufbereitung anpassen. Das wären für mich so die ganz konkreten praktischen Anwendungen, dass wir wirklich in Real-Time-Data nutzen können, um unsere Trinkwasseraufbereitung zu optimieren. Was wir dafür brauchen, ist eben wirklich auch eine praxistaugliche Anwendung, dass wir eine sehr überschaubare Softwarelösung entwickeln, die eben in so einem Leitstand integriert werden kann, damit die Kollegen dort vor Ort auch eben damit umgehen können.
Ja, vielen Dank, Frau Henn.
Ich denke da an Smart Meter, dass wir Anreize setzen können, um zum Beispiel, wir hatten den Wassersprenkler im Sommer, dass wir Anreize setzen können, diese Verbrauchsspitzen zu verschieben und dass wir auch eben die Hardware-Lösungen haben, um damit bei den Wasserversorgern die Potenziale abzuschöpfen. Und was wir dafür brauchen, ergänzend zu der Diskussion Open Source, das ist natürlich auch für die Universitäten ein Riesenthema. Und da ist vor allem Nachnutzbarkeit ein Riesenthema, Nachnutzbarkeit von Code. Und ja, man braucht dafür Geld, man braucht vor allem Ressourcen und man braucht vor allem Wertschätzung dafür, dass das auch wissenschaftliche Arbeit ist, wie das Erstellen von Publikationen oder wie das Aggregieren von Daten ist, Maintenance von Code auch ein Riesenthema. Und ich glaube, das ist sehr wichtig.
Ja. Herr Kozlowski.
Wenn ich jetzt ein bisschen träumen darf, das Projekt-Outcome von IOLE ist ja auch ein Open-Source-Produkt, was dann auch verfügbar sein wird. Und um Open-Source-Produkte bilden sich ja auch oft Communities. Und das große Problem mit der ganzen Leckage-Community ist eigentlich, dass es keine öffentlichen Realdatensätze gibt, um Modelle zu benchmarken, um Modelle untereinander vernünftig zu vergleichen zu können. Und wenn ich das mir aussuchen durfte, dann gäbe es in 5 Jahren eine Community, in der es auch Daten gibt, in der nicht nur unsere Algorithmen erweitert werden, sondern vielleicht auch noch weitere hinzugefügt werden, aufbauend eben auf jetzt dem ersten öffentlich verfügbaren Leckage-Tool.
Ja. So, jetzt auch an unseren Experten. Gleicher Zeitraum, 5 bis 10 Jahren. Wo stehen wir in diesem Anwendungsfeld? Also quasi, wie digital sind wir, realistisch gesehen? Also in 5 bis 10 Jahren. Herr Krakau.
Ja, auch ich, würde nochmal auf das Datenthema gerne anspringen. Also letztendlich haben wir als Umweltverwaltung, als Behörden noch einen unfassbar großen Datenschatz bei uns allen in unseren Datenbanken drin. Und wir sind, es gibt jetzt seit einem guten Jahr auch dazu eine Verordnung der EU, die uns zwingt, und das finde ich sehr gut, dass sie das tut, diese Daten maschinenlesbar zu veröffentlichen. Und da sind wir bisher nicht wirklich weit, da sollten wir deutlich weiter sein, und ich hoffe, dass wir in 5 bis 10 Jahren diese Daten auch sehr qualitätsgesichert, hoffentlich, auch das ist eine große Herausforderung, aber auch dann maschinenlesbar veröffentlichen können, um eben eine Nachnutzung durch Industrie und Wissenschaft und Forschung zu ermöglichen, weil ich glaube, das ist eben ein Riesenfundus und der uns wiederum auch dann hinterher hilft, diese Erkenntnisse, die dann aus diesen Daten eben gesammelt werden können, auch wiederum zu nutzen und für unsere Zwecke einzusetzen. Also das wäre ein schöner Erfolg, wenn uns das gelingt.
Ja, klar. Dann bleiben wir bei den Behörden. Dr. Kummern, 5 bis 10 Jahren.
Ja, meine Glaskugel hat ziemlich große Sprünge im Moment. Einerseits, also ich arbeite ja auch mit der KI-Gruppe bei uns und ich glaube, das hat ein Riesenpotenzial, was komplett unterschätzt wird von vielen Menschen in Deutschland. Ich glaube, dass wir in 5 Jahren oder 10 Jahren wirklich so weit sein können, dass wir wirklich verstehen, wie Zusammenhänge in unserer Sozioökonomie oder in dem Erdsystem oder in der Landschaft, in der wir leben, funktionieren und wie wir die optimieren können. Und da gehört das, was Herr Kratauer gerade gesagt hat, mit Daten und Ontologien und so dazu. Aber dazu gehört eben auch Externalitäten sind komplex, aber die steuern am Ende, wie effizient und wie gut wir Innovation in die Anwendung bringen können. Und ich glaube, das können wir schaffen. Dafür bräuchten wir eben eine Diskussion in der Politik Und wir bräuchten so eine Art De-Risking Facility, ich weiß nicht, wie man das auf Deutsch nennen würde, eben wo entweder mit Steuervergünstigungen oder also man kann auch Steuern erheben oder man kann Geld bezahlen oder man kann einen Fonds machen. Also alles, was der Zukunft hilft und besser ist, als ein Rentenniveau zu garantieren oder sagen wir mal, zu versuchen, die Werkzeuge, die in der Vergangenheit oder die Strukturen, die in der Vergangenheit gut funktioniert haben, aufrechtzuerhalten, halte ich für sinnvoll. Und deshalb wünsche ich mir, dass wir so eine Art De-Risking Facility hinkriegen in Deutschland, die von der Verwaltung, aber auch von der Privatwirtschaft vielleicht irgendwie gemeinsam gedacht und befördert werden kann.
Ja, ja. Dr. Piersing, ich schenke Ihnen das letzte Wort. Ja.
Also zunächst einmal glaube ich, dass wir werden viel digitaler sein als heute. Dabei spielt die Zeit für uns, also wenn ich mal in 10 Jahre denke, dann werden so die alten Männer, die werden nicht mehr da. Ich werde dann kein aktiver Teil mehr sein der Wasserwirtschaft. Ja? Und das, was nachkommt, ist einfach mit Digitaltechnologien aufgewachsen. Und das macht es sehr viel einfacher, solche neuen Technologien zu etablieren und auch in die Nutzung zu bringen. Ja, also von daher bin ich da recht optimistisch. Das nächste wird sein, wir werden vieles, also mit diesem Generationswechsel, der definitiv ansteht, werden sich auch viele Erfahrungen, die so junge Leute, diese digitalen Nutzer machen, die werden sich auch in den Industriebereich übertragen. Also Plattformen und dann viele Apps, die dann sinnvoll miteinander zusammenspielen. Ja? Wir hatten vorhin oder ich weiß gar nicht, wir hatten dieses Stichwort proprietäre Systeme. Das wird sicherlich zurückgehen und die werden zerfallen in viele kleine Einzelanwendungen, die dann aber miteinander kommunizieren müssen, also interoperabel sein müssen. Das wird kommen, sicherlich. Das wird sicherlich Anstrengungen hinsichtlich Standardisierung zum Beispiel erfordern. Ja. Und dann einen Punkt will ich auch noch betonen, der ist mir heute ein bisschen zu kurz gekommen. Wir haben ihn nur mal so an einigen wenigen Stellen so kurz berührt. Das ist das Thema KI. Also ich glaube definitiv, wenn wir in 10 Jahren zurückgucken, dann werden wir feststellen, dass Mitte der 20er Jahre, das wird so einen Zeitpunkt davor und danach geben. Ja, also 2020 wird davor sein, 2030 wird mit Sicherheit danach sein, aber die Möglichkeiten, die KI bietet, die werden so dramatisch sein und die werden sich auf so viele Dinge auswirken. Ja? Die werden so viele Arbeitsabläufe verändern, auch weil es erforderlich ist, ja? weil uns Fachkräfte fehlen, weil uns Menschen fehlen. Aber das wird, also wenn wir zurückgucken in 10 Jahren, wird das vermutlich das Ding sein, das den größten Einfluss nicht nur auf die Wasserwirtschaft, sondern auf die Industrie in Summe gehabt hat. Ja? Und da fallen mir noch gar nicht alle KI-Anwendungen ein, die möglich sind. Das ist eben nicht nur die Hochwasserprognose, sondern das sind sicherlich erstmal interne Prozesse, was weiß ich, im Personalwesen, im Rechnungswesen, in der Reisebuchung, sonst irgendwie was. Ja? Und die Erfahrungen, die da gewonnen werden, die werden dann irgendwann auch in den betrieblichen Alltag von Anlagen reinspielen. Und nochmal, es wird ein Davor und ein Danach geben.
Ja. Ja, vielen Dank und vielen Dank an alle meine Gesprächspartner heute. Wir geben ein großes Applaus. Und wir verabschieden auch unsere digitale Gäste. Vielen Dank, Dr. Kuhlmann, dass Sie dabei waren. Genau, und wir machen jetzt eine Pause. Also es gibt Kaffeepause in der Foyer. Und we start again at 11:15 and I switch back to English now. Sprachtest überstanden, ja. Danke.
My name is Christoph Kepschel. I will be your host for this session. As you can hear, it's a mixed language session. We will have the presentation of the 3 projects in English and then switch to Deutsch for the anschließende Diskussion. Let me quickly run you through what we have planned. So we're first going to hear the 3 presentations from the projects, each telling us about their approaches to increasing resource efficiency through digital innovation. Each presenter has 12 minutes, and then we have time for one comprehension question from the audience. After we heard all 3 presentations, we will be joined here on stage by the 3 presenters plus 3 external experts, which I'm going to introduce to you later. And then together we want to discuss the opportunities and challenges of implementing such solutions across industry. Again, also in this discussion, there will be the opportunity to ask questions from the audience. I think that's all for our plan. And of course, please turn off your cell phones. Let's start with the first project. The first project is Reduce. And in a second, I would like you to welcome with me Dr. Sven Gleich. He's the team lead of advanced robotics at Vitesco Technologies. And he's going to tell us how to increase resource efficiency through human-machine cooperation. Mr. Gleich, the stage is yours.
It's a pleasure for me to be here today at Digital GreenTech and present you our project Reduce. My presentation is called Human in the Loop, Resource Efficiency through Operator Interaction. Our project was driven by 3 project partners. My name is Sven Gleich, as already mentioned. I'm from Vitesco Technologies, which is now a part of Schaeffner Technology AG, and we have business in the automotive supplier industry. Then the second partner was the Chemnitz University of Technology, in particular the Department of Human Cyber Physical Systems, with a broad knowledge in cognition-based human technology interactions. And finally, our third partner was the company Visualistic, or Technische Visualistik from Dresden, which develop software solutions and in particular are focused on complex data processing and visualization. In our project, we had the main goal to reduce resource consumption on the shop floor, that means in production environment. We wanted to reach that if we unite different process areas. That means on one hand digital and technical processes, and on the other hand human interactions, that means work and cognitive processes. Our goal was also to develop tools and measures and applications for a direct application on the shop floor itself. That means we want not stay on a theoretical module, we also wanted to implement it on the production floor with a high transfer value. I would like now to start with the transdisciplinary approach to explain you a little bit how can we come close to the solution. At the beginning, we started with analysis of the production. We have approximately 1,000 employees at our shop floor, together with a broad diversity of production. It means we had to select one area where we can work on. Some of the production is very automized with many of robots, but we have also places where people are working still on the line. And this was our field. Then we wanted to put the human in the center of our activities. That means we started with collecting data at the line, with interviews, with surveys, and asked different people and managers what area could be focused on. After the database preparation, the installation of some hardware on the line, I will explain it a little bit later. The University of Technology Chemnitz started to create a psychological model, and also based on that, which decision-making process has to be implemented. After user research and based on also with the empirical knowledge which we gathered, we started to create a decision logic and also to design our visualization system. With that, then we were able to install a pilot on the shop floor. Always we had to keep in mind that we have to balance between the data which we collect, which we present to the user, and to support him in his actions, to not overload his typical workload, because the main task still is to operate on a line. Our mental model then showed in a cognitive map that we have more than 1,500 paths which lead to a certain decision to be resource efficient, which is far too much to implement in every detail in the software model. That's why we started to compress those solutions and implemented a so-called recursive decision manager, which then were implemented in our backend. With 2 front ends, we also needed some aspects to cover the visualization for the user and also the interaction. if you have now a look at the pilot area, you see here the production line which we used. It's a testing line. Maybe most important to know is that you have 4 testing modules which have the same task, actually. And depending on the state of the system itself, you could even switch off a module which consumes energy, but not decreasing the output of the line. That depends on how is your NOK-OK quote, how much parts do you put on the line, and so on. The modules itself, this is kind of a product. It's an injector for internal combustion engines. The modules itself have been equipped with smart meters, which were able to send data directly to the cloud in a approximately 1 to 3 second interval to collect the energy data. Furthermore, we also used the production database to gain the status of the line itself concerning which module is running, which testing head has, for instance, a fault, and maybe is there any cycle time optimization necessary. Now let me give you some insights about the visualization solution which has been installed. It consisted overall of 3 parts. One of the main parts was the display to show the user, the operator, the actual state of the system in terms of energy, historical-wise for the last shift, but also in the current status. That means we also use the comprehensive logic about green, red, and yellow line to show if it's still in a resource-efficient manner operating, or is he already touching the boundary to less efficiency, less energy efficiency. The second component was a touch display for human interaction for the operator. It gives him the possibility to react. That means, on one hand, to give feedback if he was able to carry out the proposed action or not. Then he was able to get some more information about the current, let's say, proposal. Sometimes we realize that operators will not follow the recommendation system because they need just more knowledge to get insights and to say, okay, I agree or not. It was still on a kind of voluntary basis. Our system consisted in a third part and a controller, which we, at the end of the project, programmed to simulate the behavior of the line. It was able, or this gives us the ability to present that project also on fairs and conferences, and this is also the point to invite you, maybe afterwards in the break. In another room, we have a small demonstration available to show you our system which we have developed. Overall, the system was able to support the operator during line optimization and cycle time optimization, for instance, which also leads to energy efficiency, but on the other hand also to detect technical faults, repairs necessary, or even the idle state where the operator should usually turn off the line itself. The pilot phase consisted of 3 parts. The first part was the control phase itself, where we gather data without activating our system. That means we have like a reference basis. Then following was the introduction of the reduced system to the operators itself, where they should give some introduction about the usage itself, how to interact with the system. They were also giving us questions what we could make better during the pilot phase, and then we started with the test phase in stage 2, finally by group discussion in stage 3. Overall, we got consistently positive feedback on our system itself. We realized that the people accepted it, that they used it, but on the other hand, since it was like a voluntary participation, we could actually finally also figure out that even if the system proposed the user, please turn off the line, he was not always doing it that. But this is actually something which has to be solved during the hierarchy of a company, since some operators, although they are empowered to do that, they will not do this. Still, as I said, it was voluntary, so we cannot force them to just do this and that. Now let me come to conclusion and transfer. On this diagram, you see from the left to the right the energy consumption in green bars on a weekly basis for the test line, together with an orange bar which shows you the amount of products produced on that line. And if you start to compare pairs with the approximately same amount of energy, you recognize that although you use, for instance, 4,000 or 8,000 kilowatt hours in a week, you have on 1 week maybe 6,000 injectors, and the other week only 3,000. It's barely the half. But you use the same amount of energy. So this showed us that basically just by proper interaction is able to produce 2 times more injectors or products with the same energy consumption. In our pilot week, where we operated this line by ourselves, since we were, let's say, strictly following the messages from the system, we achieved an energy consumption of about 1,300 kilowatt hours per 1,000 parts, which finally is close to the optimum which we recognized during approximately 1 year of pilot phase for 1,200 kilowatt hours. If you now scale this to 5 lines, which are only at our company available, for 48 production weeks, you could achieve a resource saving of about 200,000 kilowatt hours. This is just the electrical power consumption, which you could reuse, but the side effect would be also to use less water consumption because those lines are usually also cooled with cooling fluid. Now some of our experiences and the final conclusion of the project. We could show that resource efficiency can even in a highly, let's say, zero productive line implemented on the shop floor, and we could also show that sustainability can be brought to the operator on the lowest level, let's say, in a production itself. We figure out that our pilot solution has already a high maturity. It has it's modular and transferable, and I will not read now during the time, or because of time, to all those aspects here, but maybe what we experience in our field, let's say, area, that we should, or at least at the shop floor, you should avoid to use technologies which could be interpreted as control mechanism. Usually we made the experience that operators, even if you have just a QR code scanner there, they somehow feel still controlled, right? They will not probably use the system as you intended to be because they feel controlled. On the other hand, in development, I could give the recommendation that always aim for a real world product or solution and start from the bottom and make your steps upward to the final solution. Now some words about transfer. As already mentioned, we could embed sustainability directly on the shop floor. We could act situation specific in a real world environment because it was real production, it was not just a model. We could use a psychological founded model and implement it technically to, let's say, create a common language between the user itself, that means the human, and the machine. Furthermore, we could empower operators to act as a source efficiency. That means we did not implement basically something to switch off the machine. We left it to the operator to give him also like a motivation and to understand what he's doing. And finally, currently the rollout of 5 additional lines is under investigation. The results of the project has been presented on several scientific and economic conferences. I would like to thank you for your attention. I would like also to thank the BFDR for funding our project and our project team for the real, truly inspiring work after 2.5 years. Thank you.
Thank you, Mr. Gleich. Stay with us for a second, because we have time for one question from the audience. Yes, the microphone is coming to you. And then please stand up. That would be great for the camera behind you.
Ja, vielen Dank für den Vortrag. Eine Verständnisfrage. Es ging darum, glaube ich, in der Entscheidung, Energie zu sparen, indem man Module abschaltet. So, ja. Ne? Gab es da dann einen Zielkonflikt zu anderen Zielgrößen, zum Beispiel, dass dann die Durchlaufzeiten länger werden oder sowas? Oder ist das sozusagen kongruent auch mit Kostenminimierung?
Nein, es war kein Zielkonflikt. Typischerweise haben wir festgestellt auf der also Englisch-Deutsch? Deutsch, richtig, ja?
As you like.
As you like, okay. Dann stay in German. Wir haben festgestellt, dass auf dem Shopfloor haben Sie viele Bediener, die sagen, wir lassen es einfach eingeschaltet, dann läuft es wenigstens. Diese Denkweise zu sagen, ich schalte jetzt mal bitte ab, weil es brauche ich einfach nicht, die ist noch gar nicht existent. Und weiterhin ist es so, dass viele Leute sich die sind sich gar nicht bewusst, wie viel Energie da eigentlich verbraucht wird. Ja, wenn man ihnen sagt, 18 Kilowatt, sagen die, ja okay. Wenn du ihnen aber sagst, okay, eine Woche lang läuft die Linie, wenn die nichts macht, verbraucht die so viel in den Haushalt im ganzen Jahr, dann macht es plötzlich Klick und die Leute denken, wie kann das sein, so viel? Ja, weil sie immer irgendwie einen Bezug brauchen zu ihrem privaten Leben. Und ja, wir haben festgestellt, wenn man die kann man die Module abschalten und sie produzieren nicht weniger. Zum Teil, weil sie eben gar nicht so viele Teile haben, die sie auflegen können. Aber Hauptsache, es läuft alles eingeschaltet, alles betriebsbereit und trotzdem ist es eigentlich zu viel des Guten.
Okay, danke.
Thank you very much. Thank you very much, Mr. Gleich. And we're gonna directly go to the next presentation. The next presentation is from Professor Benjamin Leiding. He's at the Institute for Software and System Engineering at the Technical University Clausthal. He's going to talk about SOREC, and specifically he's going to tell us how to make eddy current sorting machines smarter with digital technologies and built-in AI. Welcome on stage.
Yeah, thank you very much. Also, warm welcome from my side. I have to pay attention that I stay close to the microphone because I have a tendency to walk around rooms while talking. So please get me back if I'm starting walking too much. So, yeah, SOREC, our project, and this was our object that we spent about 2 years with. This is a so-called barrier eddy current separator. That's a small lab machine, but the big ones don't look much different, just a little bit slightly bigger. And they are made to separate so-called non-ferrous metals from other things. Non-ferrous metals could be aluminum, copper, brass, something like that, so everything that is not magnetic. And they do so by pushing material over that band, and just below that band is essentially a magnetic drum. It rotates, and then the non-ferrous metals, they jump up to the one side and the rest stays on the other side, and this is how you can separate certain aspects. The problem with that machine, it is, even though this technology has been around for a while, it is extremely stupid. It does not understand if there's too much material on the band, it does not understand if there's too little on the band, it doesn't really notice if any malfunction occurs, like for example there's a magnetic piece of iron on it, which then starts to heat up and is glued to the surface, or to this conveyor belt. So it's not really smart. It actually runs with analog buttons. And when we first started, we had this test machine, but we also had a bigger machine with a not consortium partner, but a collaboration partner in Austria, where we could have used the same approach. But yeah, this is where we essentially started. And the material that you get for those eddy current separators that you usually try to separate as best as you can comes mostly from electronic waste. And the more different resources you have in this, and there are 50, 67 different resources in this thing, you want to get all of them out and also as perfectly separated as possible. And the more small stuff is in there, the finer you have to shredder this material. The finer it gets, the more complicated it also gets. And this is essentially where we started. So this machine, making sure that it perfectly, or as good as possible, sorts as much material as possible. The faster you run it, the worse it sorts. The slower you run it, the less output you get, but the better the sorting quality. So this is a little bit the dilemma that we faced in the beginning. And I brought you just 4 pictures to get a little bit of an idea about the sorting size that we're talking about. So 4 millimeters works quite nicely. You can actually look at it and sort it by hand if you have to. 1 millimeter on the other side, getting a little bit more complicated. So you can't really, it's getting more complicated to tell it apart. So we mostly, also due to our industry partner request, focused on the 4 and 3 millimeters because they said this is what they are mostly having at the moment. Future work then definitely having to go in the direction of 1 millimeter. And yeah, how do you start that? First, making the machine capable of being smarter by removing all the analog buttons and installing various types of sensor and digital control equipment so that you can actually understand how fast is the belt running, what's on the belt, and so on and so on. So first, our partner ESD Technology set up a digital control panel, PLC, and we also installed various types of camera. At first, we went a little bit crazy and just installed as many cameras and different types of cameras as we could because we didn't really know what gives us the best results. So we had very classic GoPro cameras because they can record at very high resolution, very, very fast. We had 30-euro USB cameras. We had a 5,000–6,000 euro line scan camera. So we tried to incorporate various types of cameras, also heat cameras, and so on and so on. In the end, then we had a little bit of a minimal setup, but that goes a little bit beyond this 12-minute discussion. So We installed all of that, we added a few more sensors as well, and then we ran various test runs to first record initial sets of data. First for the cameras, as of course, and the sensors, but then also to get an idea of the sorting quality without any interference. Like if we run the belt that fast with that much material, how good is the sorting quality? And the only answer, or the only way to find that out, is paying a lot of heavies to check manually how good the sorting quality is. So thank you very much to all of you who suffered. One thing that we first looked at, and I'm like just really skimming through the different parts of the results due to the 12-minute limitation, is checking with the cameras like what type of materials are on that belt. Of course, not in real time and not for everything, but more taking different types of sessions, because usually you get a big chunk of new material that is somehow homogeneous in that one batch. So you take certain aspects or like certain parts of those video streams to get an idea of what should the sorting look like, what should be expected, how do we calibrate the machine to get a good sorting quality given a certain output for this new batch of material. And the system then could start classifying various types of material quite nicely. You also see, like for the different bounding boxes, like how sure is the system that this is, for example, actual copper, so 39%. It got successively better and better and better. Usually at the end, like we were somewhere north of the 70 to 75%. You also don't need 100% of accuracy because we're talking about very large amounts of very small material. So I mean, before that you had no clue at all and you could not calibrate anything. So we're pushing the boundaries a little bit to getting more efficiency there. So understanding what's in there to calibrate the machine to process as much material as possible was one of the first aspects that we did. Another aspect that used to stop the production is either having too little material on the belt, too much material on the belt, but also the wrong type of material, because when you shred a lot of electronic waste material and pre-sort it so that you only have the non-ferrous stuff, things could go wrong in the previous steps. If the shredder settings are wrong, you get a lot of material that has potentially very sharp edges, which once again then is really bad for a conveyor belt, which then could be damaged. Then you have to stop the machine, have to replace a lot of conveyor belts, or at least repair them, and you don't really want that. It also tells you that something in the previous steps went wrong, what you do not want to continue for a longer time. So for example, detecting those kinds of malfunctions in previous steps is also another aspect that we integrated into the system, so that we're not just detecting what type of material it is, but also the sharpness of materials as one example. Another aspect goes in the direction of thermal imaging. As I said, if you have suddenly ferrous metals in there that are magnetic, because the magnetic drum is below the belt, it essentially then glues the magnetic thing to the belt. It starts to heat up and either burns through the belt or could even cause a fire, depending on what other stuff is in the material mix. You also don't really want that to happen. On one hand, of course, is operational safety, but also human safety, because a lot of humans, or in the past, like for those stupid machines, humans were mostly essentially checking those machines by standing next to them and making sure that they don't clog, that there's enough material, that there's nothing sharp or whatever on those belts. You can do this more remotely now, but you also make sure that they don't have to be in this very uncomfortable and noisy, dirty environments. Those were like now just 3 examples of certain aspects that we implemented. Of course, we didn't just like put those 3 things there and said we're done. There is a more complex IT infrastructure behind that. So essentially we built a larger system that can operate or monitor not an arbitrary, but a large amount of those eddy current separator machines. So it's not just a single solution for one barrier eddy current separator, but it's more from the perspective of an industry partner who has many of those machines, or someone who's operating that software for industry partners who have barrier eddy current separators. So each of them gets a different location. Each of them is then connected with all of the sensors. Each of them has a digital twin to represent the current state of the actual machine at a certain location. And we filter in all of the sensor data, but then also deployed various types of AI models that the partners could select for their personal barrier eddy current separator, and then also say, okay, this is how much I want to optimize certain parameters. So we're not going to go through that figure in detail. It's just to show, okay, we have bigger system architecture available there, and you can also grab the code for everything there because we just made it open source, so feel free to run with it and have some fun. Same goes for all the images, all the AI models and everything. We even put all the data sets online, so enjoy. Good. Conclusion, also very short one. So we started with this initial problem of trying to sort as much material as possible while keeping a certain sorting quality that has predominantly an economic perspective in mind. We want higher throughput, but with the best sorting quality in mind. And we made quite some good progress in that direction. Of course, it's not perfect yet, but much, much better than the stupid machine initially. We also reduced downtimes with these early fault detections. So the sharp pieces, the wrong materials that cause potential fires. We also built in some mechanisms that can detect the deviations of the belt if they get a little bit loose over time. So that reduced a lot of the downtime. And we could also schedule the downtime ahead of time to, for example, account for those loose belts at times where little material was processed in the first place. By monitoring everything remotely, we also lowered the operational cost and also made sure that people did not have to sit next to the belt in these very uncomfortable working environments. So there was, like, from the economic perspective, quite a few parts on the plus side. From a scientific, technical perspective, so we built this digital twin for those eddy current separators. We created the machine learning models. We built the software platform. We made everything open source. You can run it with it. Societal, ecological perspective, short, like if you have more material being processed in less time with a higher quality, you don't have to put the same material in the sorting process twice or 3 times. And also you can process much more of this electronic waste material, which is just getting more and more because we're buying more and more smartphones or more screens and other electronic gadgets that we do not use as long as we should. What's the next steps? We talked with further industry partners. ESD Technology, as our industry partner, also is currently checking if we can use this with as kind of a licensing software system, or if they just help as a consulting gig to get this working for customers. And we also published quite a few papers about this. And if there are any further questions, happy to either answer them later or just drop us an email.
Thank you, Mr. Leiding. Are there any questions at this moment? Someone who wants to break the ice? Okay, then
probably
we have
not many people who have a barrier eddy current separator at home, I guess.
Probably, but we also have time for more questions later. But thank you for now, Mr. Leiding.
You're welcome.
We come to our third project, which is Kimber, and our last presenter for that project is Lieve Goebbels. Ms. Goebbels is a research assistant and PhD student at the Department of Anthropogenic Material Cycles at the RWTH Aachen University. In their project, they have used AI and sensors to check and improve the quality of recycled materials, and she's going to tell about us now. The stage is yours.
Yes, thank you very much. So we're going to stay in very noisy and dusty environments. With the Kimber project, it was very nicely introduced, so I can directly move forward to a little bit of project background. So it was also funded by the BMFTR, and we finished the project this August. It lasted for 2 years. And the overall goal of this Kimber project was to provide a very technical solution to sensor-based and AI-based quality monitoring for construction and demolition waste processing. And we did so by analyzing the particle size distribution of this material. And maybe as the most important aspect also with the transfer in mind is to place this project at a very high technology readiness level. So to do this and to achieve this, we are together with several industry partners in this consortium who provided a lot of industry expertise, and those are MAV, Point 8 and kamen GmbH. And we combined all of this expert knowledge with the more scientific perspectives from ANTS, DFKI, and ProTech. And we also take very great value still in the two associated partners, Vero and VDMA, who are also here today, who really helped us to collect the perspectives from the different companies in this sector. So what then is our motivation behind this project? As many of you probably know, the construction and demolition waste stream is the biggest one we have in Germany, and a significant part of this waste stream still gets landfilled, even though obviously a significant part gets also recycled, and these recycling aggregates get produced. When we look at these recycled aggregates, most of them go into civil engineering, and still a very small part in the highest grade recycling, namely for the use of building new buildings with this recycled material. What we would then like to have, see if it works, yes, is on the one hand to minimize the amount of this waste stream that gets landfilled, so to increase the stream that goes into this recycling process, and then also to increase the amount of recycled aggregates that go into this highest grade of recycling applications to also meet the demands that are occurring there. When we then look at this production process in more detail, we see a very big gap, namely that the quality factors such as particle size distribution are still being analyzed by hand, and this leads to a very big time delay, a large sampling error, and also generally higher costs. So a solution would be to implement a sensor system that works, for instance, on machine learning or AI, to automatically and completely monitor this output stream in terms of its quality. And in the best case, this would not just mean a sensor-based quality monitoring, but also an excellent basis for this adaptive process control to, in the end, not just monitor the quality, but also improve it. And in the context of this project, we took a mobile comminution process, so an impact crusher. And in this context, there are two possible positions for the sensor system to be placed. And since we want to monitor this output stream in terms of its quality, we decided to place the sensor or the system at the very end of this comminution process. So given this entire context, we identified or determined three main goals within this project, which is first the proof of feasibility of this monitoring system, then also the demonstration and the validation of this sensor-based system, and third, to move beyond this mere quality monitoring, also the development and demonstration of an AI-based assistance system as a precursor to this adaptive quality control. So when we then look at the machine learning pipeline in more detail as part of this process, we see that it consists of multiple modules, starting with the segmentation module, who takes the raw data and processes in this way that all of these particles are segmented, so singled out and processed to the next module. So this segmentation module is able to segment over 1,200 particles per image and is able to identify particles starting from a 4 millimeter size. So then the next module, which we are still optimizing because it's such an interesting aspect, takes all these single particles and simultaneously performs a classification and a weight prediction of these single particles. using the laboratory data ranging from 2 millimeter to 63 millimeter and a weight of the particles between 1 milligram and 231 grams. We thus far were able to achieve an 84% accuracy overall for the classification and a maximum weight prediction error of around 15 grams, which is very promising. So all the information we collected in these previous models is then combined and visualized in the last model, which also functions as an assistance system to achieve this live monitoring also on the plant. So what that then looks like in practice is best shown with this video. See if it works. It doesn't. Well, I also have the video as an exposition part, so feel free to come by. Regarding the goals, for the first one, we managed a successful integration of this entire sensor-based system and also have extremely promising results for the AI solutions using laboratory and technicum scale data. For the second goal, we were able to also implement the complete software pipeline, but also came to the conclusion that some further optimization in some aspects is highly desirable, and that it would also be extremely interesting to use different material types within this construction demolition waste stream to see how generalizable this pipeline in fact is, and to also stably and robustly achieve these higher technology readiness levels. For the third and final goal we had, we achieved a very robust simulation and also live recording of the machine data. But here too, we would need a little bit more data and especially higher data variance to create a very exhaustive AI-based assistance system. So we also had several discussions with industry experts in the different parts of this sector, among others together with Frau Grunewald, who really supported us there. And we kind of identified a couple of categories of additional hurdles that would need to be solved next to this mere technical solution. So very briefly, these regard acceptance, material flow management, costs, the quality, which Kimba would be a part of, but also analytics and storage. So what can we then conclude from all of this? Our technical solution, so our project, has a lot of potential in terms of marketing opportunities, contributes to a very constant product quality, has the potential for improved data and data transparency, and also more efficient plant utilization. But we should not forget that our research is only one brick of the building, and that numerous bricks are still missing, and that especially a very intensive exchange between all actors in this sector is necessary to achieve this common goal of increasing the circularity in the construction industry. With that, I would like to thank you for your attention, and I'm always open to questions. I also have some sample material, so feel free to have a look, and thank you.
Thank you. Thank you very much. Who's got a question for Ms. Goebbels? We have one question in the back. Could you stand up, please?
Ach, sorry. Yes. Ich würde es gerne im Deutsch fragen eigentlich.
Ja, klar.
Was war eigentlich die größte Herausforderung in dem Projekt gewesen?
Also es gab mehr als eins, tatsächlich. Also was eigentlich auch heute diese Fokus-Thema ist, was ist diese Transfer? Also es gibt ja riesige Fortschritte im Laborbereich, wo dann auch sehr hohe Genauigkeiten erreicht werden können. Das ist dann zum Beispiel mit Partikelgröße ab 16 mm. Wir haben hier Größen ab 0,063 mm. Und um dann diese Technologien wirklich in so Pilotenmaßstab, Industriemaßstab zu transferieren, das ist der Riesenherausforderung. Zum Beispiel auch, weil viel von dieser Sensorik, was wir im Projekt genutzt haben, eigentlich gar nicht dafür ausgelegt ist. Also es sind sehr raue Umgebungsbedingungen. Das ist alles sehr schön und stabil im Labormaßstab, aber wenn dann 50G also mit betrachtet werden sollen, dann wird es auf einem ganz schwierig.
Thank you very much. Do we have another question? Okay, then thank you for now. You can remain here on stage and just go over there, and I would also like to invite Mr. Gleich and Mr. Leiding to come up. And now I'm switching to German. Die drei hier kennen Sie schon. Wen Sie noch nicht kennen, sind unsere drei externen Experten, die wir eingeladen haben, um mit uns über die Potenziale, über die Herausforderungen von diesen Technologien zu diskutieren, aber vor allen Dingen natürlich auch, wie diese Ergebnisse in die Breite getragen werden. Deswegen hat die Diskussion auch den schönen Namen Transferdiskussion. Ich beginne als erstes mit Dr. Alexander Jans. Dr. Alexander Jans ist seit 2021 Leiter der Abteilung für nachhaltige Produkte und nachhaltiger Konsum Kreislaufwirtschaft beim Bundesumweltamt in Dessau. Zuvor war er von 2009 bis 2021 stellvertretender Leiter des Referats Vermeidung und Verwertung von Verpackungsabfällen, Werkstoffrückgewinnung im Bundesumweltministerium. Sehr geehrter Herr Jans, schön, dass Sie heute bei uns sind. Als nächstes bitte ich Sie mit mir Barbara Grunewald zu begrüßen. Barbara Grunewald ist seit über 4 Jahren als Geschäftsführerin Technik bei Vero, dem Verband der Bau- und Rohstoffindustrie, tätig. Zuvor war sie Projektleiterin in der Prüfstelle für Bauprodukte beim Institut für unterirdische Infrastruktur. Sehr geehrte Frau Grunewald, schön, dass Sie sich heute die Zeit genommen haben. Und last but not least freuen wir uns auf Tim Bichelmeier. Tim Bichelmeier ist Projektleiter bei der Prognos AG. Sein Fokus liegt hier auf der ökonomischen Analyse grüner Geschäftsmodelle, ihrer volkswirtschaftlichen Wirkung sowie ihrer Bedeutung für die Transformation hin zur Klimaneutralität und zur Erreichung einer zirkulären Wirtschaft. Sehr geehrter Herr Bichelmeier, herzlich willkommen. So, ich hole mir auch nochmal meine Uhr, damit wir hier auch in der Zeit bleiben. Herr Gleich, Herr Leiding, Frau Goebbels, vielen Dank, dass Sie auch nochmal auf die Bühne gekommen sind. Wir wollen jetzt in der folgenden Diskussion uns vor allen Dingen auf unsere 3 neuen Gäste fokussieren, aber nichtsdestotrotz freuen wir uns, dass Sie dastehen. Jump in at every time, wenn Sie noch mal was klarstellen wollen, wenn Sie was beizutragen haben, aber vor allen Dingen natürlich auch stehen Sie zur Verfügung zu Fragen aus dem Publikum. Das heißt, wie auch gerade eben, haben Sie die Möglichkeit, Fragen zu stellen. Wir gehen mit dem Mikro um und dann stehen alle hier bereit, die zu beantworten. Gut. Herr Jans, Frau Grunewald, Herr Bichelmeier, ich fange mit Ihnen an. Sie haben jetzt die Ergebnispräsentation von den 3 Projekten gesehen. Wenn Sie morgen in der Kaffeeküche des Bundesumweltamtes, der Prognos AG oder bei Vero stehen und dann kommt Ihr Lieblingskollege zu Ihnen und sagt, sag mal, du warst da gestern da hier auf dieser Präsentation oder auf dieser Panel-Diskussion. Wie war es eigentlich? Was antworten Sie? Was hat Sie am meisten beeindruckt? Ich würde mit Ihnen anfangen, Herr Bichelmeier.
Ja, gerne. Das ist eine schöne Frage. Ich glaube, wenn ich morgen in der Küche sitze, neben meinen KollegInnen, und die Kolleginnen, mit denen ich meistens spreche, arbeiten an ähnlichen Themen, oft an Analysen rund um den GreenTech-Sektor, die Umweltwirtschaft, grüne Geschäftsmodelle. Uns begegnen viele gute Ideen, viele gute Konzepte, um Transformationen anzustoßen. Aber was uns in der Arbeit immer wieder begegnet, sind Herausforderungen in der Anwendung innovativer Ideen, die Übersetzung von guten Ideen in die Praxis. Und hier eben 3 Beispielprojekte zu sehen, die genau das auch in den Vorträgen jetzt explizit betont haben. Ja, stimmt mich ganz positiv. Das werde ich also meinen KollegInnen auch berichten.
Sehr gut. Vielen Dank, Herr Bichelmeier. Herr Jans.
Ich würde berichten von 3 sehr interessanten Vorträgen, 3 sehr interessanten Projekten. Und ich würde darauf abstellen, dass mir bei 2 Vorhaben oder bei 2 Projekten, insbesondere das SOREC- und KIMBA-Projekt, sehr gut gefallen hat, dass offensichtlich eine gute Optimierung von vorhandener Technik stattfindet. Durch das Auffüttern von Rechnerkapazität, dass hier also ja im ganz positiven Sinne Low-Hanging Fruits mit digitaler Technik, mit KI vorangebracht werden. Und ohne ein Produktionswissenschaftler zu sein, würde ich auch darauf hinweisen, Mensch, über das Thema Reduce, über das Vorhaben Reduce, das fand ich doch sehr interessant. Ich habe da an der Stelle die eine oder andere Frage, was die Übertragbarkeit der Transfer angeht auf andere Produktionsprozesse. Aber auf jeden Fall war das ein sehr interessanter Ansatz. Das würde ich zunächst einmal berichten.
Vielen Dank. Frau Grunewald.
Also mir geht es ähnlich wie den Kollegen. Also ich finde gerade diesen Ansatz, dass es wirklich Probleme aus der Praxis bedient hat und mit der Praxis zusammengearbeitet hat und da Lösungen gefunden worden sind, finde ich besonders gut. Und da ich ja natürlich auch aus dem Bereich quasi der Bauschrotaufbereitung auch komme und der Rohstoffgewinnung, finde ich solche Themen nur super spannend und würde sagen, das müssen wir auch bei uns in der Branche mehr pushen und auch bekannt machen. Denn das ist jetzt eine Firma. Ich denke, das ist auch bei den anderen Projekten so, mit der die Zusammenarbeitung dann stattgefunden hat, wo es quasi angewendet worden ist. Natürlich waren viele daran beteiligt, aber das muss einfach mehr in die Breite getragen werden. Denn bis es dann tatsächlich überall ankommt, dauert das einen Moment. Und das muss man einfach mit pushen.
Mhm. Vielen Dank. Da haben wir schon zum ersten wichtigen Punkt bekommen, nämlich der Übertragbarkeit. Und ich würde direkt mal bei Ihnen bleiben, Frau Grunewald, und auch bei der Frage der technischen Übertragbarkeit. Sie haben viel Erfahrung mit Unternehmen, Sie haben es gerade gesagt, in der Bau- und Rohstoffindustrie, auch vielen kleinen und mittleren Unternehmen gerade. Wo sehen Sie die größten technischen Hürden, aber auch die Chancen bei der Integration solcher Systeme, wie wir sie gerade gehört haben?
Also Hürden gibt es, glaube ich, doch noch eine ganze Menge. Also da ist zum einen die Hürde der Mensch, aber Sie haben ja nach technischen Herausforderungen gefragt. Das muss dann wirklich in den Alltag und in den eigentlichen Aufbereitungsprozess eines jedes einzelnen Unternehmens angepasst werden und da reinpassen. Und wenn man dann weiß, okay, es gibt so einen Sensor, der kann das, aber wie teuer ist der, wie setze ich den ein, muss ich dafür jemanden schulen? Da sind dann direkt ganz viele technische Fragen offen. Muss ich eine Software kaufen? Läuft die auf meinem Rechner? Brauche ich dafür den einen bestimmten Brecher von der einen Firma? Muss ich mir vielleicht einen neuen Brecher kaufen, eine neue Siebmaschine? Die sind auch nicht ganz günstig. Und diese Fragen hat jeder sofort im Kopf und dann ist man schnell in so einer Tiltposition und sagt, okay, ich schiebe das mal beiseite. Und diese technische Herausforderung in dem Sinne muss man direkt mit Überzeugung auch begegnen. Und die Chancen, die ich darin sehe, was demnächst an Anforderungen an die Unternehmen, auch teilweise aus Europa, zukommt mit Nachhaltigkeitsangaben, das wird extrem. Und das kostet sehr viel Manpower. Und da ist es gut, wenn man auf anderer Ebene auch bessere Qualität schaffen kann und auch weniger Manpower da vielleicht braucht, damit man sich einfach am Markt weiter überleben kann und trotzdem noch die Anforderungen alle erfüllen kann.
Vielen Dank, Frau Grunewald. Ich habe gerade schon Nicken von Ihnen 3 gesehen. Haben Sie zur Frage der technischen Übertragung Chancen, Risiken, schon Erfahrungen in Ihren Projekten gemacht, die Sie an der Stelle einmal teilen möchten?
Also vielleicht kann ich da ganz kurz ergänzen. Wir haben ja viele Akteursworkshops auch mit ganz vielen Unternehmen im Bereich gehabt. Und was uns so positiv überrascht hat, ist, wie motiviert die alle sind und wie positiv die gegenüber also das KIMBA-Projekt und die technische Lösung stehen. Also sehe ich da eigentlich vor allem diese positive Schritt. Genau.
Weitere Ergänzung, sehr gerne.
Bei uns war es eher so, dass man im Produktionsbereich weniger erkennt, dass man diese Daten braucht und sammeln muss. Ja, die meisten Leute sagen, warum brauche ich Energiedaten? Das Produkt fällt auch so vom Band.
Wir kommen aber andererseits, was Sie sagt, Frau Grunewald, zu dem Punkt, dass wir auch auf unser Boot in Zukunft so ein Nachhaltigkeitslabel draufpappen müssen. Ne? Wir müssen sagen, wie viel verbrauchen wir Wasser, wie viel Kilowattstunden pro Teil am Ende des Produktionsprozesses. Und das können Sie heute nur sehr schlecht tun, wenn Sie das auf Hallenebene ermitteln. Das heißt, wir müssen schon in die Linien gehen, wir müssen in die Module gehen und müssen die eigentlich einzeln mit Sensorik ausstatten, was uns dabei geholfen hat, dass man vielleicht mit einfachen Lösungen beginnt, nicht gleich eine super-duper-Lösung für mehrere tausend Euro, weil wenn Sie dann feststellen, das ist eine Sackgasse, dann war das Geld einfach umsonst und die Manpower. Also besser mit einfachen Lösungen beginnen und schrittweise die Daten sammeln und dann auch damit zu lernen, mit der Menge an Daten zurechtzukommen und vielleicht auch auszusortieren.
Ja, ich könnte jetzt noch mal kurz dann abschließen. Also die Frage der extra Kosten ist ja auch etwas, was wir dann, deswegen haben uns ja mehrere Kamerasysteme angeguckt. Ich weiß nicht, ob man mich immer noch hört. Um zu gucken, was ist denn das günstigste Setup, was eigentlich das optimale Ergebnis denn herausholt. Muss es ein 5.000 € System sein oder reicht es auf die 30 € Amazon-Kamera? Die Antwort ist teilweise ja. Um auf die Frage zurückzukommen, mit dem, wo die größten so Transfersachen sind. Also wir haben das auch festgestellt beim Einsatz der Maschinen in Partnerunternehmen, dass natürlich die Menschen, die jetzt eigentlich die Maschinen sonst bedient haben, betreut haben, nur bedingt wirklich begeistert davon waren, dass da jetzt so ein KI-System um die Ecke kommt, was den Job 24 Stunden am Tag macht, in der Regel sogar noch effizienter, weil was mache ich denn jetzt hier eigentlich? Da könnte man jetzt natürlich mal so ein bisschen in die Richtung der Politik gucken, dass dort natürlich dann auch Perspektiven geschaffen werden müssen, weil jetzt einfach zu sagen, okay, wir leben jetzt damit, dass wir weniger Rohstoffe zurückgewinnen und dass wir dann offensichtlich eventuell auch mal irgendwann die Rohstoffe ausgehen, nur damit jeder seinen Job behält und wir uns gegenseitig beschäftigen, ist ja irgendwie auch nicht die Lösung der Zukunft.
Da haben Sie jetzt an mehreren Stellen schon so ein bisschen den Punkt angesprochen. Entscheidend ist auch der Faktor Mensch. Ich stelle die Frage mal in die Runde und gucke, wer sie ausgreift. Welche Rolle spielen denn menschliche Faktoren für die Skalierungsfähigkeit digitaler Lösungen? Sehr gerne, Herr Jans.
Ich denke, dass insbesondere das Vertrauen in Prozesse, die beispielsweise jetzt gerade vor diesem etwas geheimnisvoll daherkommenden Begriff KI stehen, dass das vorangebracht werden muss. Das heißt, dass die Datenbasis, mit der eine KI gefüttert wird, gut sein muss, dass der Prozess effizient läuft und dass er den Mitarbeitenden unterstützt bei Entscheidungen wie beispielsweise beim Reduce-Projekt. Und dann, wenn diese Akzeptanz steigt, wenn dieses Vertrauen steigt, dann sehen das die Mitarbeitenden, dann sehen das die Menschen wahrscheinlich auch als wirklichen Mehrwert an. Und die Abneigung oder diese innere Furcht vor KI wird reduziert.
Wie auch die Frage an alle, was für weitere Möglichkeiten gibt es, dieses Vertrauen aufzubauen? Geht es darum, die Mitarbeitenden von Anfang an mitzunehmen? Geht es darum, zu erklären? Geht es darum, Befürchtungen abzubauen, sowohl Ihre Erfahrung in den Projekten als natürlich auch Ihre Erfahrung? Frau Grunewald, gerne.
Also ich finde, da ist so die Validierung auch ein wichtiges Thema, gerade wenn man über Qualität und Qualitätssicherung spricht. Wenn dann eben zum Beispiel jetzt bei dem Kimber-Projekt zu bleiben, wenn da eine Korngrößenverteilung ermittelt wird oder die Korngröße bestimmt wird und man macht das händisch, dann muss da das gleiche Ergebnis bei rauskommen. Und das muss man dann quasi 100 Mal machen. Und wenn immer das Gleiche bei rauskommt, dann vertraut man dem. Und ich glaube, das muss man auch selber machen. Und das ist nicht so, dass wenn man einem erzählt, ich habe hier 100 Mal gesiebt und 100 Mal mit dem Sensor das bestimmt und es war immer das gleiche Ergebnis. Man muss es einfach selber machen und dementsprechend sind so, sage ich jetzt mal, Workshops und Vorstellungsrunden oder mal, sage ich jetzt mal, ausprobieren da ganz wichtig. Und wenn man selber Erfahrungen macht, dann sind das immer die besten Erfahrungen.
Also selber machen, selber anfassen, sind das auch die Erfahrungen, die Sie in den Projekten gemacht haben?
Ja, das kann ich bestätigen. Ich habe es vorhin schon kurz gesagt, ich glaube, den Menschen hilft meistens, wenn man es in einen Kontext bringt, was sie selber verstehen, auch in ihrem Alltag. Nicht nur im Arbeitsalltag, sondern auch im Übrigen, außerhalb von der Arbeit, weil dann bekommen sie einen Bezug und können es einordnen und haben dann auch eher Verständnis dafür. Und wenn man nur mit einer Vision daherkommt, ohne noch das zu unterfüttern mit wirklichen Maßnahmen und das dann auch anhand von Zahlen, Daten, Fakten zeigen kann, dann reicht die Glaubwürdigkeit einfach nicht. Oft steht die Frage, damit aber was springt denn für mich raus? Das ist natürlich schwierig, dem die zu beantworten, aber wenn man die Situation in der Industrie oder Wirtschaft kennt, dann weiß man, dass wir immer in Konkurrenz stehen mit anderen Ländern global. Und das bedeutet, wenn ich einen Standortvorteil erarbeiten kann, und sei es durch Nachhaltigkeit und Ressourceneffizienz, dann sollte ich das aufgreifen, weil ich dann den Mitarbeitern auch klar machen kann, wir können länger existieren, wenn wir hier an diesem Thema arbeiten und eben nicht nur schauen, dass wir möglichst billig und schnell produzieren.
Mhm. Vielen Dank. Sehr gerne.
Es ist natürlich eventuell auch noch eine Generation bzw. ein komfortabel und Bildungslücke, die jetzt aktuell noch existiert. Also wenn ich jetzt irgendwo, ohne jetzt jemandem zu nahe treten zu wollen, oberhalb der 60 bin, auf die Rente zuschaue und auf einmal kommt eine andere IT-Spinner nach dem anderen vorbei und will mir irgendeine KI andrehen, das ist dann eventuell halt nicht mehr ganz meine Welt. Also ich war jetzt zum Beispiel vor 2-3 Monaten in der Grundschule in der 3. Klasse und habe da die Grundlagen für KI mal auf ganz geringem Niveau. Also diese Generation wird mit diesem Thema KI natürlich viel souveräner umgehen können, wenn das Bildungsangebot dazu natürlich auch ein bisschen Qualitätsstandard hat. Also glaubt nicht alles, was eine KI von sich gibt. Man sollte immer noch mal lieber per Hand nachprüfen und gucken, was sie macht. Aber auch, dass man KI jetzt nicht als Heilsbringer für alles und jeden versteht, dass man auch ein kritisches Auseinandersetzen mit KI hat, weil ich glaube, es hat sich jetzt niemand von uns damit auseinandergesetzt, was für Kosten, besonders ökologische Kosten eigentlich entstanden sind, diese KIs zu entwickeln, welche ökologischen Kosten sie im Betrieb verursacht. Dieses ganze Gepäck muss man ja erstmal wieder dann in ökologischen Effizienzgewinn wieder gut machen. Das haben wir jetzt alle erstmal schön ignoriert, weil das passt irgendwie gerade nicht so in diese Story rein. Aber damit werden ja dann angenommen ein ausreichendes, vernünftiges Bildungsangebot, neue Generationen auch aufwachsen, sodass sich diese Gap eventuell so ein bisschen dann auch einengen wird.
Mhm. Vielen Dank. Herr Jans.
Sie nehmen mir eine Frage, nehmen Sie mir von der Zunge runter. Ich habe zu allen 3 Projekten noch Detailfragen, fachliche Detailfragen. Das können wir vielleicht gerne nach der Veranstaltung in der Pause machen. Aber eine Frage, die ich an alle 3 Projekte habe, ist, haben Sie denn mal gegenübergestellt den Aufwand, den Sie betreiben, also durch den Einsatz Digitalisierung, KI, die ja auch ressourcen-, energieintensiv ist, durch den Mehraufwand an Technik in den Verfahren, gegenüber den ökologischen Zusatznutzen, die wir haben, und haben Sie da ja quasi eine Ökobilanz gemacht? Das würde mich sehr interessieren.
Sehr schöne Frage. Die geben wir direkt an alle 3 weiter.
Also vielleicht kann ich wieder anfangen. Wir haben das von Anfang an mitgenommen, aber nicht quantifiziert, weil es so schwierig ist zu quantifizieren, vor allem in unserem Bereich. Aber ja klar, wir haben drüber nachgedacht, wir haben viele Diskussionen auch darüber geführt, so was bringt es, was ist dann am Ende wirklich der Impact positiv, aber auch negativ. Aber das zu quantifizieren, das war für uns auch innerhalb dieser 2 Projekte ja noch einen Schritt zu weit. Genau.
Wenn Sie lassen wir mal ich denke, die wissenschaftliche Arbeit, die finanziert wird durch Arbeitsschutz, die glaube ich, muss man ein Stück weit außen vor lassen, weil das ist ja, wo man sagt, das hat Transferpotenzial, das wird veröffentlicht, das bringt dann Folgeprojekte oder Folgeideen in anderen Unternehmen oder Organisationen. Wenn wir jetzt die reine Hardware bei uns sehen und die Installationsleistung, dann kann man sagen, wenn ich das auf diesen Maßstab von 200.000 Kilowattstunden ausdehne, Industriestrompreis kann man mehr oder weniger ermitteln, ja, gibt es auch jedes Mal mit anderen Tarife, dann kommen wir auf weniger als 2 Jahre, wo sich das rentiert. Das heißt, ab Jahr 1,5 ungefähr würde das bei uns in einen positiven Wert reinlaufen. Das ist das, was wir mitgenommen haben, plus noch der Effekt, den kann man schlecht quantifizieren, dass man ein Umdenken bei den Leuten erzeugt. Unsere Idee war auch mit dem Projekt, dafür zu sensibilisieren, den Leuten klarzumachen, dass es doch mal sinnvoll ist, das ein oder andere abzuschalten, wenn du es nicht brauchst. Das können Sie aber schlecht messen, ne? Es sei denn, Sie statten wirklich alles mit dem Sensor aus, aber Sie bewegen schon die Leute zum Umdenken und das führt dann vielleicht auch in anderen Bereichen, anderen Sektoren zu einem gewissen ressourceneffizienten Denken.
Zweigeteilte Antwort. Bei SOREC haben wir es zum Teil nachvollziehen, also was ich jetzt gerade gesagt habe, was ich auch schon eingestanden habe, wir haben jetzt natürlich nicht die gesamten Umweltschweinereien, die das Trainieren und Erstellen der KI generiert hat, mit einbezogen. Wir haben aber natürlich mal Strommessung gemacht, was verbraucht dieser Eddy Current Separator alleine und wie relevant sind die Unterschiede, wenn wir da unsere Technik hinzuschalten. Da das Gerät an sich leider sehr energiehungrig ist, um dort ein sehr, sagen wir mal, starkes Magnetfeld am Laufen zu halten, fallen die eigentlich nur sehr bedingt rein und wir haben auch die KI-Modelle immer quasi so an dem unteren Ende ihrer Leistungsfähigkeit gehalten, sodass sie in der Regel sogar auf einem Raspberry Pi oder was leicht leistungsstärkeren laufen konnten. Wir machen es aber wiederum in einem anderen Themenfeld bei uns in der Forschungsgruppe, wo wir resiliente und nachhaltige Nahrungsmittelversorgung machen und dort eigentlich genau diese Rechnung aufzeigen oder anfangen. Minimaler Ressourcen-Input für maximale Kalorien-Output. Und um das dann quasi halt irgendwie quantifizieren zu können, machen wir dann jetzt genau das einerseits schon in Vorarbeiten, andererseits in Anträgen, die jetzt gerade sind. Weil die Frage treibt mich halt irgendwie auch um.
Wir öffnen gleich die Fragen auch nochmal fürs Publikum, aber zuerst Frau Grunewald.
Ganz kurz da reingrätschen, weil das nämlich tatsächlich ein Thema ist. Da mache ich einmal einen Werbeblock für die nächste Runde. Da drüben gibt es nämlich was zu den Nachhaltigkeitsanalysen. Wir haben tatsächlich begleitend zu den Projekten durch das Öko-Institut Nachhaltigkeitsanalysen durchführen lassen für die Lösung. Die haben so ein Tool entwickelt. Das haben wir jetzt halt noch nicht für alle Projekte anwenden können. Nachher gibt es ein paar Beispiele, wo wir das gemacht haben, aber das Tool steht dann auch zur Verfügung. Das heißt, im Nachgang darf man das dann gerne auch nochmal seine Projektdaten durchjagen und dann gucken, das ist eine vereinfachte Ökobilanzierung, aber da ist genau der Ansatz. Ne? Was ist der Zusatzaufwand durch die KI, durch diese digitale Lösung, verglichen mit dem, was an Einsparungen dann aber durch die verstärkte Genauigkeit, durch Energieeinsparungen dann durch diese ganzen Vorteile tatsächlich rauskommt am Ende als Netto-Nachhaltigkeitsgewinn und häufig ja dann schon auch mit Kosteneinsparungen verbunden.
Vielen Dank, sehr, sehr hilfreiche Ergänzung. Frau Grunewald.
Ja, im Prinzip eine offene Frage, die ich dazu vielleicht noch ergänzen möchte, ist, durch Kimber und Sorek wird ja auch die Qualität der Recyclingbaustoffe, des wiedergewonnenen Materials ja verbessert. Und wie bewertet man eine verbesserte Qualität mit Nachhaltigkeitsaspekten? Also das ist ja auch eine Frage, die man sich stellen muss. Wenn eine bessere Anwendung möglich ist oder andere Materialien eingespart werden können, weil die Qualität besser ist, muss man das ja auch in der Nachhaltigkeitsbetrachtung mitdenken. Aber da kenne ich leider die Antwort nicht. In dem Themenbereich kenne ich mich nicht so gut aus.
Gibt es darauf Reaktionen? Ja, sehr gerne.
Also ich kann es jetzt natürlich nur für unser Projekt beispielhaft machen, wie es entweder von den Industriepartnern vorher gehandhabt wurde oder wie wir es uns jetzt schön gerechnet haben. Wenn es jetzt eine, sagen wir mal, Sorten- oder Qualitätsreinheit von, sagen wir, 90% geben musste und bisher hat der Eddy Current Separator das im Normalstand 60% gemacht, dann hat man dasselbe Material, was jetzt zu 60% sortiert ist, einfach nochmal reingeworfen und nochmal reingeworfen, bis man die gewünschten 90% hatte. Das wäre natürlich irgendwie ein Ansatz, dass man sagt, okay, was war der Aufwand vorher und was ist der Aufwand jetzt? Oder aber, dass man es vergleicht mit dem Aufwand, was müsste ich machen, um jetzt mit anderen Recycling-Methoden dasselbe Ergebnis zu erreichen, oder aber was würde es mich kosten, Virgin Materials zu besorgen, also neue Rohstoffe, was leider in der Regel aktuell immer noch günstiger ist, aber da wir auf einem endlichen Planeten leben mit endlichen Ressourcen, wird sich das Thema irgendwann halt auch nochmal in den Schwanz beißen. Also das wäre jetzt so, wie wir quasi die Szenarien angefangen haben, um zu sagen, okay, die sind jetzt besser oder schlechter als der vorherige Zustand.
Also ich kann noch ganz kurz ergänzen, bei uns ist es eigentlich auch vor allem Zukunft denken, weil also es geht auch um Gebäude, die in 10 Jahren, 15 Jahren gebaut werden. Und genau auch im Kimber-Projekt geht es auch um diese Rohstoffgewinn, also wie viel Primärrohstoffen werden ersetzt und was ist dann dieser Impact davon, das ist sehr schwierig abzuschätzen, aber die Potenziale, die sind auf jeden Fall da.
Vielen lieben Dank. Ich würde an der Stelle einmal die Runde öffnen für Fragen aus dem Publikum. Gibt es Fragen? Ja, hier ganz vorne, das Mikro kommt. Dauert eine Sekunde, aber das ist okay.
Danke. Ich wollte noch mal fragen, ob schon mal in Erwägung gezogen wurde, gerade auch beim Kimber-Projekt und beim Sorek-Projekt, diese technologischen Grundlagen, die da gelegt wurden, direkt auf andere Industrien zu übertragen, zum Beispiel indem man die Erfassung der Partikelgrößen direkt nutzt also in anderen Industrien, wo genau diese entsprechenden Informationen auch benutzt werden.
Also haben wir natürlich noch nicht gemacht, aber an sich ist es natürlich möglich. Dann muss man halt die KI-Modelle trainieren oder mit Transfer Learning weiterentwickeln sozusagen und auch an die Anwendungen oder Normen oder Wünsche in diese anderen Bereiche anpassen. Aber genau das ist auch der Punkt Generalisierbarkeit. Also einmal innerhalb diese Bauschutaufbereitungsbereich, aber auch außerhalb. Aber an sich, diese Funktion, das ist natürlich übertragbar. Genau.
Also bei uns ging es ja jetzt nicht so primär um die Partikelgröße. Die Partikelgröße war ja eher am Anfang so ein Aufhänger, dass es menschlich irgendwie so ein bisschen schwierig wird. Einige Sachen sind natürlich übertragbar, also sind zum Beispiel bei allen Dingen, die über Conveyor Belts, über solche Förderbänder rübergingen, alle Förderbänder mögen es nicht, wenn scharfe, spitze Sachen da drauf sind, oder alle Förderbänder mögen es nicht, links und rechts zu wackeln, weil die halt einfach temperaturmäßig sich ausdehnen oder zusammenziehen oder halt einfach irgendwann ein bisschen lose werden nach einer bestimmten Anzahl an Betriebsstunden. Das ist natürlich direkt übertragbar, dass ich dort einfach eine Kamera drauf mache, die sagt, guck nach Hitzeentwicklung, guck nach scharfen Dingen, guck nach, ob das Wand so hin und her wobbelt. Und da wir die Maschine bei uns am Recycling-Institut von unserer Universität stehen hatten, die natürlich noch eine ganze Menge andere Projekte in dieser Richtung haben und auch viel versierter sind als wir, gab es da halt auch schon Nachfolgeanwendungen von dem Thema. Also die haben quasi sich dann unsere KI-Modelle geschnappt und sind damit weitergelaufen.
Vielen Dank für die Frage, vielen Dank für die Antworten. Wir haben eine weitere Frage aus dem Publikum. Stehen Sie gerne auf.
Ja, vielen Dank für die Vorträge. Ich finde das Thema sehr, sehr spannend und es wurde immer von KI geredet. Heißt, irgendwelchen trainierten Systemen, die in der Lage sind, gerade zum Beispiel mit den Kameras, das Sortieren etc. vorzunehmen. Und da würde mich mal interessieren, worauf das Ganze basiert. Ob das eigene Entwicklungen sind, Open-Source-Möglichkeiten, APIs, KPIs, je nachdem, womit da gearbeitet wird, gerade auch zum Thema ressourcenschonende KIs.
Das geht an die Projekte, denke ich, genau.
Genau, also wir haben tatsächlich eine Kombination von eigen entwickelte Modelle. Also das war diese zweite Teil, diese Particle Size Prediction Modul. Das war komplett eigene Arbeit. Das haben wir auch, also wir haben dort auch darauf fokussiert, das so leicht wie möglich zu machen. Also ich kann das auf meinen eigene Rechner laufen lassen und dann funktioniert das auch im Millisekunde-Bereich. Und diese Segmentierungsmodul, da da schon ganz viel Arbeit im KI-Bereich passierte, haben wir hier das SEM-Modell adaptiert. Also da auch keine Neutrainierung angewendet, was schon mal viel Energie gespart hat. Und das war dann Open Source basiert.
Ja, bei uns, also beziehungsweise nicht, also ähnlich, ja, aber wir haben uns im Grunde quasi nur auf vortrainierte Modelle verlassen, weil ich komme aus der anwendungsorientierten Forschung. Ich löse existierende Probleme, indem wir mit dem Hammer der Digitalisierung versuchen draufzuhauen und gucken, was runterfällt. Das heißt, wir sind jetzt auch nicht die Experten dafür, die jetzt neue KI-Ansätze von Scratch irgendwie entwickeln. Also wir haben zum Beispiel sehr viel basierend auf existierenden YOLO-Modellen gemacht, so Objekterkennung oder Bounding-Boxes zu übersetzen oder Segmentierung, und haben die dann quasi ein bisschen nachtrainiert oder angepasst mit unseren Testdatensätzen. Aber jetzt komplett von vorne entwickeln machen wir eigentlich sehr, sehr selten, um den Trainingsaufwand gering zu halten, aber auch natürlich der Zeitaufwand ist ein erhebliches Etwas und dass man auch deutlich weniger Datenmengen braucht. Und gerade würde ich sagen, sogar bei allen 3 Anwendungsbereichen ist ja, wenn man 2 Jahre nur hat, einen riesigen Datensatz aufzunehmen, der auch jetzt nicht zu homogen ist, aber auch nicht zu heterogen. Da beißt einen ja nachher noch ganz viel anderes irgendwo mal von links und rechts, sodass man damit den vortrainierten, also man muss das Rad nicht neu erfinden, meistens ganz gut irgendwie zu vernünftigen Ergebnissen kommt, zumindest so aus der bisherigen Erfahrung.
Ich würde sagen, eine letzte Frage haben wir noch. Sehr gerne einmal aufstehen.
Wir haben ja die ganze Zeit von KI geredet. Ich würde fragen, haben Sie sich schon mal so Sorgen gemacht um Cyberattacker? Also wie offen sind solche Systeme gegen Cyberattacks?
Wir haben jetzt keine KI-Modelle eingesetzt. Wir haben auf eine bestehende Infrastruktur aufgebaut, die sowieso im Firmenkontext vorhanden war. Und da mussten wir feststellen, dass in der Produktionsumgebung Forschungsprojekte zu implementieren, das ist nicht ganz einfach. Sie haben am Anfang eine tolle Idee, wollen das schnell umsetzen, greifen auf vorhandene Bausteine, Systeme, Bibliotheken zurück, wollen mal ein Docker-Mensch installieren und dann kommt die IT um die Ecke und sagt, nee, das geht so nicht. Das ist halt ein bisschen schade, da muss vielleicht auch der eine oder andere Industriepartner noch ein bisschen umdenken, aber so ist halt die Realität. Ja, also
das heißt, das Thema Cyberattacke war bei uns da doch schon mal ein bisschen außen vor. Die Firma hat generell mit solchen Problemen zu kämpfen, deswegen sind da auch die Maßnahmen, die implementiert sind, sehr strikt und sehr hoch und man muss dann sich immer um gekapselte Lösungen erstmal bemühen, die so funktionieren und dann möglichst auf das aufbauen, was schon State of the Art ist, also was man sowieso schon in anderen Applikationen im Firmenumfeld anwendet und dann möglichst seine Lösung daraufhin adaptieren, dass sie dann immer noch läuft, aber mit den und den Restriktionen.
Ja, also einen kleinen Teil oder eine kleine Motivation für Cyberattacken, die es ja häufig bei solchen Industrieprojekten gibt, haben wir schon dadurch so ein bisschen umgangen, dass wir einfach alles Open Source gestellt haben. Das heißt, es interessiert jetzt nicht mehr jemanden wirklich, die KI-Modelle oder die geheimen Daten oder irgendwas zu klauen. Den Aspekt der Operational Security, dass man jetzt nicht in das Projekt reinkommt und von außen dann das Band schneller laufen lässt oder falsche Sensordaten rein füttert, die dann das Band schneller laufen lassen oder ähnliches. Das war jetzt nicht Teil des Forschungsprojekts. Also ich komme eigentlich aus dem IT-Security- und Privacy-Bereich vor 7, 8, 9 Jahren. Hätte da definitiv auch meinen Spaß dran, aber war jetzt einfach in dem Projektbereich oder dem Projektthema gerade nicht der Fokus.
Vielen lieben Dank. Ich würde noch mal einen Schritt zurückgehen. Wir haben vorhin ja schon über Ökobilanzen geredet. Danke, Frau Ziemann, nochmal. Das ist ja auch, wenn wir uns das vielleicht wünschen würden, nicht die einzige Bilanz, die dafür entscheidend ist, dass solche Lösungen auch wirklich angewendet, übertragen in anderen Unternehmen genutzt werden. Das andere ist die ökonomische Bilanz. Herr Bichelmeier, ich würde einmal mit Ihnen anfangen. Wenn Sie auf die hier vorgestellten Lösungen blicken, woran entscheidet sich, ob ein Unternehmen diese Lösung übernehmen kann? Ab wann lohnt sich der Einsatz?
Also ich würde vorwegsetzen, erstmal die hohe Relevanz dieser Lösung. Ich werde nachher kurz nach 1 unseren GreenTech-Atlas vorstellen, eine Studie, die sich die ökonomische Bedeutung von verschiedenen grünen Geschäftsmodellen angeguckt hat. Und dort gucken wir uns unter anderem auch den Leitmarkt Circular Economy an oder Kreislaufwirtschaft, aber eben auch die Energieeffizienz. Und beides sind sehr wichtige Leitmärkte. Circular Economy ist sehr groß. Energieeffizienz ist etwas kleiner, wächst aber sehr dynamisch. Also da sind große Potenziale, auch in Zukunft noch mehr Wertschöpfung auszulösen. Was mir mit so einer ökonomischen Brille immer wieder begegnet als Herausforderung für solche Projekte, ist, dass wir schon seit einiger Zeit jetzt in Deutschland eine Investitionszurückhaltung haben. Also selbst dann, wenn Technologien einen eindeutigen ökonomischen Mehrwert liefern könnten, einen eindeutigen ökologischen Mehrwert liefern könnten, kommen sie trotzdem nicht immer zum Einsatz. Und auch wenn sie sich innerhalb von 2 Jahren amortisieren können. Wir haben in Deutschland zum Beispiel seit 2022 einen rückläufigen Trend bei den privaten Anlageinvestitionen. Das alles spielt da rein und ich glaube, um das zu überwinden, ist es ganz wichtig, stabile Rahmenbedingungen zu haben und eine klare Zukunftserwartung in Richtung Klimaneutralität und Kreislaufwirtschaft oder einer zirkulären Wirtschaft zu entwickeln. Und wenn es diese Zukunftserwartung gibt, dann glaube ich, dass die Nachfrage für diese Produkte sehr, sehr groß, für diese Services und Produkte sehr, sehr groß sein wird. Und wir große ökonomische Potenziale erschließen können und letzter Punkt, damit auch international erschließen können. Ich werde das nachher im Vortrag auch nochmal unterstreichen. GreenTech ist eine ganz wichtige Exportbranche und wenn wir es schaffen, diese Lösungen technologisch zu entwickeln, marktreif zu entwickeln, dann schaffen wir es vielleicht auch, sie in die Welt zu exportieren und damit Exportmärkte der Zukunft zu gestalten.
Vielen lieben Dank. Sie merken, ich versuche so ein bisschen alle Dimensionen der Übertragbarkeit hier in der Diskussion den Platz zu geben. Wir haben über technische Übertragbarkeit geredet, wir haben über den Faktor Mensch geredet, wir haben jetzt über wirtschaftliche Übertragbarkeit geredet. Was noch fehlt, sind die richtigen Regulierungen, die richtigen Rahmenbedingungen. Herr Jans, wenn Sie, oder anders gefragt, welcher politische oder regulative Hebel sind aus Ihrer Sicht besonders wirksam, um digitale Lösungen, wie wir sie hier gehört haben, in die Breite zu bringen?
Das ist vor dem Hintergrund der augenblicklichen Debatte um Bürokratieabbau, was auch immer man genau darunter verstehen möchte. Da gibt es ja verschiedene Auffassungen, ist das eine sehr schwierige Frage. Ich würde es mal beispielhaft angehen. Wir entwickeln zurzeit den digitalen Produktpass. Wir entwickeln die Datengrundlage, die Datenspeicher des digitalen Produktpasses, die dieses Instrument sehr effizient machen können. Und wenn wir es schaffen, die Rahmenbedingungen zur Erfassung, zur Integration der notwendigen Daten, also im Rahmen des Produktpasses für die Produzenten, beispielsweise für notwendige Produktinformationen, für die Recycler, was ist drin? Einerseits für die Konsumentinnen und Konsumenten, was sind an Schadstoffen in meinen Produkten drin, wie ist die Recyclingfähigkeit? Wenn wir diese Integration gut schaffen und gut verfügbar machen, und dafür bedarf es die Rechtsetzung im Bereich der Ökodesign-Verordnung, dann ist das ganz gewiss ein guter Weg.
Vielen lieben Dank. Ich glaube, das hat es tatsächlich sehr, sehr plastisch gemacht. Damit kämen wir dem einen Schritt weiter. Wir sind schon fast am Ende angekommen. Ich würde noch gerne eine kleine Abschlussrunde machen, bei denen ich jeden von Ihnen noch einmal zu Wort kommen lasse. Und ich möchte mit Ihnen anfangen, mit den Projektleitenden. Wir wollen ein bisschen in die Zukunft gucken. Und ich bitte Sie um eine Prognose, Herr Gleich, Herr Leiding, Frau Liewe. Ich weiß, immer schwierig, aber wenn Sie 5 Jahre in die Zukunft gucken, wo steht Ihre Lösung? Wie breit ist sie in der Anwendung?
Ich klaue mir jetzt einfach mal ganz dreist das Mikrofon, weil Prognosevisionen sind so das, wo ich eigentlich immer am meisten Spaß dran habe, aber vielleicht noch quasi ganz kurz andockend an das Thema vorher.
Sehr gerne.
Also ich glaube, jetzt nicht einfach nur darauf verlassen, dass die Technologien das irgendwie schon bringen wird und die Technologie muss es ökonomisch machen, das ist, glaube ich, eine Illusion, der man sich nicht hingeben sollte. Weil der Knackpunkt ist ja, die Welt zu zerstören, ist bedeutend gewinnbringender, als es nicht zu machen. Solange es gewinnbringender bleibt, kann ich so viel Technologie drauf werfen, wie ich will. Ich werde damit trotzdem nicht unter die Forbes 100 kommen. Dort sind nur Menschen drunter, die professionell und hauptberuflich die Welt zerstören. Und das wird uns Technologie nicht lösen. Also gleichzeitig technologisch Fortschritte machen, aber auch dafür sorgen, dass es teurer wird, die Umwelt zu zerstören, ist, glaube ich, so einer der Knackpunkte. Wo steht Sorek in 5 Jahren? Ich hoffe, in jedem Every Current Separator auf dieser Welt. Nein, Spaß beiseite. Also dadurch, dass natürlich elektronische Müll einfach immer mehr und mehr wird es davon hoffentlich natürlich auch mehr Maschinen geben und auch das Bedürfnis oder die Nachfrage danach vermutlich aussteigen. Ich persönlich bin jetzt nicht so sehr der Recycling-Ingenieur, dass ich sagen kann, wo diese Geräte nachher ihre technische Grenze erreichen. Also geht 1 Millimeter noch vernünftig und wie sieht es bei einem halben Millimeter oder 0,1 Millimeter und Co. aus, weil je mehr Rohstoffe verschiedenster Art und Weise in sehr, sehr kleinen Gramm- oder Mikrogrammzahlen ich da rein tue, desto mehr gerät dieser Ansatz natürlich irgendwo an seine Grenzen, sodass einfach das gesteigerte Volumen hoffentlich und vermutlich zu mehr Nutzung führen wird, aber ich glaube jetzt auch trotzdem natürlich alternative und ergänzende, komplementäre Techniken gebraucht werden, um in der speziellen Sparte jetzt weiterzukommen.
Vielen Dank, genau. Wir gehen die Runde einmal weiter.
Ich würde mir wünschen, wenn wir in 5 Jahren so weit wären, dass jeder Mitarbeiter, wenn er nach Feierabend nach Hause geht, sagt, ich habe heute ein Stück weit die Welt verbessert, weil ich es geschafft habe, bei meiner Linie Energie zu sparen, Ressourcen zu sparen, Wasser, Elektroenergie, was auch immer, Komponenten, Ressourcen. Das wäre, glaube ich, das wäre toll, wenn man das in 5 Jahren erreicht, dass da ein Umdenken stattfindet.
Vielen Dank, da sind wir uns, glaube ich, alle einig.
Sehe ich genauso. Also ich glaube, da schon recht viel Interesse bei den Unternehmen, die wir alle gesprochen haben, an diese Technologie ist, glaube ich, dass es in 5 Jahren schon einigermaßen eingesetzt wird, aber wie viel das tatsächlich sein wird, liegt, glaube ich, auch genau an die Regulatorien und das Vertrauen. Aber da stehe ich eigentlich sehr positiv drin.
Herr Bichelmeier, Herr Jans, Frau Grunewald, für Sie mache ich es noch einen Ticken schwieriger. Wenn Sie 10 Jahre in die Zukunft schauen, wie steht es um die Ressourceneffizienz in der Kreislaufwirtschaft in Klammern dank der Digitalisierung? Herr Bichelmeier.
Ich glaube, meine Antwort bleibt die gleiche, 5 oder 10 Jahre. Meine Hoffnung und optimistische Erwartung ist, dass wir konsequent in innovative Technologien investieren, die uns am Ende diese Vorteile bringen, ökonomisch und ökologisch. Und darauf hoffe ich.
Vielen Dank. Herr Jans.
Wir werden Digitalisierung, KI hoffentlich als ein sehr nützliches Instrument haben, um Kreisläufe zu schließen, Kreisläufe reinzuhalten. Es wird aber in 10 Jahren genauso wie heute erforderlich sein, dass wir auch dass wir unseren eigenen Konsum überdenken müssen, um insgesamt zu einer Umweltentlastung durch eine Fortentwicklung der linearen zirkulären Wirtschaft zu kommen.
Vielen Dank, Herr Jans. Frau Grunewald, in 10 Jahren, wie sieht es aus?
Also ich bin da auch positiv gestimmt, dass die Technologie und auch künstliche Intelligenz da einen riesen Fortschritt machen werden und auch eingesetzt werden, einfach auch, weil wir müssen, also und auch demografischer Wandel da ist. Und ich glaube aber, es wird noch nicht flächendeckend sein. Also ich bin schon optimistisch, aber ich glaube, Dinge brauchen Zeit und 10 Jahre ist eigentlich leider sehr schnell vorbei. Und aber ich denke schon, dass es klappen wird. Damals hat auch keiner geglaubt, dass das Internet sich durchsetzen wird und heute benutzen wir es fast in jeder Minute.
Ja. Vielen Dank, Frau Grunewald. Vielen Dank Ihnen allen für dieses spannende Gespräch, für diese tollen Projekte. Ich glaube, Sie haben sich nochmal einen Applaus verdient. Genau, und dann spätestens in 5 Jahren sehen wir uns hier bestimmt wieder. Dann gucken wir mal, wie weit wir gekommen sind. Wurde ja auch alles aufgezeichnet, was Sie gerade gesagt haben. Daher schauen wir dann mal. Es gibt jetzt, wenn ich richtig informiert bin, 30 Minuten Kaffeepause. Wir können vielleicht auch mal eine Folie weitergehen. Und nach der Pause gibt es dann den Vortrag zu How do you measure Sustainability Analysis Tool for Self-Evaluation of Sustainability Aspects in Practice. Genau. Ich schätze, wieder drüben. Bis dahin, Sie stehen sicherlich in der Kaffeepause für weitere Nachfragen zur Verfügung. Das heißt, nutzen Sie die 6 und ich wünsche Ihnen bis dahin noch einen schönen restlichen Tag. Vielen Dank.
Und jetzt grätsch ich noch einmal dazwischen. Ich möchte mich nämlich ganz herzlich bei unserer Expertin und unseren beiden Experten bedanken, dass die sich heute die Zeit genommen haben und einen Blick auf die Projekte und deren Perspektiven geworfen haben und ihre Perspektive eingebracht haben. Vielen Dank. Es gibt eine kleine Vorfreude auf Weihnachten. Bitte schön. Und ich möchte mich auch bei meinen Projekten bedanken. Die durfte alle 3 ich betreuen als Projektträger und ich muss gestehen, ich bin echt stolz, was bei euch rausgekommen ist. Vielen Dank.
Vielen Dank.
Hope everyone's now hydrated, caffeinated. The air smells like mandarins now, so that's a nice Christmas feeling for us in the room now. So, all right, welcome back. I hope the other session was as exciting as ours was. I would now like to talk about the Öko-Institut for a moment. Within the Digital GreenTech project, they have developed a tool to measure the sustainability gains within the projects. So today I am welcoming Martin Müller, a senior researcher for the Öko-Institut, up here today to present the tool and, more importantly, the results. So let's welcome Martin Müller to the stage.
So thank you so much for the kind introduction and a warm welcome also from my side to everybody here in the room, as well as watching online. Well, in the previous discussion, we have heard that sustainability is somehow a delicate issue because we often have a lack of, well, concrete and quantifiable information, and because of that, sustainability is not so tangible. Well, in this session, my 4 co-speakers and I would like to show you how we can create such concrete and tangible information via self-evaluation. Why self-evaluation? Well, in the first funding phase of Digital GreenTech, we could see that when the assessment is performed by the researchers who actually carry out the R&D work, we have the best approach to create reliable information at a very early stage. So this is the basic principle, but of course in order to get mainstreamed, such a self-evaluation has to have low threshold and easy to use tools. And this is why we have developed such a tool at Öko-Institut, which we would like now to present you in concept, but also in its practical application. And against this background, we will just start with some key principles of this self-evaluation. Then my colleague Jens Gröger will take over and present to you the tool in its concept. After that, we will learn how the tool has been applied in practice. So we will listen to Jonas Hunziker from DigiWave, Professor Andrea Cominola from Iole, you already heard him this morning, and finally Sebastian Pütz from Lalveco. After that, we will hopefully have a lively discussion, especially on how to promote sustainability when it comes to the transfer, when it comes to the marketization of the new developments. And finally, I will wrap up and transfer the results. So let me start with the key principles, actually, when it comes to self-evaluation of sustainability aspects, as we designed it for Network Digital GreenTech, which is the accompanying research project for DGT. Well, first and foremost, we want to create quantitative information, both on the efforts, but also potential benefits that can be created via Digital GreenTech throughout the entire life cycle of the new developments. In order to track both the efforts and the benefits as early as possible, we integrated that actually in the ongoing R&D work. And the best way to do so, as I already mentioned at the beginning, is to enable and support the researchers who carry out the work in conducting sustainability assessments of their own developments. And when doing so when allocating the sustainability assessment to the researchers, it's the best way also to strengthen their methodological expertise in sustainability, which is definitely helpful for further marketization, but also in any other context. And what is also an important part of this self-evaluation process, that we have created a lot of exchange fora in order to have this exchange of experience, knowledge transfer, but also potential synergies that can be created when exchanging about sustainability. So content-wise, the self-evaluation centers around three major questions or issues. First of all, of course, we want to track how those innovations at the interface between digitization and environmental technology can really promote sustainability, especially in terms of a lower carbon footprint or better and improved resource efficiency, but also in terms of cost savings. So also taking into account the economic implications of the new development. However, of course, we have to be aware that there are not only those benefits. We have to take into account that the production of the equipment which is needed for the project, of course, consumes a lot of resources, partially also critical metals, for example. We have carbon footprint also when looking at the manufacturing, and also toxicological hazards. I will get into detail on that issue in another input tomorrow morning. So it is really crucial also to track those efforts of the digital infrastructure. And once we have looked at both sides of the coin, of course, we are eager to know which is the overall result when looking at those two aspects. So is there any net sustainability gain which can be achieved? Or if it's difficult yet to quantify the potential benefits, we at least want to know, is there some, as we call it, sustainability break-even point? So where the benefits outweigh the efforts that we have to invest in order to use the digital infrastructure. So in order to create robust assessments in that respect, we applied interdisciplinary methodological toolbox, which started with a screening exercise that we called ex-ante analysis, where we actually attributed the different aspects of the projects to the Sustainable Development Goals and its 169 sub-targets in order to map the relevance of the different aspects, the different parts of the development. That forms the basis for everything else. So based on that scoping, the carbon footprint has been assessed. If relevant, also the use of substances of very high concern according to REACH, with a tool we call REACH Radar. And finally, the assessment was supplemented with cost analysis that also covered the whole life cycle. In order to mainstream especially the carbon footprinting as well as the life cycle costing, we created the tool that I mentioned at the beginning in order to support the self-evaluation. First and foremost, the tool aims to quantify the efforts of the hardware which is being used, but also the achievable benefits, for example, the reduced use of raw materials and consumables in the intended target application. And it provides a screening assessment of the carbon footprint. So in detail, we integrated freely available life cycle assessment databases, which are indispensable for creating quantifiable information. In particular, we used EDEMAT, a database that provides several thousand entries for different materials and also emissions, for example. But we also used inventories from projects at Öko-Institut, which we compiled in a digital carbon footprint calculator. So this is an important part, but even more important, in order to really help the self-evaluation, we created a user-friendly interface with a search function and easy selection of suitable data sets, that it is really possible also to model complex products and components that you might have in your bill of materials, for example, a drone or a robot. Once you know the materials that are being used, you can transfer this information into the carbon footprint in just a couple of clicks in this tool. And finally, also as part of the assessment is a screening of the life cycle costs, which both considers investment and operating costs. So with that, actually, I'd like to hand over to my colleague Jens. Jens, please come to the stage. Having a background in energy and process engineering, Jens has been working at the Öko-Institut since 2009, and as scientific coordinator for sustainable for sustainable for sustainable infrastructure. No, so for
sustainable digital
infrastructure. His research is focused on sustainable ICT equipment. So, for example, Jens develops approaches how to assess the energy efficiency of data centers, for example, but also has carried out a sustainability assessment for a wide range of ICT products.
Yeah.
So with that, Jens, the floor is yours.
Thank you, Martin. I guess we have only a short time frame to present all this. So thank you for your introduction, but you stole actually my minutes. I just want to show you the tool. As Martin already said, it's to calculate the carbon footprint and to calculate the costs. And the benefits on the other side. And to present this tool, I mean, it's only Excel tool. You can visit it in the break afterwards. We show it on the screen there, and you can play around with it. I just invented one GreenTech project just for this purpose. This is a train running on a rail line. Everything is fine, but sometimes it happens that trees break down, so the train doesn't run anymore, and instead of all these cars are running. So this is now my GreenTech idea coming up, that we could plant into the trees all these smartphones and solar chargers, and as soon as a tree gets a angle of inclination which is concerning, then the lumberjack can come and cut down this tree before it actually falls on the train line. Great idea. We save a lot of car travelings like this, but after all, we need quite a lot of electronics for it. And what I would suggest is that all this digital green tech is only justified if there is actually a benefit for it. And to do this, it's necessary to compare the associated efforts with the benefit. And also the costs might be quite interesting to look at. This is the example that does not really exist. That's no funded project, actually. It just, I just invented it the day before yesterday. We have this self-evaluation tool, and we can very easily type in there the efforts we have. We have 1,000 mobile phones, 1,000 solar chargers. We have mobile data transfer. We have a central monitoring server that processes all this data, which has to be produced, but which also uses energy while processing all this data. And we have additional train kilometers because the train line isn't blocked. And we have more persons required for this digital green tech inspection, someone who has to check if all these chargers are working and so on. But we also have benefits. We have actually prevented 6 hours of rail closures per month. So every month a tree falls down. And we have fewer cars traveling during that train cancellations. 6 hours per month. It's altogether 60,000 kilometers per month saved. And we have less personnel. Before, there was one person visiting that forest every day. Right now, we don't have this person anymore. Just the lumberjack that cuts down the tree, but actually we have another person necessary for all this electronics in the tree. Okay, this is one part of the tool. This is a database. Martin already said it's got more than 1,000 parameters in there, and a search function where you really can choose what do you need for it. If you have a robotic arm, you can maybe choose the metal and the plastic and the motors and everything from this database. For our example, I've picked these 1,000 smartphones, the PV cells for the solar charger, and then what's happening during the operation, the transfer data in the internet, the server in the data center, and the additional kilometers the train will run, and on the lower side you see what is being saved. Actually, it's been saved the person that does the tree inspection usually, and the kilometers by car. So what are the results? The results are shown here. The green one is the saved carbon emissions, and the red one the additional carbon emissions. So actually, we have saved something. We had an effort of 32 tons of carbon emissions. So all these smartphones and so on led to 32 tons of carbon emissions, and we actually had a benefit. We even have a net benefit, meaning if we make this 118 minus 32, we get up to 86 tons of carbon emissions. So let's look additionally to the costs. We had an effort of 109,000 euros per year and a benefit of 40,000 euros per year. So actually that was not an actual win. And if we look a little bit closer at the euros we've spent to save 1 ton of carbon emissions, we end up at 802 euros per ton, which we have spent to save these carbon emissions. And I guess there are other measures which where I get for 802 euros much more carbon reductions than this one. But I mean, this was a very quick calculation. Maybe just in the very early stage, I could start to optimize that system. Maybe I don't really need 1,000 different smartphones. Maybe already this angle inclination sensor together with a microprocessor and a Wi-Fi network might be sufficient, which might be much cheaper and has a much lower carbon impact. And so I can start to improve that system to get to this point that it overall gets useful. And this one actually didn't seem to be so useful. But luckily, we see these projects that have been funded and not just an idea of mine, and they will show how they use that tool and how useful their project ended up. Thank you.
Thank you so much, Jens, especially for keeping the time despite of the stolen minute at the beginning, and that I do not steal any further minutes. I just briefly introduce the next speaker, who is Jonas Hunziker from the DigiWave project. He has a background in environmental engineering and has been the person being responsible for the self-evaluation at the DigiWave project. Please, we're looking forward to it.
Thanks for the introduction, Martin. Today I show a certain aspect of the DigiWave project because we had several tools that we developed, but we just look at the real-time prediction model for microbial water quality for a UV plant. And to tell you, so normal UV plant is operated that it has to reduce microbial inflow, which is set, and a dose is applied. Our model predicts the microbial inflow, and therefore the dose can be varied according to the microbial inflow. And to develop such a model, you have additional expenses, you have laboratory measurements at certain points, you have to develop the model, you have to adjust the model, you have to run a PC, you have to do maintenance, and we also had at-line E. coli measurement device, an Aqua Bio, which you have to buy and run and maintain, and you also have personnel. For the operation, there you have the savings, but also additional expenses. So again, the PC personnel maintenance is still there, but in our project we found out that for 25% of the operation time of the UV plant, we can reduce the UV dose, which is required to achieve the microbial quality, by 30%. We can reduce it, and which results in a 50% less power consumption of that plant, while still ensuring the microbial safety. And our plant was 1.2 kilowatt, which is is a very small plant. Okay, so I put everything into the tool. The personal computer, the Aquabio, there we took data which we had from other projects, and then we had the invest costs and the operation costs for additional, and then the savings were basically just we saved energy. But for this small plant, our finding was that also for GHG emissions, and for costs, there's no net relief for this small plant. But for a slightly smaller plant, a slightly bigger plant, we have the break-even point for GHG emissions, and for an even bigger plant, which is not an astronomically high, has an astronomically high power consumption, and plants with such a power demand exist, we have even a break-even point for costs, saying if you always buy a new Aquabio, this online E. coli measurement device. Yeah. So yeah. For our pilot plants, it's not net relief, but if you apply it for other plants, and our assumption is that basically the model development and the running of the model has the same effort, then you get the net relief for our tool. And lessons learned. So I'm not an experienced life cycle assessment performer. We have a department in our company which does this, but I did it as a environmental engineer, which is more focused on the water treatment. It was easy to use, and it's very basic lesson. Intuition versus assessment. Assessment wins, and the scale at which you apply the Digital GreenTech, the tool, is very important. And for the tool, so my feedback is I really find it easy to use, and it was really good for first evaluation, and to have a small complaint, not a big complaint. The database could be a bit bigger with this tool. But yeah, to get a first impression, a rough evaluation, it's very nice. Thank you.
Thank you very much, Jonas, for sharing your insights. We're going to move over to the next speaker, who is Andrea Comenola. You have heard him this morning, so I also will have only a very brief introduction. Andrea has an interdisciplinary background covering information technology and also environmental engineering, and with this background he was the ideal person also to perform the self-evaluation of sustainability aspects in the EOLI project. Yeah, really looking forward to the input.
Yeah. Thanks for the kind introduction. Yes, about the evaluation of the EOLI project. Just a quick wrap-up of what we do in the project for those of you that were in the other room in the first slot. Here we basically develop software for leakage detection in water distribution systems. We have developed this, which is basically now only shown as an interface that water distribution network operators, so meaning water utilities, can use, and it integrates two different algorithms for leakage detection. You see them on the bottom. Both of them need some data. One also needs some more computations than the other. There's a bit of trade-offs. And behind the interface, actually, there's a full stack development that we're finalizing right now, which really goes from the data to the analysis to the final evaluation. So basically, we have a software development that's the subject of our environmental evaluation here. In general, that means also this is somehow not something that is yet in place in water utilities, so it's a prototype that now we're testing in a controlled environment. That also means that the results can be very much utility specific, because depending on what the wishes of a utility are in terms of integration of the software in their system rather than running it on a server or something else, then this can create some uncertainties. Therefore, we basically define two scenarios to set the basis for analysis. The first one is an ex-ante scenario in which there's no solution from our project implemented in the water utility system, so they rely on whatever is their actual solution for water utility for leakage detection at the moment. And we are relying on numbers that indicate a baseline leakage detection rate that they have now. We've been quite conservative in this case, so we consider a pretty low leakage rate for a water utility that's actually around about 3%, which is quite below average, considering that the reference is normally, at least in Germany, the reference group is 7.7. Then we have a digitalization scenario in which we assume that our product is implemented in the utility system, so the solution is there, and we can calculate the break-even point. That means how many leakages should the water utility reduce in such a way that the benefits and the costs are balancing out, basically. As I said, conservative calculation. Also in this case, we overestimated a bit the amount of data, the amount of hardware that we need. But it's important to clarify we evaluate the software here. So we don't require in this evaluation any new sensor. We assume the sensors are there, which is actually what we are assuming in the whole project, basically. What are the causes of our environmental impact? On the product development, of course, we have hardware. We need computers, we need monitors, we need data transfer, and we need, of course, the whole implementation of the software. Power consumption, of course, and as I said, data transmission, so internet traffic and storage. On the operational phase, we assume that the water utility will have a dedicated and high-performance computing workstation at their premises. So we assume in this case that they will add a new hardware component. Then, of course, power, data transmission, and internet traffic. We also overestimate that a little bit. And then there's a financial cost for using our software. We estimate it now into 2,000 per year. That's under discussion, depending on the future of these of our products. But these are basically the assumptions. So let's look into the calculations, as also Jonas showed for the DigiWave. I'm showing here the calculations. In our case, you see the list is a little shorter. So the calculation also, after putting quite some effort into understanding where the boundary conditions of our systems are, was pretty straightforward. And in our case, you see you basically have costs, because here we're not providing already direct benefits. Benefits are projected, and the break-even points is calculating. So let's just take a look into then the final outcomes here. Break-even point for CO2 emissions. So if we consider the development and operational phase, we have around about 5,000 kilograms of CO2 emission equivalent per year, which only, of course, reduces if we restrict to the operational phase, right-hand side of this. And if we translate this into amount of water that we need to save in order to balance this out, considering the cost that the utility has into producing, delivering water, and the loss that it has by not selling this water, basically we find that with a few, let's say 20,000, 21,000 cubic meters per year, or only 12,000 for the operational phase, we can compensate for these costs. Which for a big utility, like the example that we're considering, of course, we have also a consultation with our partner Gelsenwasser in this case, 0.24% of the current losses, so a reduction of 0.24% of the current losses can be enough to balance this out. As I said, this is somehow a very small number. At the same time, we are somehow adopting this conservative approach. So we assume that even, let's say, for utilities where maybe the amount of water that's produced is less and more costly, even if you put like an increasing cost that moves this one order of magnitude higher, then it's 2.4%. So still quite in the low range, let's say, especially if they have big leakages. Similar findings, of course, if we look at the economical aspects. So just to go quickly, actually, the economic aspect is balanced out with an even smaller amount of leakages that is reduced. Of course, here I have to put a disclaimer. As I said, here we're calculating only these numbers based on software. So if new sensors are needed, then this will be an additional cost. if on top of the solutions that we have at the moment, there's some, let's say, AI algorithm that needs to be trained in a specialized server, so additional costs will come. Actually, the highest costs, if you look at the financial costs and also environmental costs, are already the data transmission and storage. So if you use data-intensive algorithms, still this will be worse. Quick wrap up on this. I think basically it was really a cool experience actually to use this. I actually during my master, more or less 14 years ago, I attended a class on life cycle assessments, and finally I could use some of the knowledge I got there for something useful, so that was really nice. And in general, I think the added value of this, besides the final numbers, is really that it forces you to define the system boundaries. What do you account for, what do you don't account for? And then developing scenarios. Of course, as I said, if we change the boundaries conditions, the numbers will change, but at least by defining the scenario and the elements we consider, there can be a very transparent and quantifiable process. Similarly to what was said in the previous presentation, I think the overall experience was positive, and I would add that from the quick analysis, one can of course also move to a more sophisticated calculation. So I think that was also the case for us. First we got an impression of whether the break-even point was reachable easily or not, and then we went down into more detailed calculations. On the possible improvements, I think what we would wish, so that's really more a wish list, not really a criticism, it's that it would be nice to be able to really easily, let's say, understand how the numbers change under different parameters as input. So to run some sensitivity, for instance, if we add some new elements, how many sensors do you need to actually make these calculations way worse? So having some nice sliders or things like that help also from the UI. But in our case, the data set was in fact very much complete. And yeah, that's it. Thanks.
Thank you, Andrea, for also sharing those deliberations, especially in terms of methodology. Very much appreciated. With that, we come to our last speaker, who is Sebastian Pütz. Sebastian has a background in computer science and AI, but you also might know him as the creator of a robot called Move-Base Flex, where he got internationally known for, because this robot is now running on more than 300 warehouse robots. We're looking forward to your input on the self-evaluation in the Lalveco project.
Yeah, thank you. Lalveco stands for Long-Term Autonomous Laser Weed Control. So what we do is basically with robots driving autonomously in vegetable production, we shoot at weeds. So we also presented this 2 weeks ago at Agritechnica. So what you think of there is, for example, we can reduce the amount of pesticides and herbicides and also hoeing, for example, so mechanical hoeing, and that, of course, produces a lot of CO2 equivalents. So what we did together was DFKI, the German Research Center for Artificial Intelligence, the LZH, so Laser Center Hanover, and us, Nature Robots. So we built such a robot and integrated a laser weeding tool and did perception on that to identify weeds. I will talk about that more in details with also quite a lot of videos, so you can see how we shoot at weeds in real time tomorrow, but today it's about what we can save with that. And I will start with what we invested, so in terms of our carbon footprint first. So we have roughly 200 kilograms of CO2 equivalents when we just see at the materials. So basically steel, so from what we used in the table is a market mixed Europe, and also of course aluminum, for example. Then what comes on top, of course, we have a lot of electronics. As you think of robots, we have batteries, sensors, and solar modules, and yeah, the cables and so on. So that sums up to roughly 120 kilograms of CO2 equivalents. Furthermore, of course, when we think of the usage of the electricity, we need to take into account how much do we actually need to recharge, or how often do we need to recharge the batteries. So we have 9 kilowatt hours of battery, for example. But now we need to think of how many hectares can we actually work on with this robot. So, and how much energy we are consuming with such a laser. Often people say, hey, lasers are really consuming a lot of power. That's not actually the case. So we have 1 kilowatt by the laser, and then a bit more than 0.1 by the computer. And then when we calculate this about the speed and so on, then we have a runtime of the, or let's say areas which can work on of the whole robot of around 4.4 hectares per day. So which means 24 hours. There needs to be some recharging in between, autonomous recharging, for example. So we have 6.23 hours and so on for just one mission, and then a recharge is needed. At the end, that results in around 800 hectares of driving distance, so what the robot can do in a year, and around 5,000 kilowatt hours what we need from the grid, actually. So then, of course, it highly depends what energy we are using. Also, where if it's produced by offshore wind, for example, or photovoltaic panels, that of course leads to higher reduction of CO2 costs here. So you see these numbers there. So this, of course, leads to the conclusion that we, of course, need you should use like green energy from the grid. So bottom line here is at a nice mix, we can have, for example, around 370 kilograms of CO2 equivalents per year when we have these 800 hectares the robot can do in a year. When we calculate this, or calculate with the medium, let's say CO2 equivalent here of around 1.95 kilograms CO2 per hectare, then we can also go on and calculate about what the robot is actually saving. So what we're saving here is already, when we just talk about the diesel saving effects, so thinking of what diesel actually produces in CO2, we can think of the well-to-tank approach, so and then also use the use of course. Then we have around 3.29 kilograms of CO2 per liter. That sums up at the end that we save 136 kilograms of CO2 per hectare. That's per hectare per year. That at the end sums up already to around roughly 19 tons of CO2 per robot per year. So that's a lot for working on 800 hectares or driving on 800 hectares. And when you think of, we need to drive on the same hectare 6 times because you need to do the weeding not only once in the year, but a couple of times, and you have working on 133 hectares, for example. We already save a lot of CO2 here. On top of that, there is a no-till effect, so not really digging in the soil a lot. And then, of course, we save a lot here, 256 tons per robot per year with the no-till effect. And again, on top of that, there is a saving by less soil compaction because the robot is much more lightweight. So here we save another 317 tons of CO2 equivalents per robot per year. And when we think of how could that scale, that's the last slide, I promise. So when we double, for example, the amount, not double, but triple the amount of robots in the next years, and then in 10 years, we already have more than 52 million tons of what we could save with such a robot. Thank you.
Thank you so much for sharing those impressive figures, but also the approach how they were generated. I think both is important. And with that, I think we should come all together. I'd like to ask all the speakers to come to the podium, because in the first place now we'd like to answer the question you might have. So on the tool itself, but also the results that have been shown. And then we will move over to other important questions. So first of all, is there any question first on the tool and the methodology here in the audience that we need to clarify? Or also from the people watching online, of course. So there is a question.
What's your opinion on the benefit of these results on promoting your solution to any stakeholders?
Yeah, maybe I can take a first shot on this. I guess, so we haven't done yet any wide advertisement of this, but of course, as I said earlier, we have a utility that's an associated partner here, and I discussed some results with them as well. And I believe it's in general nice to see the numbers for them, because I believe, you know, there's this, at least in the case of leakage detection, there's this understanding that, of course, if you consider the elements we have in our solution, some intuitively will have a higher weight than others. So I think qualitatively assumptions can be made. And there's also this idea that up to a certain point, it's not economically beneficial to reduce water losses. I think here we're giving some numerical evidence in that, and I think this has two values. One is that actually one could say, okay, well, that's maybe something that I can afford doing, and on the second hand is actually, besides just the number, just fostering a wider discussion, okay, and breaking some barriers, because maybe some utilities thinking about the small ones or so may say, well, we have already our own leakage detection solutions and we're happy with it. But maybe once you give the numbers of a new solution, then at least the conversation it goes a bit on. That relates also to the question of interest you had in the previous panel.
I can continue. So, like we said before in the panel discussion, it's, I think, difficult to sell the environmental benefits from a, for example, GHG emission perspective. But yeah, we found out that also from the cost perspective, you could say, okay, you have less operating costs and you invest amortizes in a short amount of time, and then if you have a tool that is usable, has a good user experience, and is from a cost perspective, yeah, beneficial, I see no problem, and the decision is should be more or less clear to use it.
So the question was about the stakeholders. I would also add on shareholders here. So we are right now, for example, in an funding round, raising our first seed round here after 3.5 years of bootstrapping, so that we can scale with such a solution in the next years. And there we are looking for Article 9 investors, so which are really have their in their letters that we need to save a lot of CO2. And as we know that agriculture is saving 1/4 to a third, depending on the sources you are looking for, of the global CO2, or could or is emitting actually 1/3, 1/4, 1/3 of the global CO2 emissions is coming from agriculture. So there is a huge benefit, and yeah, there are coming up in more and more agriculture robotic startups using also electrical driven robots, which are more lightweight. And the nice benefits, of course, you can save humans there, but at the end it's very important for us to also measure how much kilometers at the end, for example, what's the weight of the robots, how do they treat the soil, for example, and then by that derive the amount of CO2 equivalents we can save with these. And of course that can be accounted with some methods like carbon farming, where we think of what the farmer could, coming to the stakeholders, could let's say, earn in terms of money additionally on top of, hey, the robot is saving human workforce, or actually enabling to stay as a farm because he's not finding or she's not finding any additional people for the farm. By the way, you can also save a bit more of money or earn a bit of money by carbon farming.
Got a follow-up question on that important issue. When looking at the transfer of the results and the marketing, which existing frameworks or initiatives could support you in that respect, or which you would like to see that do not exist so far? So you mentioned SFDR, Article 9 investment. Is this an important way to go to with reliable information? Or which other frameworks or initiatives would you like to see?
I mean, let's say the phase where sustainable technology in the last 3 years was very on the peak, was in the last 3 years, I would say, and it's quite hard these days also for the funds, for the VCs, to close their second fund, for example, or the next fund to raise money. It's harder these days. So what we think, what we need for the longer term, or for the next valley of death, which is coming for a lot of startups and also nice ideas, which are great and could save a lot of CO2 and presenting a valid business case. So we need, of course, public funding for that R&D projects, and where they think of what is actually just looking at the numbers, just looking at the facts, is on two sides, on the business side, but also on the CO2 side, could work together. And not like running after trends too much. Right now we see a huge AI bubble which could explode in the next months and years. But let's also see what is happening with solid, like hardware, software business cases in the next years. And for that we need more R&D on that, and especially for startups. Yeah.
Thank you. Further thoughts in that respect by you, Andrea and Jonas?
I mean, I would not be able to name a framework in this case, but more like a purpose. I think it would be nice to value the good outcomes of this experience, which are, in particular, we have a very well-established methodology. Life cycle analysis was not invented for the purpose of this project, but is well understood, I would say. We have a tool which I think our experiences demonstrate is quite usable and useful. And we have a set of different projects that, with a consistent framework, produced some relevant insights about their sustainability. So I think this can be used as a blueprint. I'm thinking more to connect to a higher level, thinking about the water sector, for instance. In 2 weeks, there's the first Water Resilience Forum in Brussels, and there's a lot of a hype in circularity in the water sector. So I think also connecting these experience and practice with higher level Europe-wide initiatives and policies may be very useful. I'm thinking of, for instance, integrating these also into Horizon projects and European level projects, so that this aspect of impacts, direct or indirect, is not just always set as, well, we should also calculate that, right? But that's in fact part of the project by design.
Yeah, so with our tool, I'd say the whole aspect of having a kind of sandbox, or like where you can test the tool in real-time situations and make it more robust, because it's the water sector. And this is also not a framework, but yeah, to have funding for operators that say, okay, we looking into the topic of water reuse, and we have the capacities to support, for example, us in our research, and then we can just increase the robustness of the tool and have more data, which is which is lacking for
to make the tool more usable in the practice yeah.
So much. So we are just entering the stage of wrapping up this session. I like to announce that anybody who is interested in the tool in detail has the possibility to look inside. So we will have outside a stand where we can just look into the file and do some quick modeling of questions you might have. So this will be provided at the second half of the lunch break. So 1:45 we will be there and then answer your questions. Again in the coffee break in the afternoon. And concerning the tool, I'd like to come back to also the transfer, because we do not want to keep this tool only here in Digital GreenTech, but also provided for other similar programs, also the following or just started robotic call. And in this respect, I'd like to ask you, because you are experienced now with the process and you saw where we also supported you, where do you think would you need most support if you start from scratch? Imagine another project group likes to do the self-evaluation. Where is the most need for support? Is it rather the scoping at the beginning? Is it the filling of data gaps? Or is it the final assessment at the end? So maybe a short, quick round at the end where you need support when doing such a self-evaluation with the tool.
So first of all, I think that the tool was really great. It's easy to handle, and without such a tool, I think the modeling of your problem, and then of course it's a lot of research in terms of paper reading and bringing these together, so that can take days and weeks, and having of course the time to doing so, or having some student workers, but also experienced organizations, so that's always like having a plan, let's say a plan how to do this, maybe with some examples. That would be great for other startups, other projects. And time, always it's about time.
Nice. I see also quite some useful aspects in the scoping. Because particularly, I think, going back to our experience, we started with some hypotheses. Okay, this is what we need to account for. This is what we can also live out. And then we added or modified things step by step. So I think having maybe some joint workshop or so where those that actually know the tool pretty well. So you and not just maybe a good set of diverse partners from the project. We can say, oh, but look, when we implement the solution, this aspect may also be important. And then maybe according to somebody else, there's a different scenario or so. So this scenario building, I think, can be maybe made a little bit more efficient if it's guided instead of being just more spontaneous, let's say, from those that produce the solution. Because sometimes also we're somehow in our box of the solution. We may need some external input in that sense. So.
Yeah, I want to pick up what Andrea said. So we had the exchange, which was really good with other projects. So if you have new projects that you accompany, I think if there are several parallel running projects, or even to have the experience of older projects and an exchange, is really nice, because for people who don't have a lot of experience with LCAs, to know what kind of scenarios to look at, and how to maybe change the scope to have interesting findings. It's not super intuitive, I'd say, but with an exchange and you with your own ideas and exchange with other people with ideas, it's a nice approach, and you can learn a lot even if you're not very much into the topic of life cycle assessment.
Thank you so much for your feedback. Next to me sits the creator of the tool, and very much appreciate, I think, that feedback. But I would also ask you, Jens, what do you see as key in order to get the tool mainstreamed as much as possible? What should be the next steps from your perspective?
Yeah, actually, that tool is just a tool, and I think we've been talking far too much about this tool, because what I think is that every funded project should report about its benefit. I mean, it's not just spending money for some environmental project, but it's also reporting how much has been saved by this project. And so we actually need tools, and this is quite a simple tool. Maybe we need more intuitive or more experienced tools. But I even think that every digital service should report about its environmental impact. So every ChatGPT request or Google request should directly report about this. And if we once had this, then we probably would have a competition about the most environmental friendly services or ideas around here. And so we actually need these kind of tools. Yeah.
I think this really deserves the applause and should be the final conclusion of that session. We are happy to further discuss any open questions that are still existing now in the lunch break, or especially, as I mentioned, at the point where you can meet the tool. Thank you so much for your attention, and I just give back to moderation.
Yeah, sure. Thanks. Right, basically everything's been said. We'll break now for lunch for 1 hour. So I welcome you all to go back into the foyer. There's food waiting for you there. And for our friends online, I wish you also a pleasant break. We'll be back at 1:15. And yes, please check out the tool. So see you again soon. So I think most of us are back now. So to everyone here with us in Berlin, welcome back from lunch. I hope everyone's well fed and also has coffee to recover a little bit from the nice food provided for us. And also to everyone online, welcome back. I hope you also had a nice break. So we're going to move on with our next segment for today now, and are turning to the question that's central to Germany's future competitiveness: how digital tools can strengthen the green transformation here at home and help shape sustainable innovation made in Germany. So to talk us through what this means in practice, please welcome Tim Bichelmeier from Prognos AG. He is an expert on climate policy and the green and circular economy.
Thank you for the kind introduction. And I'm going to talk now about the study me and my colleagues conducted this year for the last 1.5 years, the GreenTech Atlas 2025. And maybe if you can show my slides, it's not there yet. Oh, I need to push a button. Okay. Yes, so I will talk about the GreenTech Atlas 2025, a study that focuses on the economic impact, the economic footprint of green business models, from products to services, from well-established services and products, like, for example, public transport, all the way to new and very innovative products in the market. We have conducted a very detailed quantitative analysis of different economic metrics based on official statistics. And for those of you interested in the methodology, there is a methodological note on the website of the German Environmental Agency, for whom we conducted this study. So please go there. But for my presentation, I would like to focus on some key results of our analysis. And the first message, and for this message, we looked at, for example, employment data, or on gross value added data. What we find is that green tech is a key industry and an anchor of stabilization for the German economy. To give you just a few numbers, the German green tech sector represents 3.4 million persons employed in 2023. That is 7.5% of all employment in the German economy, so very significant. If you put that into perspective, a well-known German industry, the German car manufacturing industry, represents around about 1.1 million persons employed. But the green tech sector is not only very large, it is also growing significantly. growth value added increased in the period of 2010 to 2023 by 4.7% per year. If you look at the last years, from 2018 to 2023, this trend even more accelerated, and you see even more dynamic growth rates. Okay, this is including an animation. No, that was not the plan. The third number you should see here is the number of 130 billion euros of products being exported. A number growing at 6% per year, representing about 10% of total German economy, of the total German exports. Also a very significant number. To look a bit closer into what does the green tech sector consists of, we define it across 7 lead markets, the largest being the circular economy, followed by sustainable mobility, growing at 7.2% per year, the renewable energy market, growing at 8.3% per year. We look at energy efficiency, growing significantly, water management, sustainable forestry and agriculture, and mitigation and protection technologies. In sum, 314 billion euros in growth value added in 2023. A few focus points with regards to digitalization. On the left side, for the past, between 2010 and 2023, we have seen a few markets, services, products that have doubled in their gross value added. For example, software development to develop further industrial processes, digital network technologies, Industry 4.0, smart factory, the smart meter market or smart grids, all of these markets doubled within the period we observed. And there are many other markets to look at, sensor networks, AI's ecosystem monitoring, digital twins, digital product passports, digital platforms. You can list many, many examples of products where we can anticipate relevant growth within the next years. And we can anticipate a trend that gives even more dynamic to the German green tech sector. But already today, the green tech sector has grown significantly, as I said. You can see here the trend of persons employed in the German green tech sector, the red line, and you can see that it has grown consistently over time, surpassing other key industries in the German economy. If you look at car manufacturing, if you look at metals being produced, if you look at chemicals, all of these key sectors have gone through a fundamental crisis in the last years, and they stagnate more or less around the level of 2017, while throughout the crises we have seen Corona crisis, the energy crisis after the attack of Russia on the Ukraine, the green tech sector has continued to grow. The second message I want to deliver looks at global markets. We have conducted a detailed analysis of the German exports as well as global imports. And what we find is that German companies have in the past and hopefully will in the future benefit from a global demand for green tech. You can see here again the second lead markets and differentiate the 2 years, 2010, 2022, and the sum of global imports. And across all lead markets, you can see that at least the markets have doubled. Some show even more dynamic. For example, the market of energy efficiency on the right side, we can see a threefold increase. On the very right, sustainable mobility, even more dynamic than energy efficiency. Here again, you have a trend graph. You see the upper trend, which is the sum of global imports. And below, you can see the trend of German green tech sector's exports. And what we can see quickly is, so far, German green tech sector has managed to keep pace with the global trend, benefit from global increasing demand. A trend that is not the same, true the same way if you look at total import markets and total non-green tech German exports, where you see a split. While global imports have increased massively, German non-green tech exports fall behind, and they, at least in the last period, in the last year observed, have not managed to keep pace. A few aspects to highlight. Of course, if you talk about global trade, one cannot ignore what is happening right now, the trends and shifts we see in the world. With regards to green tech, the US is a key market. They have imported 154 billion euros of products of green tech. In light of the new Trump administration with regards to trade barriers, but also with regards to their massive pushback on climate ambition and the support for green technologies, we cannot expect this market to grow in a similar way. We might even need to anticipate a decline. Similarly, on the other side, if you look at China, China in the past years has massively increased its capacities of production. Today, in many markets, has a very dominant market position. Take solar PV, take the battery production, where Chinese production is ahead. And if you look at German exports to China in the last period, in the last year observed, 2022 to 2023, we see a decline. So China is becoming less important for German green tech exporters. But the good news is there are many other opportunities in the world. First of all, if we look at the EU market, half of all green tech exports go to other EU countries. Some of them growing very significantly. For example, I highlighted here Poland, growing at 8% per year. Other countries show similar increases. But even beyond the EU market, you see other countries, India that has grown by 11%, Cambodia has grown by 20%, Vietnam has grown by 15% in their imports per year. Throughout the interviews we conducted for this study, we had several experts pointing to other export opportunities in South America, in African countries, where the demand for green technologies is growing rapidly, and therefore the opportunities for German exporters are also growing fast. The third message I have from our study, we have conducted a detailed analysis of patents. And what we find is that Germany is one of the leaders in global innovation race. For half of all green tech patents in the world come from 3 countries, the US, Japan, and Germany. Germany alone representing 16.5% of all green tech patents. So we are in a very strong position in the global innovation competition. In this graph, you can see additionally a segmentation in the 4 lead markets. What we find is that 3 lead markets are of particular importance, which is the renewable energy system market, the energy efficiency market, and the sustainable mobility market. What you can also see is China with 6.6%, relatively small share compared to the top 3. But China is catching up fast. In the last years, we see an exponential increase in the patent fillings of China. So it is only a question of time until China is going to surpass Germany or at least equal with German patent activities. A few more highlights from this analysis of patent activities distributed or differentiated here for 4 lead markets. If you look at the circular economy, 18% of global patents come from Germany. In particular markets or particular products, even higher shares can be observed. For example, there's a topic, the utilization of waste materials in the cement production. German companies hold 23%. Another example is the lead market of energy efficiency. We see 14% of global patents coming from Germany, and we can see strong growth. 10% per year the patents have increased in the period observed. Third example, the renewable energy systems market. Germany is still holding a strong position in this market. If you look, for example, at the wind energy market, 23% of the patents come from Germany, making it the second just behind Denmark, and for example, having double the amount of patents compared to the US. And the fourth example, the sustainable mobility. As I pointed out before, car manufacturing is a key market of German industry, and it holds its strong position. Although there's strong international competition, Germany is second ranked with 21% of the patents, just behind Japan. So to conclude my presentation, I would like to put emphasis on 3 strategic areas I think are important to unlock the described potential of the green tech sector in the future. First, from my point of view, advancing the transformation towards climate neutrality and a circular economy is key to put stable surroundings, stable condition for the green tech sector to develop and make use of its full potential. Second, seizing opportunities in emerging markets in the global trade. Particular companies can redirect their focus. As I pointed out, there are many countries that increasingly demand green products. These bring great opportunities for German export markets of the future. And last but not least, strengthening innovation to ensure long-term competitiveness. As I pointed out, Germany is in a strong position, at least with regards to patents, what we show here. But we want to keep pace with the international competition. So we need effective research funding. We need optimal condition to bring innovation into markets. And we need a good and well-functioning public-private collaboration. So now you have the chance to look at the QR code and find our study. There's the full report in German. There's a shorter version of the report in English. Again, as I said before, there's on the website of the Environmental Agency, there's also a methodological note with all details on the products and services covered under the umbrella of GreenTech, as well as the data sources, the methodology, everything one might want to know. And last but not least, feel free to contact me directly now after my presentation, later when we have a coffee. Send me an email, contact me. I'm happy to learn from your experiences, from your perspective. Yes, thank you. And then I would like to ask if there are any questions.
Yes, do we have any questions for Mr. Bichermeier? I actually have a question. I was thinking, so your presentation presented a quite positive, I think for my opinion, surprisingly positive view of Germany in this technical area. And I would say, as someone coming from a media perspective, a lot of what we spend our time putting out to the public is a lot of negative stories about Germany falling behind on tech, Germany falling behind on AI, Germany not having access to the rare earths that it needs to fulfill a lot of these tech obligations. Could you comment on maybe where the discrepancy is between your presentation and what is maybe part of the public perception?
Yes, I agree with the description. When it comes to public discussion, we often focus, maybe it's a German thing, we focus on difficulties and things that are not working. And you are right that the report, of course, depicts a positive message. We start the report with a description of some changing trends in the world. We look at the US, we look at China, we look at regulatory conditions we see in the EU and in Germany to highlight two trends. We see the dynamic, the increasing demand, but also increasing competition, increasing difficulties to supply products and services to this changing condition. So this is not to be a study telling all of us that it's going to be fine and all problems are solved. We have the technologies, we have companies ready to provide these services and products, but we need to think about conditions that make use of these opportunities, I would say.
Yeah, I mean, a follow-up question I have as well, or comment maybe, is like the patents data is really interesting because this is something that, like, Germany has been a leader in patents filed for some time, but there is also a bit of, I guess, I know discussion, again, from the media point of view, why this failure somehow, or perceived failure to turn the patents into market leadership in some areas. But what I'm seeing in your presentation is there is, in fact, some leadership in some areas. But do we have a comment or follow-up question here?
Yes.
Let's get the microphone. Yeah, that's fine.
I didn't want to interrupt you.
That's fine. No, carry on.
Would you agree with the opinion that maybe one point why this digital or this green tech importance of the green tech sector in Germany is not well known in the public is that it's not like one sort of branch like the automotive industry?
Yeah.
And what could we do about that?
Yeah, that for sure is a difficulty. If you take it from the perspective of data and classification, a green tech sector doesn't exist. It is always part of different sectors of the car manufacturing, of machinery being produced, and so on. Statistically, we estimate for each of these sectors how much is related to green products and services. So in a way, it is a statistical construct to show its absolute importance and the trends in the past years. But it is difficult because no company out there identifies as part of the green tech sector, even products or services where it would be rather expectable in renewable energies, for example, they will always say they are part of the energy sector. So yes, it is a difficulty.
More questions? Yes. I'll bring the microphone in a second.
Regarding the numbers you showed, it was from 2023 to 2022, right? And especially the decrease in green tech came, I guess, in the last 3 years. So what is your perspective on that when we look at startup funding, for example, funds? So Invest dropped like after 2022 massively. So I would ask for what's the perspective on the last 3 years?
That's a good question. It's a bit, to be honest, it's a bit of a blind spot for me. I look at the data we have, the official data that is out there, and then we have the time lag until 2023. So when we update this study in 2 years, then we will have the data available to assess the trends now or in the past 2 years. Of course, I have a perspective and an opinion on current trends, but yeah, I like to stick to the data I have.
Fair enough. Do we have any more questions? Okay, then another round of applause for Tim Bichelmeier. Thank you very much. So, I would like to do a special shout out again to our friends online, because we're moving into a segment that's all about them now. We'll be awarding prizes for the Digital Green Talents of 2025. So we have everyone with us online now who will be receiving the award. The Digital Green Talents Award ceremony honors every year 20 young scientists from around the world who are developing innovative ideas in the fields of sustainability and digitalization. To promote this international exchange and research in Germany, the Federal Ministry of Research, Technology and Space is funding these talents to come and conduct their research in Germany for 3 months. And the prize includes their stay at the summer school to be held in Germany near Frankfurt in June of next year, as well as participation in a mentoring program. So a bit about how we're going to organize this. For the award ceremony, we want to introduce our talents and highlight the different perspectives that their research backgrounds are bringing to the table. And we have them here up on the screen. So maybe let's give them an applause just to start right now. So, hello, good to see you all. And we're going to be getting to know each one of them a little bit closer here in a minute. So we've organized everyone's into 5 different thematic categories. These categories are water, waste and plastics, agriculture and transport, energy, and climate change and others. So we've clumped a few things together, but bear with us. And this year, as part of their application, the talents have each sent us a video where they introduce themselves and their research. So we'll be watching those in a minute, but first I'm going to welcome Dr. Müstner back onto stage, and he would like to share a few words with our talents and with our audience.
Good afternoon, everybody. Here in the room again. You know me by now, I assume, since this morning. But a very warm welcome to our nominees for the Digital GreenTech Talent Award 2025. And it would be nice if I could see the faces of all the colleagues on the screen. Yeah, hello everybody joining us virtually. My name is Rainer Müsner. I'm working in the division for circular economy, resources and geoscience in the so-called BMFTR, German Federal Ministry for Research, Technology and Space. According to the program, you probably expected my Deputy Director, Mr. Rudolph, but unfortunately he couldn't make it. But be sure your award will be signed by him when you get it handed personally when you're in Frankfurt or coming to Germany. Anyhow, it's my great pleasure to conduct with you together this award ceremony, and I'd like to say a few words, not many, just a few, about why we are doing this talent award. Mrs. Platzen already mentioned, we do it for quite a long time. Since 15 years, we nominate international digital green talents because we are very much convinced that projects won't change the world. The only ones that can change the world are people. Bright minds like you are, and intelligence and bright people are spread over the world, all over the world. And ambitious people like you who want to go a step further, to improve things in sustainability and to use the tools of the 21st century to make the world better, to make it a better place to live in, to make better neighborhoods and to create more sustainable livelihoods. This is a very ambitious target and we appreciate this very much. Already this morning, I don't know if you could follow the discussions and presentations this morning, we had somebody on the panel saying, we need more exchange. And with exchange, it didn't meant data for AI models. He spoke about human intelligence. We need more exchange on human intelligence, and that's why, complementary to our funding of projects and research infrastructures in Germany, we have funding schemes to attract international talent to Germany and to build networks. While some of the international green talents stayed in Germany, worked for companies, got maybe a professorship in a research institution, others went back home, but made friends in Germany or had professional links, let's say, to alumni or other people here in Germany, and most of them appreciated it very much. On the other hand, we as a ministry appreciate your input, your willingness to come to Germany and to exchange your ideas with fellows in research organizations in Germany or even companies in Germany that have a research department that are working the same themes like you are working. Ms. Platzen already mentioned, actually, it's 4 elements of the Digital Green Talent ceremony. 5, she said 5, so she will add what I said. The 5th comes from the moderator today. The one is your research stay. Sorry, I thought you meant the research stay of up to 3 months. The summer school near Frankfurt, and I'm looking very much forward to this summer school because there I will meet all of you in person, hopefully, in Frankfurt. The weather will be much nicer in May than it is now today. And in summer, I hope you have an excellent stay in a research organization where you would like to work together with researchers from Germany and abroad, because nowadays roughly 1/3 of our researchers in research organizations coming from outside Germany already. Every third scientist in Germany has a background from a different country. So what makes working and living very multicultural. But coming back to the main point, to pave really the way forward for sustainability needs people. People on the ground, people that like to change the way business is done, maybe in the coming years, and people that are willing to test and to improve the situation of the environment in their countries. That's why I feel very honored to have you as a guest in Germany in next summer. The award ceremony in the next minutes, Ms. Platzen mentioned already the procedure. In any case, I like to say, be ambitious, make the best out of your time in Germany. From next year on, you will be one of the members of a very large community of alumni of Digital Green Talents, and that's one of the biggest benefits we have here in this program, that you can be part of a larger group. And with these words, I'd like to hand over to our moderator and to proceed with the ceremony.
So thank you, Dr. Müssner. So we will be co-presenting our talents in just a minute, but just a couple follow-up questions I wanted to pose to you, just based on the words you shared with us, because you mentioned people a few times there, and this is something we also spoke about in our discussion this morning about in German, Faktormensch, the human factor. Could you talk to me a bit more about why this specific aspect is so important to you? Because I have the sense that when you bring it up so much that it maybe you felt that it's missing from, because we're here to talk about digital tech, but now we're talking about the human factor. So could you tell me if you felt that's been missing or why it's so important?
I guess that's a discussion we haven't had this morning too often, but I thought about it when I was listening to my previous presenter, Mr. Bichelmeier. We talked about the economic opportunities that lies in digital green tech or environmental technologies. But if you don't have the right workforce, skilled workforce in this sector, then all these options are diminished. That's crystal clear. And to have a specialized workforce is essential for a country like Germany, but most likely as well for the countries where our digital green talents come from. So with respect to this, what we call in Germany Facharbeiter, or the other term Facharbeitermangel, is a central question for all the industries in Germany, maybe big companies like Bayer, Siemens, Mercedes, you name it, or if it will be Schmidt & Sohn, our traditional small and medium-sized enterprises in Germany. Of course, they're looking for AI and ways to improve their business. But even more important, they're looking for employees they can hire to have a solid background in their business case, but as well bring new ideas and trigger innovation inside the company. Because quite often when you talk about innovation, the companies say, yeah, everybody's speaking about innovation. I have to do my business here, and I have to find people that know what I'm talking about here. So talent, to really have a skilled workforce that is talented, that brings in new ideas, is essential for a country like Germany, not to fall back in the race that was described very profoundly by Mr. Bichelmeier.
Yeah. Another thought that came to me listening and thinking about, we're here in Germany and largely, present company excluded, a German crowd here, but also with our friends from abroad. And historically, we all know that I'd say especially in the 20th century, Germany and Europe and also the United States has had a role of going outward and trying to maybe educate these other countries and somehow, bring our knowledge to them. And thankfully, this narrative is changing that this is some sort of Western export good that we have, and that this, of course, goes in other directions. How do you feel about this idea of an exchange, like auf Augenhöhe at eye level?
I'm very grateful that you mentioned it, because it's easy to get this impression we are soaking up talent from around the world to Germany because we want to have the brightest minds here in Germany. Mm-hmm. This is true, but the focus should be on exchange. I sincerely hope that the research staff, the nominees in Germany and the network will be informative and inspiring for their personal career. Most of them will go on with their personal career in their home country, in third countries, in excellent companies in Australia, wherever, Malaysia, you name it. And what I like to have is that they have new ideas from Germany to their career, to their work life, and to bring their ideas to Germany, to the people that stay here. So I used this term, I guess it was yesterday on an event on robotics. For me, it's an issue of cross-fertilization. It's a little bit complicated, sophisticated thing, but we can learn from each other and we can benefit from each other. Simply, Germany is a very small spot on the global landscape. We think we are economically strong, but the statistics shows us different. So it's essential for our countries, like for most countries around the world, that we have strong links and interaction with people around the world, because we will not win against climate change, or we will not increase the use of renewable energies in Germany alone. Mm-hmm. It's a global endeavor to make a change.
Yeah, wonderful. And that's a perfect transition to our next phase here, where we'd like to give a bit of the stage to our talents to talk about themselves. So as I mentioned before, we're going to be presenting the talents in 5 different categories. And to begin each category, we'll have a short introductory video from an expert opening the category, and then we will see short presentations from each talent presenting their work. So our first category to start off will be the category of water, and we have a video introduction from Alexander Bonda, the Secretary General of the Deutsche Bundesstiftung Umwelt, the German Federal Environmental Foundation. This is the largest environmental foundation in Europe, which focuses on innovative projects aimed at protecting the environment. So let's roll the video.
I'm here from Brazil. I'm here with the German delegation at the World Climate Conference, the COP30. The world is meeting here to tackle the big problem of climate change. We need solutions, we need political commitment, but what we also need are young talents, young scientists, young entrepreneurs, young professionals who are helping us to solve the big problems that we have on our way to a sustainable future. Questions like circular economy, like using digitization to solve ecological problems, questions of emissions, and a lot of other things needs you. So thank you very much for participating. Congratulations that you are the chosen digital green talents for this year. I hope you find some ways in your areas of expertise. I hope that you are participating in the big fight against climate change. And I hope that you are part of the international cooperation, of the friendship between Germany and your countries. So have a good time in Germany. I hope when you're meeting the World Climate Conference will have some good results. And I'm counting on you to help us fight climate change, solve ecological problems. In the next few years, we need you.
All right. Yeah, I forgot to mention that he was at COP, but I guess that was obvious. So it's a nice message from someone fighting down on the ground to our talents and to everyone here in the room. So now to present our talents in the category water, we're about to hear from 4 talents: Adoke Areshola from Nigeria, Elprida Agustina from Indonesia, Supreja Kohli from India, and Abhinesh Ganapati from India. We'll have short messages from them.
I'm Abhinesh Ganapati, a PhD student at the Indian Institute of Technology, Roorkee. I develop climate informed models to estimate flood risk under changing climate conditions. 2 things that deeply motivate me in this research. First, I come from a region in India that faces flood every alternative years. Second thing is, I'm very much interested to work with data and statistics. This research blends both of my interests in a meaningful way. Now I'd like to extend my model to manage water scarcity as well. In Germany, there are many researchers who work in hydrological extremes. Now, with the Digital Green Talent program, I look forward to collaborate with them, use local data set, and access to high-performance computing. Thank you very much.
Hello, I am Adoke Areshola Habib, a PhD candidate and a graduate research associate at the Center for Biomediated Bio-Inspired Geotechnics at Arizona State University, United States. I am a recipient of multiple prestigious awards, including the Trent Howe Dams and William W. Moore Fellowship by the American Society of Civil Engineers. My research aims to develop biomaterials through fungal mycelium, which is the root of a mushroom, that could be used in place of conventional synthetic materials for different geotechnical engineering applications. My vision is to scale these bio-integrated solutions globally, particularly in developing regions where sustainable, cost-effective materials are critically needed. Through Digital Green Talent, I aim to collaborate with global innovators and researchers to accelerate this transition towards biomaterials infrastructure systems. I am committed to translating breakthrough into real-world applications. Thank you.
Hi, I'm Elprida Agustina. I'm a PhD candidate in Environmental Engineering Study Program at Institut Teknologi Bandung, Indonesia. My research is about modeling the flow of plastic waste from land to the sea through rivers, with integration of primary sampling using machine learning and remote sensing product data to address gaps in global plastic waste modeling. My work focuses to reduce uncertainty caused by differences in the spatial and temporal resolution. I integrate environmental engineering, particularly in waste management, with spatial analysis and machine learning approaches to develop promising decision-making tools. I strongly believe in the saying, you cannot manage what you cannot measure. My ultimate goal is to develop valid, reliable, and globally applicable data as a foundation for formulating strategies and policies that contribute to achieving Sustainable Development Goals number 11, 12, 14, and 15. Thank you.
Hi, I'm Supreja Kohli, a PhD student from the Department of Biochemical Engineering and Biotechnology of IIT Delhi in India. I'm currently working on recovering phosphate from municipal wastewater with the help of tiny green organisms called microalgae, and I have identified some proteins responsible for this process. This sustainable approach not only treats wastewater but also supports a waste-to-resource model where the produced microalgae can be used as a slow-release phosphate fertilizer. In the future, I plan to pursue my postdoctoral research on automated wastewater treatment by investigating protein-phosphate interactions on selected microalgal proteins using molecular dynamics and machine learning models. As a stepping stone towards this path, the Digital Green Talents program provides me with a wonderful opportunity for mentorship and long-term collaboration with Germany's scientific community, while also exposing me towards the country's rich cultural heritage.
A round of applause for our talents from water. Okay. All right, now moving on to our next segment, Waste and Plastics. We'll hear a message from Anja Eimer, the head of Global Water Business at Siemens AG. Let her roll. We're missing some audio. Do we have a lip reader in the audience? Okay, maybe we seem to have a technical difficulty with the video, unfortunately. So we're going to move on now to presenting the works of our talents in this category. So we'll be hearing from our winners in the Waste and Segments category. We have Shaula Adelusi from Nigeria, Nilesh Kumar from India, Kaylee Shaw from Canada, and Haley Smith also from Canada.
Hi, I'm Haley Smith, a fourth-year PhD student at the University of Victoria, working on sustainable bioplastics from kelp, specifically developing greener extraction methods. Before starting my PhD, I worked in the petroleum and petrochemical industry. Seeing the health risks and environmental impacts of chemical exposure and pollution firsthand really motivated me to go back to grad school and focus on developing safer and more environmentally friendly solutions. As a green chemical engineer, I like to consider the whole life cycle of a material, from sourcing and solvent use to how it breaks down in the end of its life. I look at where the biomass comes from, what solvents are used. It's all about ensuring materials can be reused and have minimal impact on the environment. My research uses computational modeling and predictive toxicology to support designing greener alginate extraction processes. Learning from experts in Germany will help me translate research into real-world applications, as well as find new opportunities to implement green chemistry practices that curb pollution.
Hi, my name is Kelsey Shaw. My pronouns are she, her, and I'm a PhD candidate in civil engineering at the University of Victoria here in British Columbia, Canada, as well as the Swiss Research Institute EAVOG in Zurich. My research focuses on tackling one of the biggest sustainability challenges, how to safely manage human waste in places without sewer systems. I study how microbes degrade waste and produce methane, and how we can turn that data into something usable. This research resonates deeply with me. I grew up using a septic tank. These systems are common in Canada, especially northern and Indigenous communities. I've observed here and during my fieldwork in Uganda how resource constraints and rapid urbanization make sanitation a public health and environmental issue and disproportionately affect marginalized communities. That's why I'm passionate about using digital tools to generate actionable insights that support safer, more equitable sanitation systems for all.
Namaste. I'm Nilesh Kumar, a PhD scholar in biological engineering at IIT Madras. I'm particularly passionate about solving global environmental challenges, specifically in the area of plastics. As we all know, every minute 1 million of plastic bottles is accumulating in our environment. So my research tackles this by transforming waste PET into various biochemicals using chemomicrobial process. And along with this, my work integrates life cycle assessment with digital tools such as machine learning to reduce environmental impact and also support circular bioeconomy. And I'm particularly excited about this program because Germany is a global leader in LCA-driven sustainability and environmental biotechnology, which perfectly aligns with my objectives for greener innovation. So let's build a smarter, greener future together. Thank you so much.
What would it say? My name is Shaula Adelusi, and in my doctoral project, I'm redefining the story of waste. In my study of waste torrefaction, I spend a lot of time in the lab experimenting on different waste fractions. This has given me a deeper insight into the complexities of mixed waste and also into the limitation of current conversion processes for mixed waste. This motivated me to incorporate modeling and computation for predicting chemical conversion processes, specifically for mixed waste. So, I'm applying for the Digital Green Talents program because it fits right at the center of my project. That is applying digitalization, in this case, modeling and machine learning for advancing sustainable energy creation. I leverage every opportunity to advance sustainable waste-to-energy technologies. I see this program as a platform to sharpen my skills further and scale the impact of my work. Thank you very much.
All right, for waste and plastics candidates, yeah. So our third segment now, we turn to agriculture and transport, and to begin, we'll hear from the chair of Artificial Intelligence in Climate and Environmental Sciences at the Karlsruhe Institute for Technology, Per Novak. His group's work focuses on data science issues in climate science.
So
So, dear awardees, I'm Per Novak, Professor for Artificial Intelligence in Climate and Environmental Science and one of the committee members of this year's Digital Green Talents Awards. And first of all, I would like to offer you my warm and sincere congratulations on this great success. You have gone through an exceptionally competitive selection process. You can be truly proud of this achievement. And I was personally very deeply impressed by the depths and breadth of research you have shown so early on in your careers. And I'm convinced as a result that you will be truly able to make the most of the research opportunities offered here in Germany. May this be in a project in industry or as part of academic research at a university or a research institute. And yeah, as such, I think the next 3 months will certainly and hopefully feel like a fresh start for you, that you will find not just that we are delighted to have you here, but also that you will find new friends and support and inspiration for your own research to make this world more sustainable. And just as a little anecdote, so when I went abroad for a similar research stay, which was also supposed to be 3 or 4 months, it actually turned into more than 10 years eventually, including PhD research and also part of my academic career. And it really shaped how I think about the world and how I go about research and also my personal life. So maybe, even if on a much shorter time scale, because this is certainly the exception, I hope you will make similarly meaningful and transformative experiences during your time here. Now, yeah, I'm sure you will make the most of it, but if you should ever feel lost or have questions about the research landscape, then please feel free to reach out. I will be very happy to help. So as I said, I'm in the southwest of Germany. I might just bump into you eventually. But until then, have a great day at the award ceremony with BMFTR, and might see you. Bye.
And so our talents in this category we'll hear from now: Nicolas Charon from Canada, Phung Le from Vietnam, Sandes Potel from Nepal, and Lukaya Zoroburagi from Benin.
Hello, dear selection committee. Welcome to the Laboratory of Ecology, Health and Animal Production. I'm Lukaya Zoroburagi, a PhD student in agricultural and food technology. I'm working on genomic characterization and digital traceability of indigenous cattle breed with the goal of building a climate resilient breeding programs in Benin Republic. I'm deeply committed to using digital innovation and molecular tools to support sustainable livestock system, preserve genomic diversity, and empower rural communities. As part of this work, an article titled Breeding Practices was developed to guide the foundation of breeding strategies. My ambition is to co-design a user digital traceability platform that integrates genomic, environmental data, and AI. I'm so excited to learn, share, and contribute to a global network of digital green innovators. Thank you for this opportunity.
Hello, my name is Nicolas Charon, and I'm doing my master's at Polytechnique Montréal in civil engineering. I'm currently studying under the supervision of Professor Catherine Morancy, and I'm doing my research on interregional transport in Quebec. I'm studying the demand of transport across a province and also studying the location of inter-regional facilities, such as stations in cities, in order to maximize accessibility to the population. Having had the chance of doing an exchange at TU Berlin a few years ago, I've seen what Germany has to offer in terms of interregional mobility, and I would like to bring some of it back to my home province of Quebec through the exchange program of the Digital Green Leaders. Übrigens, ich kann schon Deutsch, aber dieses Forschungspraktikum wäre auch eine sehr gute Gelegenheit, mein Deutsch zu verbessern. I would like to thank you for taking into account my application, and I am hoping that I'll be able to join some like-minded researchers next summer. Thanks.
Hi, Selections Committee of the Digital Green Talents Award 2025. My name is Phung Le, a master student in Sustainable Urban Development at Vietnamese German University and TU Darmstadt. I am excited to apply for this program to explore how AI and digital simulations can support planning for heat resilience and sustainable cities. And I am currently preparing my master's thesis on thermal comfort and human perceptions in urban green space, an area that connects SDG 11 and SDG 13. And my case study is my hometown, Bình Dương, is one of Vietnam's fastest growing city, and I hope to apply my research to help shape its future sustainably. Why I am early in my research career? So I'm so passionate, curious, and committed to learning. So I see this opportunity as a key step toward a future PhD and contribute to Vietnam's net zero 2050 goals. And now I'm so excited. I'm thrilled at a chance to join Digital GreenTech community. Thanks for watching.
Hi, I'm Sandesh Podi. I'm a PhD student in the Department of Agricultural and Biological Engineering at the University of Illinois Urbana-Champaign. My PhD research is to develop low-cost, open-access, artificial intelligence-driven, site-specific robotic mechanical weeding system for a specialty crop. Prime intent of my research is to reduce the uses of chemicals and agrochemicals uses like herbicides in the farming system. As we all know that those chemicals, it causes the adverse effect in the environment and the biodiversity. So my research helps in reducing those chemical uses in the farming system. Therefore, I'm applying for Digital Green Talent with the hope to collaborate with Germany's leading research institutes and the companies so that I can incorporate some of the German technology in my research so that I can come up with the sustainable solution for this leading agricultural problem in the world. Thank you so much.
All right, a round of applause for this category. So we now move on to the thematic segment energy and turn to an expert in the field of computer science and AI. She has a particular focus on sustainability and the circular economy. Dr. Christiana Ploszniak has worked on AI and computer modeling for over 15 years, and she will greet you with her message now.
Hi everyone, my name is Christiane Ploszniak. I was one of the jury members this year. I was very proud to be part of the jury actually. And I'm sending my greetings here from the Smart Factory lab at DFKI Kaiserslautern. I was really amazed to see all the brilliant applications this year, and actually this gives me hope for our planet. If we set aside the research excellence for a second, what else made this project shine? I can think of a few things. For example, the motivation of the young people that send their applications, their enthusiasm for their projects, and also the innovative ideas that were around when I read all those applications that made me really happy. If I had to give one piece of advice to the people who come here to Germany, I would say come here, be friendly, be open, meet new people, but at the same time, do remember that you've already come a long way. You have had some experience, that's why you won. And if you use this experience and combine it with the new things you see here, you can develop really, really innovative stuff. And this is what makes places like this shine. This is what will make your research stay in Germany shine. So enjoy and keep up the good work.
All right, and now we will hear from the talents from this category: Malcolm Fernandez from Malaysia, Kavanch Salek from Turkey, Omidreza Hadarite Fresh from Iran, and Joel Fuji from Malaysia.
Hi, I'm Joel, a passionate researcher wanting to explore the intersections of artificial intelligence and nanotechnology. My PhD focused on visible light responsive carbon nitride photocatalysts with multifunctional applications for sustainable innovation. In my previous work, we achieved high yields of green energy through photocatalysis. We have also included 3D printed photocatalytic sheet as part of my study in achieving the lab to pilot scale translation. Integrating machine learning can advance catalyst design, reaction kinetics, and reactor optimization, paving the way for an AI-driven green energy ecosystem. Winning the Digital GreenTech Award would be a pivotal step in advancing my vision, leveraging AI to revolutionize catalysis for a sustainable future. I'm excited about the possibilities ahead and eager to contribute to this transformative field.
Hello, I am Kıvanç and I am applying for Digital Green Talents Award and Research Day. I am a final year PhD student in A-Star and Nanyang Technological University, Singapore. I have heard of this program through the School of Materials Science and Engineering. My research focuses on thermoelectric materials. Nowadays, around 60 to 70% of the energy is wasted, and thermoelectric materials can convert this wastage into useful electricity. By doing so, my research directly addresses the 7th of Sustainable Development Goals. However, I believe that the real progress on sustainability comes when we fulfill all the Sustainable Development Goals. And this can be achieved only when the researchers across various fields come together. Therefore, Digital Green Talents Award is an excellent opportunity for me to contribute sustainability for all people in the world. Thank you.
Hello, I am Malcolm Fernandez, a PhD candidate from Malaysia at Heriot-Watt University. My research focuses on using digital tools like Energy Plan and LEAP to model renewable energy transition scenarios of national energy systems towards the future. In my current work, I have modeled renewables and energy storage, such as batteries and pumped hydro, in the Malaysian national energy system towards 2050. I see digital innovation not just as a tool, but as a bridge to connect science, sustainability, and real change. Being part of the Digital Green Talents program will allow me to grow through collaboration, apply new and existing skills that I've learned, and contribute to global solutions for a more sustainable world. Thank you for considering my application, and I'm looking forward to gain knowledge, collaborate, and produce more research output during this program.
Hello, I'm Mohamed Razani, hopefully a future professor. I'm super passionate about sustainability and making electricity greener and available to everyone.
I recently finished my master's in power systems with focus on artificial intelligence, optimization, and renewable energy systems.
For me, transitioning to clean energy isn't just about technology. It's also about connecting people, ideas, and solutions from all over the world. That's exactly why I'm so excited about joining the Digital Green Talents program. I'm excited about making new friends from around the globe who share the same interests. I can't wait to learn, contribute, and connect.
I will comment on the result. I will comment on the result.
All right, a round of applause. So for our final category, we'll hear from Julia Karlitsky from Remondis. She has an academic background in industrial engineering and innovation management, which she uses to help Remondis develop digital and innovative solutions for the environmental services branch. And she will speak to us ahead of our climate change and other topics segment.
Hi, my name is Julia Karlitsky, and I work at the Remondis Innovation Hub. Remondis is one of the leading companies in the field of recycling services and water. I'm very honored to be part of this year's Green Talent jury. As digital services in the circular economy, our day-to-day business, I have been very impressed by the variety of the students' topics using digital tools to overcome sustainability challenges. I hope the selected students will make the most of their time here in Germany, building meaningful connections to help them grow their career during the program, but also beyond, so that they can make a difference. Thank you and all the best.
So our talents in this category, we'll hear from now Karwo Chong from Malaysia, Joshua Demasaka from the Philippines, Benjadid Rashad Sanusi from Benin, and Moazzam Shah Bukhari Syed from Pakistan.
Hi, I am Benjadid Rashad Sanusi from Benin, currently pursuing a research on how artificial intelligence can enhance the customer experience in sustainable tourism in Morocco. My goal is to explore how AI tools like recommendation system and chatbot can help travelers make greener choice while ensuring that local communities are actively included and benefit from the tourism economy. I have worked with UNDP. I have co-founded an initiative using AI for agriculture and also worked for many digital policies. And my goal is to connect digital innovation with environmental responsibility. I believe that Germany is a good place to further this research, and joining the Digital Green Talent Program is a good opportunity for me to learn, to collaborate, and also to build smarter and fairer digital system for the people and the planet. Thank you.
Hi, I'm Josh. I am a civil engineer by practice, but for the past 6 years now, from civil engineering to public policy to AI, I have been exploring the world to understand our climate and disaster risk at different scales. The big question mark of this current research that we do is to know whether countries are making progress in reducing their climate and disaster risk. We would like to use the rich information of our satellite imagery and develop data-driven tools. What we hope in the future is a vision where we have a solid and transparent understanding of our disaster risk, especially for areas where there are still sparse and scarce data. But beyond that, we hope that our research makes a meaningful contribution as to what would be the future of Sendai framework alongside Sustainable Development Goals beyond 2030.
Imagine a world where carbon trading systems are seamlessly connected across the regions, ensuring an efficient and fair transitions into low-carbon economy. Yet, despite the progress in Europe and Australia, developing markets, particularly like ASEAN, are still struggling with carbon pricing and poor liquidity. This is where my passion and expertise come in. Hi, I'm Carl Ward, and my background in green finance, sustainability, and data science equipped me to tackle about this challenge. And my goal is to develop a scalable carbon trading system that not only in Europe and Australia, but reaching out to ASEAN and other developing markets. The global carbon market, as we know, remains fragmented, with significant disparities between established and emerging systems. Many developing regions still lack of infrastructures, financial tools, and regulatory frameworks that make the carbon trading effective.
Hi, I'm Mazam Shabukhari Sayed, a PhD researcher from Technological University Dublin in Ireland. As we all know that SDG implementation monitoring continues to face data quality challenges. Now what this means is that there is data, but the data lacks important descriptions or features of how the data was obtained, what the data is about, and how the value the data represents actually came to the point that it is the real value for people, decision makers, policy makers, scientists to trust it for scientific workflows or any important decisions. My PhD research is tackling this problem by proposing a novel mechanism that helps domain experts in consistently describing their data and putting those important details and features of data, as in what the data is about, how the data was obtained, for the data to be more consistent, reusable, and high in quality, to be trusted by stakeholders.
All right, round of applause. So we've heard from all of our talents now, and we'll move on to the award ceremony part of this segment. I would like to ask Dr. Musta to join me back up on stage, if you don't mind. And just a word. Oh, could I also see the talents actually again on screen so we can see your face? Okay, good. Now I can see you all. So just a word for everyone, both here and online, how this is going to work. We're going to present each talent once more time in alphabetical order. And then Dr. Musna will present you with your certificate, and you could share a word with him. And if you'd like to take a moment then to take a screenshot of you receiving your prize, feel free to. That would be your moment. Yes. So I think that's everything. Shall we get started? All right. Okay. So then I'd first like to call up Adoke Areshola from Nigeria, and could you please unmute yourself so you can talk to Dr. Musna?
Yeah, hello everyone.
So,
once again, my name is Adoke Areshola Adi. I'm a PhD candidate at Arizona State University, and I really appreciate the recognition from Digital GreenTech
through the Digital Green Talent of the Year as one of the top or the youngest scientists in the world. I really appreciate the support, and I would like to give you all in German. Thank you once again.
Thank you, Adegoke. It's a pleasure and sincere congratulations to your part of the winning team, let's say. You're working on biotextiles, a very interesting area, and it's a new developing industry, let's say, not only in Germany, in many countries. So all the best. We're looking forward to meet you in Frankfurt. That's your document. You can see it on the screen, I hope so, and we'll hand it over to you in Frankfurt. Thank you very much, and congratulations, Adegoke.
Yeah, thank you.
So, all right, we'll now call up Shaola Adelusi from Nigeria. Unmute your mic.
Hi, thank you so much. My name is Shaola Adelusi, and I'm a Vanier scholar in Canada at the University of Sherbrooke in Quebec. I'm really glad to have been selected for this program. I think it would be a great opportunity to have this international collaboration within my doctoral project. And I think more importantly, I'm anticipating the future collaborations that would come. I feel like this is the birth of something new for me within my career in collaborating with industries and with institutes around the world. And I think, of course, Germany is the best place to start this. So again, thank you so much for this opportunity, and I cannot wait to get to Germany.
Thank you very much, Ms. Adelusi. And I'm not sure if Germany is the best place to go, but we hope to be a good host for you in the next year. And I was making jokes this moment. You're the second candidate from Nigeria, and I was making jokes. It's very cold, actually. Not very cold. It's simply German winter, so temperatures around 0 degrees. But I realized you're staying actually in Canada, and as you mentioned, you're adapted to much colder climate. And be sure in May it's really nice in Germany. That's your document, that's your certificate, and once again, thank you very much and congratulations.
Thank you.
All right, congratulations. Now I'd like to call up Elprida Agustina from Indonesia so we can present you with your award.
Yeah. Okay.
Hello.
Good afternoon, everyone. Hello. Good afternoon, everyone. Good evening from Indonesia. I'm Elprida from Institut Teknologi Bandung. So I'm deeply honored to be chosen along with my 19 brothers and sisters here from around the world. And thank you for trusting me also to be the part of this global network. Can't wait to see you all next year. Thank you.
Thank you, Elprida, and congratulations to be one of the 20 winners. It's very sympathetic that you speak about brothers and sisters already, about your 19 brothers and sisters in the group, and I guess that's a very good starting point for you to have fun and have an intensive exchange with your colleagues that are all digital talents of this year. Looking forward to see you in Frankfurt. That's your certificate.
Thank you.
Next up, we have Nicolas Charon from Canada.
Yes, hello. My name is Nicolas Charon. I'm a student at Polytechnique Montréal in Quebec. I just wanted to thank the jury for selecting us all for this amazing opportunity in Germany. So thank you all.
Alors, Nicolas, tu sais parler allemand, okay, perfektement. Alors, herzlichen Glückwunsch. Sie sind Digital Green Talent Gewinner 2025. And to switch to English to make it a little bit easier for you, Nicolas. And I hope you can improve your German skills when you're here. And I already realized you had the metro plan. On the back of your video was the metro plan of Berlin, so you can be the guide for your colleagues when you meet here in Berlin. Congratulations, Nicolas.
Merci beaucoup, votre français est très bon.
All right, we'd now like to present to Karwo Chong from Malaysia. Yeah, there we go. Yes. Hello.
Yeah, hi. I'm Kawo. I'm from Malaysia, and I'm incoming of PhD student at University of Kassel. So next year, I'm not only going to do my research stay 3 months at Germany, but I will still continue studying there. So I'm really looking forward. I already have the research host at Kaiserslautern. It's called Sociovatis, a company that located not only in Germany but across the Europe. So yeah, and also looking forward to the summer school for next year.
Congratulations to you to be one of the winner, Cavo, of 2026. I realized you're actually staying in Dublin. So you have a very multinational career already, and when you're coming to Germany, actually when you're coming to Kassel, if I understand correctly, that's not far away from my hometown. It's simply a 1-hour bus ride from my hometown. So I hope all the colleagues behave well and be a good host for you in Kassel. Thank you. Congratulations, Caro.
Next up, we have Josh Dimasaka from the Philippines. Congratulations.
Hello.
Hello, Josh.
Hello, we hear you.
All right, mabuhay from the Philippines. So I'm calling in from the Philippines right now and go back to the UK this January, but really thankful and very thankful for this recognition. It feels great to see everybody so diverse in our community who are so supportive for our own endeavor and in our own work as we shape a better world for everybody. So really can't wait to see everybody next year. And kita kits, so that's Tagalog or Filipino. See you in Germany next year.
Thank you, Josh, and thank you very much. We have to say thank you very much that you were brave enough to send the application in our competition. As we've already mentioned, we had more than 120 applicants, and you are the ones who convinced our reviewers. And I can tell you, you could see from the videos in the last minutes, you could see the reviewers there. They were very critical, but very fair, and be sure it gives us confidence that we selected the right people for our Digital Green Talent Program. Looking forward to see you in Germany. Bye.
So I'd now like to congratulate Malcolm Isaac Fernandez from Malaysia on being one of our talents this year.
A very good day to everyone. I'm Malcolm and I'm from Malaysia. I've just completed my PhD in engineering, and my focus is mainly on energy systems modeling. So I look forward to collaborate my research in a university in Germany, which has a similar field in energy systems. And I also like to congratulate all the awardees for receiving this award, and I look forward to meeting all of you potentially during the summer school next year. Thank you.
Congratulations, Malcolm, and our best regards from Berlin. Working in energy systems, there are a lot of researchers working on energy systems in Germany and around the world, and it's far from simple to find the right level of complexity and the right methods to make a more sustainable energy future. And we all know that energy is a key if we want to solve our climate change problems. And so we are very happy to hear your ideas when you come to Germany. Thank you very much, Malcolm.
Thank you.
Next up, we'd like to congratulate Joel Fuji, also from Malaysia. So, hi, Joel.
Hi. A very good afternoon, everyone. I'm honored to be part of the Green Talent community and grateful to the Federal Ministry of Education and Research for this recognition. I would like to acknowledge the support coming from my supervisor, Professor Ong Lee Jun. I also like to thank God for guiding me on this journey. My work focuses on the advancing clean energy material with the aim of making renewable energy more efficient and accessible. I look forward to learn from all of you and building collaborations that help shape a greener future. Thank you.
Hello, Joel, and congratulations being one of the Digital Green Talents 2026 and to come to Germany. I'm not sure, could you follow the presentations of this morning, the English presentations of the sessions we had? Because you probably realized there were a lot of projects where AI was in the center, so the key technology where everybody works with when it comes to waste treatment, water management, and all the things. And your contribution and your approach to AI will be a valuable contribution in the context of what we are doing here. Thank you very much.
I'm looking forward.
So we now call up Abhinesh Ganapati from India to receive your award.
Hello everyone. Guten Tag. I'm Abhinesh, PhD student from IIT UK, India. And I work in FedEx teams. I very much looking forward to apply advanced digitalization technique for sustainable water management. And I also like to thank Dr. Musner and other people behind this Digital Green Talent program. And I'll be happy to see other fellow Digital Green Talents in Germany following year. Thanks a lot.
Thank you very much, Abhinesh, and you don't have to thank me personally because I'm just doing my job for the ministry, but of course I send you best regards to all the people that work hard in the background to make this program running, like the German Society for Informatics or my colleagues from the Project Management Agency. You're working on water management. That's an issue I'm responsible in our division at the ministry, and I have more programs running on water management than I have on digital green tech, actually. And I know pretty well that you have very different regions in India where the pressure on the water sector is higher or not so high, but water is a big issue and a big challenge in India. We are used to be a water-rich country in Germany, but actually with climate change coming, this is changing. We're feeling a stronger variety in very hot summers and flooding and water extremes. So even in Germany, we have to adapt our water management, and we're looking forward to hear your approaches, how you think you can improve the water management sector in India. Welcome and congratulations.
Thanks.
So we'd now like to speak to Omidreza Herarita Efresh to present you with your award.
Hello everyone, I'm Omidreza Herarita Efresh, a PhD student from Sharif University of Technology, actually winning an academic award from one of the most innovative countries in the world. Validates my academic journey, and I'm so happy, I'm so glad, and also so much grateful for this given opportunity. And last but not the least, I would like to thank my family because of supporting me down this road. They were always been supporting for me, and I can't wait to learn, contribute, and connect.
Thank you very much. I forget, I can't pronounce your name correctly, but please send best regards from us here in the room and from the ministry to your families. It's very sympathetic that you mention it. And you said Germany is one of the innovative countries of the world. I'm not so sure about it, but we are struggling hard to perform well. And we're looking forward to your ideas because you're working on smart grids, if I remember correctly. And despite the fact that a lot of people in Germany working on doing a real smart grid in our energy infrastructure, we haven't succeeded yet, and maybe your idea will be the game changer in developing smart energy grids. See you soon. Bye-bye.
So now we invite Nilesh Kumar from India to turn on your mic and receive your award and exchange a few words.
Hello everyone. So myself Nilesh, a PhD student at IIT Madras, working on a project which is related to plastic valorization. So I thank you everyone for this Digital Green Talent Award, and I'm grateful to be a part of this community and to drive sustainability and innovation forward. And I'm also looking forward to meet you all at summer school in Frankfurt. So see you soon.
Thank you very much, Nilesh. Congratulations from our side to your award. With your work, you're tackling one of the most complicated, let's say, waste streams when it comes to plastic. We all know there's a lot of political attention even on the issue of microplastic in our oceans and the microplastic that we have on our continents that's washed into the oceans. And actually 2-3 years ago, we had a dedicated program to microplastic running in our ministry, and maybe you can tap on it when you come to Germany and see what we've achieved or not achieved, because the big problems are not solved yet in microplastics. Thanks again, and welcome in your start in the new digital green talent career.
So I'm happy to now present Phung Le from Vietnam to receive her award.
Guten Tag und hallo aus Vietnam. Ich heiße Phương, Master Student in Nachhaltigkeit Stadtentwicklung. For young researchers on a journey of my self-discovery and research practice toward sustainable development, especially in the field of urban climate resilience. I'm very honored to be a part of Digital Green Talents and so excited to come to summer school this June with everyone, and together we create new ideas and make positive contributions to our organizations. Thanks all. Vielen Dank und auf Wiedersehen.
Fung, herzlichen Glückwunsch. So I can stop moderating in English and we can speak German. As you, I see from your CV that you was working on the German-Vietnamese University, so a long-standing research infrastructure between our two countries, Vietnam and Germany. And if I remember correctly, you have been in Darmstadt before, is it correct? And when you come in summer, you will stay at Darmstadt to enhance the collaboration and go a step forward with the TU Darmstadt, correct?
Yeah.
All the best to you, and have a safe journey when you're coming to Germany. Thank you, Fong.
So we now ask Sandas Podal from Nepal to unmute yourself and receive your award.
Hello, I'm Sandas Podal. I'm currently pursuing my PhD at the University of Illinois Urbana-Champaign in the United States. I'm originally from Nepal, and I'm truly honored to receive the Digital Green Talent Award, and I'd like to extend my sincere thanks to the organizers and everyone involved in the Digital Green Talent program for recognizing my work. And also thank you for supporting young researchers and for creating a platform that encourages us to push boundaries and think creatively. Also, I would like to also remember my friends, my family, my current lab at University of Illinois Urbana-Champaign, my PhD advisor, my lab mates, and everyone who were directly and indirectly involved. And they supported me a lot. So thank you once again for this incredible honor. Thank you.
Thank you very much, Sandesh, and congratulations for being part of the winner team of the Digital Green Talents 2026. Just some minutes ago, we were listening to your video where you explained what is your expertise and what are your plan to work in Germany. But if I remember correctly, you was wearing a polo shirt with a brand of a very famous company. I don't know who has seen it, BMW. So have you been connection to BMW, or are you driving a BMW in Illinois? Is it correct? You're actually working in Illinois in the States?
Yes, that's correct. I work in the University of Illinois, but I like BMW personally, but I'm not affiliated with that company.
Okay, it doesn't matter if it's BMW, Volkswagen, or a foreign brand. You're more than welcome in Germany next summer.
Thank you so much.
Bye. See you.
So we now speak with Kavanch Salik from Turkey to receive the award.
Hello, I'm from Nanyang Technological University, Singapore, and I'm a PhD candidate in material science and engineering. I am very happy to be selected as a Digital Green Talent awardee, and I'm very excited now, as you can see. So I'm looking forward to be in Germany in summer school next year, and I'm looking forward to contribute to sustainability through my research in thermoelectrics, and I congratulate all other awardees. Thanks again.
Thank you, Kivanch, and congratulations to be one of the award winners of the Digital Green Talents competition. We invite you to Germany, but it's hard for us to compete with Singapore because you're just staying in Singapore, and in your video we could see very fancy research buildings. I guess it was a research building on the left side. So your host institution, you know already it's a company or it's in your university. Where do you want to go in Germany?
I'm considering institution.
In a research institution?
Yeah.
So you can come. Okay, so when you go back to Singapore or Turkey, you can compare where the best research facility is, if it's Germany, Singapore, or is it Turkey. Looking forward to meet you next summer in Germany. Congratulations again.
Thank you.
So now we're happy to call up Benjarid Rashad Sanusi from Benin to receive the award.
Thank you. I am from Benin, but based in Morocco. PhD candidate at the Euromed University of Fes in Morocco, where I am researching on the impact of artificial intelligence in sustainable tourism. And thank you so much for selecting me. I am so grateful for this recognition. And this award reinforced my dedication to leveraging digital innovation for sustainability and supporting communities that need it most. And thank you for the jury, the program team, my supervisor, my family, and everyone supporting this journey. Congrats to you all, and I can't wait to see you all.
Sanusi, congratulations to your award-winning approach here. You're an excellent example that it worth to try twice. Because I know from our statistics or from our data, let's say, that you sent an application already last year, and last year it was on the short list, I can guarantee you. When you're in Germany, I tell you the positions that you had last year, but this year you made it, and you were one of the top 20 candidates, and you're a testimonial that it's worth to try a second time or maybe a third time to be awardee here. And see, it's this way. You nearly made it up halfway, from Benin to Morocco and from Morocco to Germany. It's more or less halfway, I would say. Looking forward to see you. Bye.
So I'd now like to call up Kelsey Shaw from Canada to receive her award.
Hi, thank you. Good morning here from the west coast of Canada. It's very early. But I'm very happy to be here and also to hear about all of my peers and colleagues. This is the first time I also got to watch their videos, so that was really great. And I'm really looking forward to spending time in Germany and meeting with folks there. As I finish my PhD here in Canada, also partnered with a Swiss research institute. So really looking forward. Thank you.
Thank you, Kelsey, and good morning, I have to say, or grüezi, how do you say in Switzerland, because you work close with the Switzerland Institute. In the mornings they say grüezi too, or they have another expression, I don't know by heart.
Yes, yeah, in Swiss German, grüezi.
Grüezi, okay. So you're based in Canada, and as a matter of fact, I have been liaison officer for research collaboration with Canada for 3 years, and I have been several times in Ottawa. You said, where are you based in Canada? In what
I'm in
province?
Victoria.
In
BC,
Victoria.
on the west.
On the West Coast. So probably it's not as cold as already in Alberta or Ontario. So it has a more oceanic climate. So how's the temperature outside now?
Dark.
Okay, temperature dark. Okay, I see. We use a different metric system, obviously. But I'm not worried about it. You will fit perfectly in our program, and we are happy to have you as one of the 20 selected candidates. And looking forward to talk to you in summer in Germany. Thank you for your application, Kelsey.
Thank you very much.
Okay, great. Now we're going to speak with Haley Smith, also from Canada.
Hi, everyone. My name is Haley Smith. I'm also from British Columbia, Canada. I'm doing my PhD, just wrapping it up at University of Victoria. But yeah, thank you so much for the Green Talents Award. So grateful for this opportunity to carry out the research in Germany, but also share my expertise in green chemistry and chemical engineering, but also develop and learn skills while I'm there and network. So thanks again, and looking forward to it.
Thank you, Haley, and congratulations to be one of the winners of the Digital GreenTech Talent competition. When I was watching your video you submitted some hours ago, I expected you to be working in the Canadian or British Columbia tourism industry because you showed such wonderful sketches of the coastline and all what makes the ideal spot for the Germans to think about BC in Canada. But
everyone should visit.
But I have a very sad news for you. You're not yet a digital green talent in 2026. You have to answer one last question. And if you succeed in this last question, then you're really digital green talent. Are you ready for this question?
Yes.
Okay. The question, the federal government Ministry for Research, Technology and Space has for you is, what's the name of your dog?
His name is Mo.
Mo, okay, that's the correct answer. So now you're an official digital green talent. Will you bring Mo with you to Germany, or will he stay with your family or friends?
He'll stay here.
Okay. See you next year.
Awesome, thanks.
So I think we have another Mo now to present. We have Moazzam Shabu Karisiad from Pakistan, who will receive his award.
Good afternoon, everyone. People also call me Mo, by the way. Just the human version. Thanks to the moderator for pronouncing my name correctly. People always struggle pronouncing my name well, but that was a first fine one. I am Moazzam from Pakistan, but I'm currently based in Dublin, Ireland. Trying to wrap up my PhD in the next few months, and then head to Germany for the research stay. It is an absolute pleasure and honor to be with all of the fellow Digital Tech awardees today here and share this space with rest of the fellows there who are joining the ceremony in person, and also to the Federal Ministry who runs this program and all the partners. Special thanks to you guys, and also kudos for pulling a successful event today. So yeah, for you. Thank you so much.
Thank you very much. And I'm quite sure I pronounce it wrongly, and only the moderator pronounced it correctly. So your name is Moazzam.
Oh, you did well.
Okay, that gives me confidence. I like
Thank you so much.
And you're in Dublin currently, is it correct?
Yes.
And you stay in Dublin before you come to Frankfurt to the summer school?
That's right. I'm in my final year. I'm a PhD candidate here. I have a Viva upcoming in a few months. So yeah.
Okay, so I tell you, I'm coming to Dublin early of May, and we meet for a beer in the Temple Bar district, okay? Before you come to
really
Germany,
amazing.
I send you my contact details.
Guinness on me.
Okay, Moazzam, congratulations.
Thank you so much.
Great to have you here.
All right, we'll now speak with Lukaya Zoraburagi from Benin to receive today's prize.
Hello,
Hello,
Lukaya.
everyone.
Bonjour.
Bonjour. Comment allez-vous?
Très bien, et vous?
Merci.
Okay, hi everyone. I'm Lukaya Zoroburagi from Benin. I'm a PhD student in agriculture and food system using digital tools in animals. So I'm happy to be here today, and it's an honor and privilege to be part of this great family of great talents. And I want to thank my husband, Marceline Ataku, who was also a great talent last year and was in poster. Yes, I want to say so because he helped me to apply this great award. So thank you all, and I'm excited to meet you all next year in Frankfurt. So, bye.
Lukaya, congratulations. It's the first time we have Digital Green Talents as some kind of family business. I didn't you. So probably I met last year in Frankfurt your husband, and obviously his experience in Germany was not too bad last year. So he asked you, no, don't send an application again. It's horrible in Germany. So that's good to hear. And thank you very much. And I'm really interested in your research because my grandfathers were cattle farmers, and I know a little bit about this business. Looking forward to hear about your work. Congratulations and bye-bye. See you.
Thank you. Bye.
All right, I believe we have just one last talent to present who is unfortunately not able to be with us today, but we still would like to acknowledge her. We have Supreja Kohli, and I think we have a slide for her. So we see here PhD candidate at the Indian Institute of Technology, Delhi. You all, the people involved in the award will have the chance to meet her this summer, and all of you online as well. So round of applause for her as well. And then, so if we could now get everybody back on screen, let's give a big round of applause for all of our talents. So very interesting to hear from all of you and to see all of your faces. And I think we're going to take a group photo now. Yeah. So everyone fix your hair, make sure, And let's see, I'll hold these up. So we can just.
So before we do the group photo, I like to show you the, let's say, trophies, the green digital. Perfectly. Yes. Everybody is showing his or her certificate. Mm-hmm. So for all of you, I show you this strange trophy of a Monstera plant, but you know it's the icon, the logo of this event. And all of you will get one in Frankfurt. It's easy to demonstrate, and you can bring it in your luggage back home. So you see it's not a problem. And I like to use the opportunity here to thank all our reviewers. You have seen the reviewers on screen, our experts. We trust on our experts to select the best talents, in other words, you. And therefore, we like to give a last applause to our reviewers and to our candidates. Please. Yeah.
So we'll take a few seconds now just to make sure we have the photo.
We have it.
We have it? Okay, all right. Then, great. Then now I just want to say again, congratulations to everyone who joined us from the internet. As for everyone here in the room now, also thank you for being part of the awards ceremony. We will now take a break for coffee, but before that, I'd like to give some information about what's coming up afterward. We will resume at 4 p.m., so you have a break until then, but we will again split into two sessions, one in room Ada here and one in room Conrad. In room Ada, we will be introducing the presentation of selected projects from the Green Tech Innovation Competition of the BMWE, and that will be moderated by Dr. Elena Aminova. And in Room Conrad, we have the networking session, Meet the Green Talents, moderated by Elena Müller from the German Informatics Society, and organized by Maha Denisova and also Ms. Müller. So this is a really interesting session for everyone, especially for PhD students, though, who might be interested in the Green Talents or in the summer school for next year. So or if you know somebody who might be interested in this program, that could be a good session for you. So you can learn about the events and how to apply and connect with talents from previous years. So we'll take a break for coffee now, and after that, please go directly to the room of your choice at 4 p.m. Thank you. Welcome back. I just wanted to, so we'll be starting in here with looking at a few different projects again, but I just wanted to mention that if you're interested in getting to know about the network, learning people that are affiliated with it, that the other room is a great moment to learn about exactly everything that's happening here. So we just wanted to mention that again in case that's something of value or interest to anyone in this room. So to get started here, digital technologies, we all know, are opening new pathways towards a more sustainable economy. That's what we've been talking about all day today, and I don't need to tell you that. From the intelligent use of environmental data to the development of innovative climate-friendly business models. So with the Green Tech Innovation Competition, the Federal Ministry of Research, Technology and Space supports exactly these pioneering efforts, and it's my pleasure to introduce Dr. Elena Aminova, Project Manager at Prognos AG, who will be presenting selected programs. Yeah, thank you.
Thank you for the invitation. My micro is, okay, it goes right now. Thank you for this invitation. Since this summer, we belong to the German Federal Ministry of Research, Technology and Space. Sounds differently now, but formally, initially, we were anchored in the Federal Ministry of Economic Affairs and Climate Change. We are a sister technology program to Digital GreenTech and represent the other side of this community, which is also quite interesting and brilliant. We have 21 German projects in total, complemented by 2 projects from the international cooperation, and we are very broad, and that distinguishes us from all the other projects from our sister technological programs. We represent projects from the brewing business up to the neuromorph chips, from the agriculture up to pumps and wastewater treatments. And I have a pleasure today to introduce 3 selected projects from our technology program. We begin with DICES, which bring us to the market of house appliances, for example, washing machines. And we are trying to introduce the idea of circularity into the product life cycle. We know it as a linear thing, and now we try to rethink it, making notion of how we can reuse some parts, how we can recycle them effectively, how can we measure whether the spare part is still okay or it needs to be managed or maintained more regularly. Kayan, please welcome to the stage. The stage is yours.
All right. Well, let's see this. Okay, thank you very much. I will try this one. Yeah, now I can hold myself. Good evening. My name is Kayan Kandia. Today, I am actually filling in for a colleague of mine who's got ill with the flu yesterday. So he's from the DICES project, but I'm coming from the ZAAD project, which my colleague Stefan will also explain to you guys later on. Today, for me, it's about sharing the passion that I share with the colleague that is at home with the flu. So let's dive right into DICES. Title is about digital transformation of circular economy for industrial sustainability. And we will talk about 3 major pillars in this project. One of it is the integrated value creation system that we use for the circular economy. The other one will be a data-based AI-aware model to assess when failures will occur on components. And the third one will be like a data-based decision model where we can evaluate which kind of remanufacturing or recycling, so re-X strategies will be applied sensibly in the situation. DICE started with a problem description where we said, okay, usually the value creation in production companies is quite linear. Elena already explained this problem, and so we don't find great implementations of circular business models in production as well. And the solution was to create a database integrated value creation system for a multidimensional circular economy. In this example, for the household appliance industry, for me, these words are a bit more bigger, so let's get a bit more concrete on what we are talking about. So actually, you will see the typical life cycle in which we think about products. So we have a development cycle, a production cycle, and the use cycle. And this project aims to change in different aspects that we know in the linear value creation system, different elements so we can implement circularity. So starting in, for example, by having a building block in the development cycle where we talk about the sustainable configuration of product or new products. This will move on, and we will talk about different things that are in the order processing, for example. So let's talk about the product that we produce. So it will go through the value chain, we produce it as we know it. So there we have to think about a new way to include reparations on the same factory layout or remanufacturing lines that are not there today. And then we use the product, learn from it, and based on the new decision assistance where we assess the perfect re-X strategy, you will then be able to know, okay, how far back in the value creation you have to go. All right, if we want to remanufacture, we go right at the corner of the development cycle and production cycle and use different production lines to upgrade this product again, or we use other strategies, and this all needs a data backbone at the end. So the other building block is the database AI web prediction model. It's quite typical to other predictive maintenance cases that we already know, where we have the building block on how we use a certain type of algorithms to assess a condition of a component. So in this case, for this household appliance, we have dynamic data and static data. Dynamic data would be, okay, how often was it used, the operating hours, what's like the water hardness that was used, and we have static information typically that you find in a production SME that are around like what is the bill of material, what is the load limit that is put in there, or what are other empirical values that we can think about. And here in this slide, there's then the big AI processing part. So at that point, I am also not very much able to tell you guys which model they use. But at the end, and this is a demonstrator that you can also then, if you get in contact with us, see how it works. You get different wear models for this household appliance. So you see how is the mechanical wear, how's the thermic wear. Appliance maker has a big transparency on what is the actual condition, and at the end you will get the component wear, or you get the wear levels on component level as a feedback out of this model. So now we know from the components that are in our household appliance which is now critical in the wear, which can run for longer or not, and then we move on and go to the next step where this project should head. To have a development of a decision model. The decision model's aim is to find the perfect RE-X route for your household appliance. The idea is, if you have as an input measure the components and the wear levels, we are now able to, with other factors like what's like the cost of CO2, to think about different routes, how we can how we can re-X something. So could be refurbishment, could be a heavy refurbishment, could be remanufacturing, and so on. So we will assess it on the economic scale. So what's the cost that I will get as a maker of this home appliance to maybe make a refurbishment or make a remanufacturing? So typically, intuitively, the remanufacturing is a bit more expensive. Then we can go and then assess, okay, how much CO2 will we emit by choosing one of these RE-X alternatives? So, for example, a refurbishment way would be less CO2 heavy than a remanufacturing way. And then combined with economical dimensions such as the cost of CO2, we will then be able to give you like a decision model where you see, okay, when I choose a refurbishment light, it's at the end we will have this kind of economical cost. When we will go for a remanufacturing route, for example, it's maybe then less expensive, and then you can do a economical decision on which recycling route you will use. And the idea is at the end that the appliance maker is able to give you a suggestion on how to move forward with this home appliance when it gets back. So this is a part where we talk about circular economy getting real. So right now the project is running with Miele, some partner institutes of us. We have Kamen and some other companies such as the All for One group. And the information that I got is the project will now run for like about 8 months now. Is still left on the project. So if you want to get in touch with this ecosystem, feel free to join the next partner meeting that will be held at Miele in Gütersloh at the business unit for laundry appliances. And there you can really get in touch with such enthusiasts like me or my colleague and talk about circular economy and explicitly about business models. Please feel free to enter this invitation, and thank you very much. Get in touch with me, but if you want to get in touch about the project, I can provide you the data about Antoine, who will be the project leader for that, but I'm very happy to answer questions later on as well, guys. Thank you very much.
Okay, thank you, Kayan. Let's move on. Our next project brings innovation to the field, this time literally. They use smart sensors and software-based solution in order to plan and then do mixed cropping. And not only they do that, but they also use the AI solutions and software-based solutions in order to sort out the crops later on, so that in the end you have a market solution which can be scaled up and is sustainable as such. Please, Stefan Saravinsky.
Hi everybody, I'm the colleague from Kayan and I will present you the research project SAAT. It stands for Sustainable Agriculture through Artificial Intelligence and Digital Technologies. So what is it's all about? We are facing an initial problem in the agriculture sector, and it's based on the monoculture. All farmers are using it, but it's quite heavy. There's quite a problem. It produces a lot of, or causes high CO2 emissions, and as well high fertilizer and pesticides usage, which then is going into soil disruption and as well as biodiversity loss, and initially then species extinction. But there is also more. The farmers are also facing more problems, like they need more, or there's a need for climate resilient fields, and there are also coming new regulatory frameworks like the European Green Deal, as well as the German government strategy, which they are also facing. So there are a lot of problems right now for the farmers and for the industry. So there is a need for change. This change could be, or one alternative is mixed cropping. Because why mixed cropping? Studies are showing that with using mixed cropping, they can increase yields by 3 to 46%, but also reduce fertilizer, and with that they can have, or they have, economical benefits, so the farmers, but also ecological benefits, like increasing again the biodiversity, but also the carbon storage. So why, if the benefits are so quite good, why we're not all in the farmer industry are not using mixed cropping? Because it's quite complex. Because on scaling it up, we need a lot of data, we need data-driven decisions, and for really being practical, it's quite complex. So on the left, we see that's normally what farmers are doing right now. They're having one crop on one field, or one block of the field. They can also already use an other layout, like an A-B layout, so a strip cultivation with 2 crops. But normally this is still linear, so we went a little bit further and used to try new patterns with a reinforcement learning algorithm, which is then trying to find the best suitable crop, mixed crop for the layout and for the field. So that's one thing we are doing in that project, as well as the second complex thing is harvesting a mixed cropped field, which is also quite complex. We there use automated harvesting technique to harvest, to detect and sort the different crops on the field. We use their computer vision, and that makes it quite focused on harvesting mixed cropped fields. So I want to show you a little bit how our current state is right now. Basically, in the field planning tool, we were focusing on 2 things. First of all, we wanted to implement a user-friendly user interface for farmers, so it should be low barrier or low entry technique. It's quite intuitive, so the menu structure is not that difficult. It's easy to find models, and it's easy to use right away. On the right side, you can see the creating field plots. You can use for global and local restriction, which are then field parameters which the farmers can put in, and we're using it later on in the reinforcement learning algorithm. There is our core functionality on the left side. We are planning with reinforcement learning the best or the optimal mixed crop layout for the field, which he's giving us the input data like field size and soil type, and we are then figuring out with our reinforcement learning tool which could be the best option. We also included a large language model, which then is also explaining the farmer why that option is the best suitable right now for his field. And also he can give us feedback, so the farmers are included also in the tool, so we use the feedback to retrain our model. And on the right side, you can see what the farmer is then seeing. It's also planning when he has to plant it or harvest it, the different crops in the season and in the years. And on the right side, you can also see the AI explanation, why it's so beneficial, also focusing on economical but also ecological benefits for the mixed cropping or mixed cropped planning. So to give you a short outlook what we are now going to do, we now want to optimize our AI approach to have a better performance, but also we want to give the field planning tool to actual potential users, so farmers, to get their feedback and also implement the feedback to optimize it even more. Thank you. That was it from my side. If you have questions later on, you can feel free to ask.
Last but not least, our third project comes from the waste, water and pump solutions. They use smart sensors in order to perform smart maintenance and scale up not only the waste water treatment infrastructure, but also measure the performance of the pumps and contribute to the sustainability of the whole infrastructure at scale. And you can see already that in our technological program, all the projects deal with digitalization. They use the solutions that go through digitalizations or with digitalizations, or they measure the sustainability effects with digital tools in order to contribute to the twin transition, not only the digital transition, but also to the green transition. Please welcome on the stage Dr. Carsten Wendt.
Okay, here it is. So, hi everybody, welcome from my side. As already said, my name is Carsten Wendt, and I'm delighted to present our project WIP Fluid here today. It's a Digital GreenTech Konferenz. So first of all, I would like to state our mission. So basically, it consists of 3 core objectives, which are to maximize the uptime of industrial machinery. Second, to minimize their resource consumption. And finally, to extend the overall machine and equipment lifetime. And all of this should serve for a greater goal, namely for more greener and more efficient and more sustainable industrial landscape. So to understand why this is important, we should have a look at the current situation. So industrial machines operate usually in quite demanding environments. So for example, pumps or waste pumps. They are faced with high mechanical loads or chemical contaminations or other hard conditions like very high or very low temperatures. These circumstances leads to failures. To predict when these failures exactly occur is quite difficult, it's quite hard. And that's why the machine operators are faced with sudden and sometimes quite long downtimes, which demand for reactive maintenance, which could also be costly. All of this is annoying, it's expensive, and sometimes also dangerous. And the reasons behind these problems are built up quite unnoticed because we cannot open the machines, we cannot monitor the different parts. And also existing monitoring solutions are not very good at detect and predict these reasons or these prognostic states. So here we brought you some pictures from our partners, so some real life photos, and you can see the effects of hidden corrosion and abrasion and cavitation and so on. And you can see they cause quite severe damage at different parts of the machines. And based on this, it's quite easy to understand why this is really a problem. To abstract this, we could state that machine operators are faced with unexpected breakdowns, which cause high unplanned costs and can also increase the actual operational risks. That means that every hour of unplanned downtime can cost thousands or maybe 10,000 of euros, which is more or less equivalent to high resource and energy consumption. Maintenance and repair activities are sometimes quite inefficient. If they are performed too early, you simply replace working parts of the machine, so the remaining lifetime of the components is simply wasted. If it is performed too late, then we run into this already mentioned failure state, where the damage is already escalated to a critical level. The reason behind this is we do not have enough precise diagnostic data. And because of this, we cannot track down the actual problem and do proper analysis to handle this. Some of you would maybe say now, okay, let's use modern database technology. We could apply ML maybe for this problem. And here we touch a quite crucial part of modern automatization in general, because machine learning is limited by several factors. So for example, as you already know, we need a lot of data, large data, and we need also high quality of data, which we simply do not have, because the events we are interested in, these severe but seldom failures, are quite rare, are quite seldom. And that's why we have to measure for a long time, we have to collect the data for a long time, which makes the entire endeavor quite expensive. If the data are available, and assuming such monitoring and prediction system exists, it's still complex to integrate them into existing IT landscapes because of the complexity. Yes, and last but not least, we need also a profound domain knowledge from the experts to interpret the data, to annotate the data, to make, to get the machine learning system into a state that they can process the data and make use of it. So now, how do we solve this problem? As you can see here, we developed a layered approach to tackle this. So first of all, the first thing is we do not wait for the data, we create the data. And for that purpose, we set up different test scenarios and set up different test sites with our partners, and there we can simulate predefined error and fault scenarios and collect the data in that way. That means we run different measurement campaigns at the different sites, collect the data about the errors and the faults and also the normal runtime as we need. And then it becomes really interesting, because then we apply modern AI, machine learning technology. First of all, we take our quite lean real-world data and apply generative models to widen the data. So we multiply the errors, we multiply the normal runtime data, we modify it, and in that way we create a quite large and scalable data foundation. Based on this data foundation, we could apply predictive models. So we simply train machine learning models to forecast the data we simulated. And then comes the clue. We do this at different sites. So we have different generative models, and we have different predictive models. And these models we collect and delegate them to the cloud layer. At the cloud layer, we combine all of this utilizing federated learning, and in that way we get a foundation model for this specific use case. This foundation model could be delegated back to the fog level, to the different sites, and there the existing specific models could be improved even further. Also sites with no data and no prediction models at all, there it could help to set up a new machine learning system. We also try to improve the sensor selection and the data selection. So what do we really need for our forecast, for our approach? We try to push the AI towards the edge to lower the energy consumption even further. And in the end, we created an edge fog cloud optimization loop, our system for that, where we collect the data, widen the data, train local models, delegate the local models to a centralized place in the cloud. Create this mentioned foundation model, delegated back to improve in a loop the models at our different sites. So the values we propose in that way are, of course, our first mission state. We try to increase machine uptime through early fault detection and early interventions in time. In that way, we can lower the maintenance and repair costs. I think that's pretty clear. But on the other side, we also created an independent software system based on no legacy software, which is modular, microservice-based, and also technology agnostic, where we can integrate maybe newly published AI technology or machine learning technology without changing the entire system. In that way, we can make the system status quite transparent via dashboards, or we can also provide a direct API access to the forecasted states, providing that way condition monitoring 24/7. And last but not least, this is quite important, data privacy is built in our design. Because we do not exchange data, we do exchange models, which is also much more resource and energy efficient. So the USPs for us from the project are we have our foundation models, we have the resource savings, low integration and setup costs, which hopefully leads to early and high return of invest. We generate the data, we do not wait for them, so we have a very strategic approach here. We combine different machine learning technologies to harden the model, to improve the model, to make them more stable. We built some kind of a crowd-based improvement loop. So that means if we have good models that would attract more users produce more data. With more data, the local models could be retrained, and these local models improve our global foundation model. The privacy respecting ML aspect was already mentioned, and in that way we have a domain independent concept which could be rolled out also to other domains with the help of our partners in research and industries. So now I would like to conclude with the last slide. So what is the current state? We completed the software infrastructure. We can collect the data, process it, store it, and so on. We are now at the actual ML model integration. We focus on more generalized model architectures. And here I have brought you two screenshots. So on the right lower side, you see the forecast of a specific error on the fog level, so at a specific site. And on the right side, you see the foundation model executed or applied on the same level. You see it's not entirely the same, but it's quite similar, and that we take as a proof of concept to perform our next steps. So we would like to improve the actual user interface and yes, develop our approach further towards a scaling product platform. Okay, that's it. Thank you very much for listening.
Thank you. Thank you. Carsten. Now, would you please stay on the stage? I would ask Kajan Kardinach and Stefan Sarawinski on the stage because we are going to arrange a short Q&A session. I might need assistance with a second microphone. Are there any questions? All right, then. I would start. If you were a startup, a question to all of you, would you be profitable? Kajan.
Well, based on the decision-making tool, we should do business positive cases, but if I'm honest, as a startup in Germany in this sector, we still have some groundwork to do with all the uncertainties and transforming the whole supply chain to work in a backwards logic as well takes a lot of steps. So I don't really think that this is possible to do in one startup that will be profitable from the start on. I think this is an effort where we will need a lot of more companies and startups that get involved.
That might be an issue for the politics.
Yes, that was a input.
Okay, thank you. The same to you, Stefan?
I would say the field planning tool maybe could be possibly profitable because it's not that difficult to run. But the initial problem is that mixed crop cultivation is still a side quest. I would say. It's still difficult, it's still too complex. Also, the machinery is not there yet to harvest and to plant it. So that field planning tool is, yes, possible, but the rest is still missing.
Thank you. Carsten?
Okay, from my side, I think, yes, it's possible. So we developed a quite scaling and also a domain-independent approach. Applying AI, of course, is costly, but the question to maintain industrial machines remains. So I think it will remain as a problem, and the question is now, at which point is it worth to apply still such complex AI systems in comparison to the actual costs?
Thank you. Any other questions from the audience?
I have a question to all of you. I liked your answers you gave to the first question, very smart question. Would you be profitable if you're a startup? You, Kaya, you're working with Miele. It's a big company in the sector, I understood. If you don't dare to become a startup, or the team is not daring to become a startup because the prospects to make money are still rather vague, what I understand completely. How is the situation of Miele? Because Miele is a big player on the market and they could buy the idea. They don't have to automatically buy a company, but they could buy the idea and produce something under the brand Miele. What keeps them away from it? Second question is to you. I have two questions. Predictive maintenance, it's a big issue in industry as such, because you described the problem perfectly. It's too early or it's too late. That's a principal problem when you have when you follow the manual, exchange the pump every 3 years or something. So wouldn't it be in the interest of the companies, let's say an SME in Germany that produces water pumps for the world market, to deliver the pumps with predicted maintenance already as a service package, let's say? And why do we have to spend public money in this area when, as a company producing pumps, water pumps with membranes or whatsoever, has a clear competitive advantage when you can sell your pumps with predictive maintenance? So these are my two questions.
Thank you. Kajan?
Well, it's still fresh on my mind, so I'll start with that. It's actually a good question. So working together with Miele, for example, shows actually there are a lot of companies in Germany already doing some kind of remanufacturing or refurbishment or kind of rehauls business models that are typically based in the service sector of the company. So to get a company in this size to start about going so deep into the product development and then reshaping the production layout needs transparency for them to understand that this business case is possible and will make money. Because at the end, the companies usually that we talk about, they will not change to a RE-X strategy just to save the planet. It has to make money at the end. And I think one of the approaches that they took in DICES helps actually to get this kind of transparency, to be able to assess the right refurbishment or remanufacturing or whatever RE-X strategy. So this, for me, is one step for a company to really then get an idea of, okay, maybe this is something that we should focus on and not only do it as a service in the aftermarket then. So, yeah. Or did it answer your question at first? Okay, great.
Okay, then I also try to answer your question. It's a very valid question, thanks. We thought so too, but we made a bit the experience. We have a really nice, I don't know the English word, Sprichwort in German. It's called, was lange hält, bringt uns kein Geld. So it's maybe not a question for the pump producers because they would like to earn money, and yes, it's a business case to sell new pumps, but maybe for the pump operators. So, but on the other side, they are no experts in such industry devices, and the challenge is here to make AI systems so, I would say, cheap or easy to deploy and easy to maintain that it becomes lucrative for the site owner to employ such a system, because they are motivated to set up their pump system in a way that it lasts very long.
Any other questions? Okay, then thank you to all of you. Give a warm round of applause. Before we make a cut, I have a short announcement to all of you. We want the green tech community to evolve, emerge, and grow further on. We have two upcoming events in 2026 from our technology programs. First of all, it is the closing event for the first round of our projects, which will take place on the 24th of March here in Berlin. At the Forum of Digital Technologies in Salzuffa. Back to back to this event, we'll be having the kick-off, the launch of the second round of the project, which will have a clear focus on sustainability, meaning sustainability as a leverage factor for green tech. And this event will take place on the 25th of March. The same venue. I have some flyers with me with QR codes. Please feel free to grab one. I will lay them outside on the table in the foyer. Register yourself, and we'll be happy to reconnect, rejoin, and see you in March. Thank you.
Hi, it's wonderful to see you all, and for sure many people also in the stream, and thank you to all of the talents that are also joining via the Zoom call and on YouTube. So this is for sure a hybrid session that we have here. So welcome everyone. Welcome to our networking session, Meet the Digital Green Talents. My name is Elena, and I'm from the German Informatics Society, where I have been supporting the Digital Green Talents project for a long time already. I'm very happy to see also many colleagues and partners from different organizations here in the audience, and I would like to welcome you all today. I have one question for you in the stream, but also to the people here in the crowd. Who of you has heard about the Digital Green Talents before the award today? I think it's all of us. Yes, that's great. And I assume you also think that the summer school is an amazing idea, right? Yes, great. So at the award earlier, we learned today, of course, who this year's Digital Green Talents are. And hi again if you're watching in the stream. And we also learned who will be coming to Germany next year. In this session, we are excited to look a bit back into last year's award, and we have 2 alumni with us today. Thank you for making it traveling here. We really appreciate it. And you can tell us more about your journey in a second. The 2 people you hear about are PhD students who came from different countries, different disciplines, and also different research contexts. And through the Digital Green Talents Award, they came to Germany and met at the Spring School last year, or this year. And we asked them in preparation for their presentation here, what is it like to conduct their research in an international context? And also, what did they learn and encounter? Before we hear those insights, I wanted to give you an idea about today's agenda. We will first have the alumni insights, then the opportunity for a Q&A, where I have prepared some questions, but also you, the audience, and maybe some people online have the possibility to ask questions to the alumni of the award. And then afterwards, we will have a hybrid networking event where you have the opportunity to not only talk to the alumni here, but also the talents that are online. Lastly, we have a little creative challenge prepared. So if we are interested, stay tuned. We can do this later. So, all right. Before we are moving into the presentations, I wanted to give a little introduction to our first alumni. He's from Belgium, and he is from the KU Leuven. Michiel is focusing in his PhD on local governments and can evaluate the progress and impact of circular economy initiatives. He assesses strategies by developing a circular economy monitor for cities and municipalities. Michiel, you're currently doing your research stay at Leuphana University in Lüneburg, and with that, the stage is all yours. You can use this microphone and this pointer.
Yeah, thanks. Hi, everyone. Thanks for having me again after the spring school. It's been very nice to be back in Germany. I'm actually not traveling from too far today, since I'm in the final week of my research day at Leuphana University in Lüneburg. And I've been asked to provide some information to the next year's talentees about my journey so far and what my research is about, and I would love to connect digitally on if you have any questions, we can explore them together. So my research is towards the development of a circular economy monitors for effective policy making. I'll put it a bit more closer. Who am I? I already introduced myself. I'm Michiel Pauwels. I'm an economist from background who has always been fascinated in this interplay between sustainability and digitalization, and these are often 2 pathways that does not necessarily go hand in hand, since what we currently are seeing with the AI revolution, with the digitalization, is that sustainability is often overlooked, and that we're applying a lot of technologies without critically thinking what is the benefit for society and how can we do this in a more sustainable way. While on the other hand, a lot of sustainability efforts needs digitalization to become more efficient and more effective. So I think this project and program is effectively what is needed to bridge both often parallel concepts in digitalization and sustainability. And in my studies as an economist, has always been fascinating in both concepts. And in my PhD at the KU Leuven and at VITO, which is the Flemish Applied Research Institute, I try to connect both. And because of the Digital Green Talent, I got the opportunity to spend the fall semester here at Leuphana University in Lüneburg, which I will talk a little bit more on later. They always say it's more important who you know than what you know. I'm not sure whether that's the case as a PhD researcher, since you're supposed to become an expert in a certain kind of field. But I would like to argue that being a researcher is also being embedded in an academic social network. And by going through conferences, talking with colleagues, you actually realize that might be a sobering or frustrating thought that the ideas you're having or the pathways that you're on are not the only ones who are confronting these challenges, since research doesn't stay within the boundaries of your country or within your research group. And that's why I'm very grateful to learn more about the German research context and explore the initiatives and research projects specifically at Leuphana University. And just as knowledge doesn't stop at boundaries, the flows of materials and products also transcend boundaries, and that's especially where we in the circular economy are thinking of and trying to tackle. Since in our current linear economy, our flows of materials and products are quite inefficient, which causes a lot of waste and environmental degradations and harm. And in the circular economy, we would like to try to change this narrative and this economic system by different strategies like reuse and repair, by keeping products and materials longer in the economy. And in the end, it's a societal transition towards sustainability. But a societal transition always takes time and never happens in the short term. And the same is true with concepts like digitalization and sustainability. And in my research, I'm trying to harvest the benefits of both concepts and seeing how circular economy can be accelerated at the local scale for local governments. And when I talk about a local context, I'm talking about the region of Flanders in Belgium and Flemish municipalities. We don't have as big cities as Berlin or Hamburg, where I'm currently living, but the research, I think, is quite generalizable in the sense that it's becoming a political topic high on the agenda of different European, national and regional governments, the circular economy. And the region of Flanders started 3-4 years ago with the idea, if we want to embed a circular economy in the future of the Flemish policy landscape, we need accurate data, we need new indicators to guide us towards this transition. Since traditional economic indicators like GDP growth, while useful for measuring some things, remain silent for a lot of important things that are considered as well-being. And that's why in our research group we developed a circular economy monitor for Flanders, where we try to conceptualize and quantify different flows, different indicators, and together, it's an online publicly available website, we try to tell the story how circular is Flanders now in reality. But we also came to the conclusion that by just harvesting data sources and building indicators, we're actually not there yet, since we need to understand how policymakers are making their decisions and how digital tools can support and help them in their decision-making process. And many challenges exist, which I'm also currently facing in Leuphana University in Lunenburg, where they do this very interesting and impactful research of scaling down planetary boundaries to the local ecosystem and seeing how can indicators be useful for households and policymakers to stay within the planetary boundaries and having a more just transition towards sustainability. And in this way, the challenges that we're talking about are the same. What kind of information do different actors need to nudge and pursue a more circular lifestyles? And how can we inform these behavioral changes to policymakers to make the necessary changes in the policy landscape? I only had 7 minutes, so I'm not sure how I'm doing on the time. But it's just a brief wrap-up slide on my research agenda. So the questions that I'm looking into here in my home university in Leuven, but also at Leuphana, is What kind of information do governments need for the circular economy transition? How do they make their decisions? What is the policy cycle? Which information do they need at which stages of their decision-making trajectory? So it's really trying to understand the information requirements of different governmental actors. Once we know how to intervene and which kind of information they need, it's time to go to the field and to collect data, to calculate and develop new indicators that can be accessible, but also useful for gaining new insights. Like examples are carbon footprints, material flow analysis of urban systems that can spark some interest in the political landscape of, we are not aware that actually textile waste was such a big problem in our city. How can we intervene in there? And finally, and that's maybe the most digitalization part in my research, how can information systems, these online platforms like monitoring systems, be designed such that they're more effectively in the usability of local governments or other urban actors? What kind of design requirements, how can they be embedded in the design process, and how can they be used for policymakers in more effective ways? So these are some of the questions that I'm currently researching. I haven't mentioned this actually. I'm in my third year of research, so still have 1.5 years to go. And I'm hopefully at the end of my PhD, thanks to the Digital Green Talent Award, try to find an answer to some of these questions. And if there are any questions, feel free to reach out, or we can discuss them in the Q&A. Thanks.
Thank you so much, Michael. It's really appreciated. As a sign of our appreciation, we also have a little gift for you. So thank you very much. Our second speaker, Abel, is a PhD candidate at Tel Aviv University in Israel. She focused on techno-economic optimization for energy management and smart grids. She focuses more specifically on the development of model and data-driven approaches for optimal planning and control of entities in the distribution grid. And Abel, you have decided to stay in Germany for a whole year, and since you got a second scholarship, we would love to hear about all of this, of course, and congratulations from our side, of course. And yes, please join me on stage to describe your experiences in the Digital Green Talent Award, and maybe to everyone who's watching, Abel specifically said that when she watched the award ceremony, she saw several synergies with the other talents. So yeah, stay tuned for that.
Thank you. So thank you everyone for joining in person and online, and thank you for having me. And thank you for the introduction, Elena. So I'm currently a doctor already, so I finished, thank you. I finished my PhD in Tel Aviv University in Israel in electrical engineering. Both my master's and my bachelor's all were focused on power and energy. So after the Digital Green Talent, I started postdoc with the Technical University of TUM, and basically, what I'm researching are technologies, so like classical optimization algorithms, as well as applied machine learning to solve problems in power grids, for example, optimal planning of legacy assets at the substation level, as well as optimal power flow, as you see here, very non-convex problem. This is only 3 dimensions, but in reality, these problems are of very high dimensions and are very challenging to solve. So we have a lot of challenges to tackle yet. And as I've already researched this topic for the past 8+ years, I feel like now it's becoming more important than ever. When we have the high penetration of renewables, we really need these technologies to make sure that our grid is reliable and safe. So I copied this citation from the Digital Green Talent website because I thought it summarizes very precisely what is the essence of this program. So it is a very unique program which wants to promote the digitalization to promote the digitalization for sustainability in science and society for a 3-month research stay, which we all know, and really focus on the inspiration of you, the awardees, as individuals. So it does not fund research projects, but rather aims to foster individual development. So I really think that this program is very unique. First, in terms of research. So for example, I had the opportunity to do my research stay at FFA, which is an independent research institute in Munich, which was very aligned with the topic that I wanted to research regarding EVs. But they had 80 years of experience and dozens of experts in this field. So this really stands out on the incredible opportunities that you have here in your research stay to find many, many experts in this field that have been researching this topic for years already. And the second component is the summer school. So the summer school was really unique in the sense that it's really focusing on personal enrichment and seeing new places and meeting new people and hearing very interesting lectures about procedures, doing research in Germany, coming into here, so really learning a lot. So I've had different experiences with summer researchers around the world in different programs, but none of them was like the Digital Green Talent. Usually, such summer schools are very focused on a specific topic, so most of the time is invested to lectures on a specific domain, or they are very focused on a specific project. So the participants spent most of the time researching specific research. So this is a very, very important experience, the Digital Green Talent Summer School. Yes, so moving on to PhD studies in Germany. So what I've noticed here is that when you do PhD in Germany, unlike other countries, you really have a lot of power and responsibilities. For example, you have an extended supervision roles. This is not the case in all of the countries, but here in Germany, you can supervise independently bachelor's but also master's students on different, so it would range from internships to seminars to thesis and so on. So you really are expected to lead your own rigorous research process and really define it on a very high level. What do you want to research? How are you going to research? How are you going to measure your research? So it is a very incredible opportunity to do a PhD in Germany if you have the opportunity. And then you also actively participate in the decision-making process. This is true also for the industry here. So I've noticed this both in academia and in industry, that the workers are really taken into consideration when decisions are being made. So PhD usually involves an employment contract, which is linked to a specific project, which is funded by a specific body, and then it means that you will collaborate usually with other universities and other commercial companies. Another route would be a PhD scholarship, but I've noticed that really a lot of PhDs are done with an employment contract. So this really opens a lot of opportunities to network in academia and in the industry. So I've just touched upon the network opportunities here, and the fact that research is being done with commercial companies means also that a lot of the time you really do applied research. So you either have access to real data or you actually implement pilots on actual sites. So this is really a unique property of research in Germany as well. And it really also opens doors for entrepreneurship opportunities. So there are a lot of programs in universities on how to start up your own companies. And for example, during my Digital Green Talent research stay, I have presented my research to the professor, and he said, you know what, maybe this could be a good company. And, you know, I didn't think about beyond research, but here this mindset is really strong, understanding how you can commercialize things that you start when you do research. So, and lastly, the last point would be the incredible resources that are existing here for everything. So one very good resource would be to subscribe to newsletters, and there are newsletters from different communities, from different bodies, different institutions, and you can really learn about a lot of funding opportunities and events and new programs. I've learned about the Digital GreenTech from a newsletter, I believe. So, yeah, I really recommend it. And also there is a lot of per institution documentation. So TUM, for example, has it, but I'm sure other universities here as well have a lot of documentations on any topic that you would want assistance with. So I really encourage you to, if you have a question, look at it on the university website. You'll probably find it. Variety of networks. So really, I mentioned it briefly, but I've noticed that there are networks per region, per organized group. So, for example, you can have a network for the Bavaria area with any specific country, maybe where you are from, and there is a network for your specific research topic in your specific area in Germany. So there are really a lot of networks that you could be a part of, and is really recommended. And lastly, there are really a lot of interactive content that you can be involved in. So a lot of workshops and talks where you can learn about any topic that you would want. So usually these programs are facilitated within universities and other organizations, and I really encourage you to participate in such ongoing regular events. So if you have any questions, feel free to reach out. This is my email. Yeah, and I hope you have a great experience with the Digital GreenTech program as I did. Thank you.
Okay, thank you so much, Abel. Also, we really appreciate all of the good advice that you gave the new talents about how they can make the best out of their experience. Of course, also, we would love to thank you for your contribution and for your time. It's really appreciated. Yes.
Say a few words to the gift that you received. We did like an extensive research survey about which tea is the best. So we got you the best peppermint.
Yes, I hope, or we hope you will enjoy it. So I think maybe it's easiest if I ask you some question. Maybe we can have 2 microphones up here, or like one. Maybe you can, or yeah. And so I thought maybe, because if the audience has questions, of course, feel free. If not, I have some prepared, and we can maybe start. So how about I start with you, Michiel? I have one question for you. What would you say was one highlight from your research stay at Leuphana University, or also in the program of the Digital GreenTech that you haven't mentioned yet? Like, what would you say is like one highlight that you can share?
It's a cliche answer. There are many, but maybe I would like to zoom in on one in my research stay at Leuphana University. In my research group in Belgium, we are quite disconnected in our different projects, since everyone works on a separate project. And in the research group, I'm embedded now at Leuphana. There are 4 PhD students, 1 supervisor. We're all working on the same project, which is very complementary. And it's really the synergies that is motivating me to contribute to their project as well. And I love that everything is related to each other. So I think, like, what I would like to give as a message, as a researcher, you often have the idea that you stand alone in your PhD journey, and that it's like a mountain that you have to climb on your own. But it's actually more about finding a personal development trajectory and reaching out to like-minded people and finding these people that can support and help you in the research. And I think that's definitely something that I got out of this research day, and I'm very grateful for getting that opportunity.
Thank you so much. That's such a nice thing to share and also so good advice. So basically the same question to you. Is there a moment from the spring school or also your research stay that you are particularly fond of, if you think about it?
Yes, so specifically for me, I think that the mindset, as I've mentioned, the conversation that I had with the people at the Research Institute really made me realize new insights that I didn't have before coming to this experience. So I've mentioned one insight regarding thinking beyond academia, how you can really use your research on actual problems in a real world.
Thank you. And now that I see that also our Zoom call is on screen, I would like to open up the question to the audience. Is there a question from the people in the room or also online that you would like to ask through the two alumni? If not, we can move on with the next part of the session. So, as you can see, we have the awardees of this year here on the screen, and we thought, given the amount of people in the crowd, it's easiest to just merge the two sessions. And so for this, I would like to ask maybe Maya to come up briefly to explain the exact procedures. And so if you want to, you can take a second, and then we will start with the hybrid session of the networking event. Thank you.